Hi guys, welcome to my channel. In this video, I will explain complete C language subject. I will explain all these 5 units and whatever the topics that I am going to cover in this video, I provided all those topics in description. So definitely go and check in description. In upcoming videos, I will cover complete btech CSC related subjects. So please don't forget to like, share and subscribe to my channel. In C language subject, most of the topics are same for all universities. I also provided study material link in description. You can download from there. Let's get started. At first, I will explain Unit 1. This is complete Unit 1 syllabus. I will explain each and every topic in detail. At first, I will explain components of computer. We also call these components of computer as functional units of computer. Before that, let me explain what is computer. Computer is an electronic device that takes input data from input devices and it stores and processes this data and produce output. For example, if you consider keyboard is an input device because by using keyboard we can enter input. So computer is an electronic device that takes input data from input devices like keyboard and then it stores the data and processes the data and produce output. Output is seen in output devices like monitor. We can see output in monitor. So monitor is output device. You need to know difference between data and information. Data is nothing but it is collection of unorganized facts and information mean processed or organized data is known as information. In simple terms, data mean unorganized facts and whereas information mean organized data. Components of computer is divided into two categories. One is hardware and next one is software. Hardware is physical parts of computer like CPU, monitor, mouse, keyboard which we can touch is known as hardware. All these are the examples of hardware devices. Next, what is software? Software provides instructions to computer. That is, it tells computer what to do. And there are two types of softwares. One is system software and next one is application software. Software which is designed for system is known as system software. For example, Windows XP, Windows 10, Linux, all these are examples of system software because the softwares are designed especially for system. And software which are designed for users is known as application software. For example, Photoshop, MS Office, all these are examples of application software because the softwares are designed for users for their personal use. Hardware contains system software like Windows 10 and inside system software we can install application softwares like MS Office, Photoshop, so on. And these application softwares are accessed by user. System software act as interface between hardware and application software and whereas application software act as interface between system software and user. Each and every computer follows 5 basic operations. First one is take input. It is the process of entering data and instructions into computer. I already said before, computer takes input by using input devices like keyboard. And next one is store data. Whatever the data that we entered, this data is stored in our computer so that we can access the data when required, and this data is stored either in RAM or hard disk. Third one is processing data, performing arithmetic and logical operations on data in order to convert this data into useful information is known as processing data. And fourth one is output information, the process of producing useful information or result to user, and we can see this output by using output devices like monitor. Fifth one is control the workflow. All above 4 operations must be done in sequence manner and it is handled by computer. Computer system consists of 3 components. They are, first one is input unit, second one is central processing unit, that is CPU, and third one is output unit. And the central processing unit contains 3 components. They are, first one is control unit, next one is arithmetic and logical unit, and third one is memory unit. This is block diagram for components of computer. We also call this diagram as von Neumann architecture. First one is input unit. This input unit contains input devices such as keyboard, mouse, so on. By using these input devices, we can enter input, and this input unit establish connection between user and system. Next one is CPU. CPU is considered as brain of computer because each and every operation is controlled by CPU and all types of data processing operations are handled by CPU. This CPU itself contains 3 components. On that, first one is control unit. The name itself says control unit. Control unit means whatever the instructions or operations that CPU receives, all these operations are controlled by control unit. Next one is arithmetic and logical unit. Data processing tasks are handled by arithmetic and logical unit. As I already said before, performing arithmetic and logical operations on data in order to convert them into useful information. That is nothing but processing data. Data processing tasks such as performing arithmetical calculations and logical operations are handled by arithmetic and logical unit. And last one is memory unit. Whatever the input that user provide to system, this input is stored in memory unit and as well as output is stored in memory unit. For example, if I give input like 1 plus 2, then this input 1 plus 2 is stored in memory unit and I will get output as 3. This result 3 is stored in this memory unit. Next I will explain types of memory. Memory is very important for each and every system, because if we don't have memory in our system, then we cannot perform even single task in our system. So memory is very essential for each and every system. Computer system contains two types of memory. One is primary memory and next one is secondary memory. At first I will explain what is primary memory. There are two types of primary memory. One is random access memory and next one is read-only memory. At first I will explain what is RAM. RAM stands for random access memory. This RAM is temporary storage, that is whatever the data that is present inside RAM, once we shut down our system, then all this data will be lost. So we call this RAM as temporary storage. There are two types of RAM. One is static RAM and next one is dynamic RAM. At first I will explain what is static RAM. Shortly we call this static RAM as SRAM. In static RAM, data is present until we shut down our system. And next one is dynamic RAM. In dynamic RAM, data is stored in our system very short time. Even though if we do not shut down our system, within short time our data will be lost in dynamic RAM. This static RAM is very costly when compared to dynamic RAM, and this static RAM consumes more power when compared to dynamic RAM. Next I will explain ROM. ROM stands for read-only memory. This is permanent storage, because even though we shut down our system, then data will be present in our system. So we call this ROM as permanent storage. There are three types of ROM. First one is PROM, where PROM stands for programmable read-only memory. In programmable read-only memory, once we copy any data in PROM, then we cannot delete that data. And next one is EPROM, where EPROM stands for erasable programmable read-only memory. Name itself says erasable means once we insert any data in EPROM, we can delete that data and then we can insert new data. And next one is electrically erasable programmable read-only memory. Shortly we call it as EEPROM. In electrically erasable programmable read-only memory, we can delete data by using electric waves. By using special electrical waves, we can delete data within milliseconds in EEPROM. Next I will explain secondary memory. We also call this secondary memory as external memory. Example of secondary memory are CDs, DVDs, pen drives, floppy disks. All these are examples of secondary memory. Next I will explain computer languages. Computer languages are classified into three types. First one is machine level language, second one is assembly language, and third one is high level language. At first I will explain what is machine level language. Language which is understandable only by machines is known as machine level language. We also call this machine level language as low level language. Generally this language is in the form of zeros and ones, so this is not understandable by users. This language is understandable only by machines, and this language was introduced in 1940s. In olden days, that is in 1940s, system understand only machine level language, that is machine can understand only zeros and ones. And second one is assembly language. Language which uses some symbols in order to write program is known as assembly language. Generally this language uses symbols, so we call this language as symbolic language, and this language was introduced in 1950s. Third one is high level language. Language which is understandable by users is known as high level language. Generally this language is in the form of English language. Language which is understandable by users is known as high level language, and language which is understandable by machines is known as machine level language or low level language. What the C program that I written, this C program is in high level language, that is in English language. So computer cannot understand this high level language. So in order to convert this high level language into machine understandable language, that is into low level language, we need translator. The name itself says translator. That means it will translate high level language into low level language. There are two types of translators. One is compiler and next one is interpreter. In C we use compiler. That means, for example, I open Turbo C++ and I written program in Turbo C++, and then I will click on Alt F9. Whenever you click on Alt F9, that means you are compiling your program. Whenever you click on Alt F9, this compiler will convert this high level language program into low level language, that is in the form of zeros and ones. So this is use of compiler. Next one is interpreter. Interpreter also convert high level language into low level language. We use this interpreter in Java. Difference between compiler and interpreter is compiler will convert entire program into low level language at a time, but whereas interpreter will take one line and then it will convert this line into low level language. After compiling this line into low level language, only after that it will go to next line, and then again it will convert this line into low level language. After that it will go to third line, so on. I will explain what is operating system. For example, if any user want to access any hardware components, then definitely you need one operating system in order to access those hardware components. So this operating system act as interface between user and hardware components. Example of operating systems are Windows XP, Windows 10, Linux. All these are examples of operating system. So if any user want to access hardware components, then definitely you need one operating system in order to access those hardware components. For example, if you want to access any software like MS Office or Photoshop or Notepad or any games, then definitely you need one operating system in order to access those software. This diagram, for example, users want to access any software like system software or application software. These both are present in operating system, and this operating system is connected to hardware, and this hardware contains CPU or RAM or any input and output devices. This is diagram. These are some of the important functions of any operating systems. First one is memory management. By using operating system, we can perform memory management, and next we can also perform processor management, device management, file management, and this operating system also provides security, and this operating system is also used to control system performance. These are various functions provided by operating system. These are various types of operating systems. At first I will explain what is batch operating system. The name itself says batch. Batch means group of people. For example, if there are some users perform similar type of job, then whatever the users that perform similar type of job is grouped into one batch. For example, let us consider 3 users, user 1, user 2 and user 3. These 3 users perform similar type of job. So these 3 users are grouped into one batch. In olden days, users write program in punch cards. For example, these 3 users will write some programs in punch cards, and then they will submit these punch cards to computer operator, so that this computer operator will insert these punch cards into system. So in batch operating system, users cannot directly interact with computer. They will just submit punch cards to computer operator, and then this computer operator will insert this punch cards into this system, and then he will perform his task. This is known as batch operating system. What is multitasking or time sharing operating system? For example, let us consider there are different users located in different places, and these users want to access same computer at a time. All these users can access this single computer at a time by using internet, and this is considered as time sharing operating system. I will explain what is real-time operating system. This real-time operating systems will give response within short period of time. Military software system, space software system, all these are examples of real-time operating system. If there is any crime or any bomb blast, then this military operating systems will give immediate response, and similarly if there are any changes in space, then immediately we will get response by using space software systems. These both are examples of real-time operating system. Next, what is mobile operating system? Operating system which is designed especially for mobile is known as mobile operating system. Example, Android, iOS, all these are examples of mobile operating systems because they are especially designed for mobiles. Next, I will explain what is network operating system. This network operating system runs on server. Every software company contains server, and this server contains network operating system, and this network operating system has capability to manage data, manage users, and also it will provide security and other networking functions. This is use of network operating system. Next, I will explain what is distributed operating system. Normally every computer contains only one CPU, but whereas in distributed operating system it contains multiple processors. Processor is nothing but we call CPU as processor. So distributed operating system uses different processors, so that these systems are very fast when compared to other systems. Next topic is numbering system concept in C programming. Numbering system is classified into 4 types. First one is binary number system, second one is octal number system, third one is decimal number system, and fourth one is hexadecimal number system. At first I will explain what is binary number system. Bi mean 2, nary mean digits. Binary number system contains 2 digits. They are 0 and 1. Example, 01101 base 2 is an example of binary number system. We can also call this binary number system as base 2 number system. This binary number system contains only 2 digits. They are 0 and 1. I will give one more example, 01110 base 2. It is also an example of binary number system, 111 base 2. We also call this binary number system as base 2 number system. Next one is octal number system. Octal mean 8. So octal number system contains total 8 digits from 0 to 7. We also call this octal number system as base 8 number system. This is an example of octal number system. Octal number system contains numbers from 0 to 7. So it contains number from 0 to 7, that is 735. These numbers are in between 0 to 7. So we call it as octal number system. Here you need to write base 8. I will give one more example. 3, 5, 6, 7 base 8. Numbers are in between 0 and 7. So we call it as octal number system. Next I will explain decimal number system. Meaning of decimal is 10. So it contains 10 digits from 0 to 9. We also call this decimal number system as base 10 number system. This is an example of decimal number system, contains numbers from 0 to 9, and we represent decimal number system with base 10. I will give one more example of base 10 number system like 998 to base 10. It should contains numbers from 0 to 9. Next I will explain what is hexadecimal number system. Hexa mean 6 and deci mean 10. Total it contains 16 digits. So we also call this hexadecimal number system as base 16 number system. This hexadecimal number system contains numbers from 0 to 9. After that it contains alphabets like A, B, C, D, E, F, where A represent 10, B represent 11, C mean 12, D mean 13, E mean 14 and F mean 15. Total it contains 16 digits from 0 to 15, where 0 to 9 are numbers and A, B, C, D, E, F are alphabets. This is an example of hexadecimal number system FA319 base 16, where base 16 represent hexadecimal number system. For example, 1110. We call it as binary number system because it contains 0 and 1. So we call it as binary number system. For example, 3581. We call it as decimal number system because it contains numbers from 0 to 9. For example, 1117. We call it as octal number system because numbers are in between 0 and 7. A10. We call it as hexadecimal number system because it contains alphabet A. For example, if they give 735 base 10, actually 735. Actually these numbers are in between 0 and 7. So actually it is octal number system. But in question if they give like 735 base 10, then you need to consider this as decimal number system because here they given base 10. Though numbers are in between 0 and 7, if they give base 10, then you need to consider it as a base 10 number system. For example, 125 base 10. This is decimal number. I want to convert this decimal number 125 into binary, octal and hexadecimal. I will explain this by using calc. At first you need to click on mode. Here you can see options. Here you need to select base n. So click on 4. Here by default it will show decimal. Here you need to enter your number. Here number is 125. So I am entering here 125. Place is equal to. Here you can see number 125. Now I want to convert this 125 into binary. Here you can see option binary. BIN. So click on it. So this is result. This is how we convert decimal number into binary. So answer is, don't count zeros, count from 1. 1 is from here now. So right here 1 1 1 1 1 0 1. If I convert this decimal number into binary, this is result. If you want to convert this into octal, just here you can see option octal. Here you can see octal. Just click on it. So if you convert decimal number 125 into octal, then you will get answer as 175. So if you convert this decimal number 125 into octal, result is 175. If you want to convert this 125 into hexadecimal, then just click here. Here you can see hexadecimal button. Just click on it. Answer is 7D. This is how we convert decimal number into binary, octal and hexadecimal. For example, I want to convert binary number into decimal, octal and hexadecimal. Let binary number be 101101. I want to convert this number into decimal, octal and hexadecimal. So at first you need to click on mode. Here you can see option that is base n. So click on 4. Here by default it will show decimal. But I want to convert binary number into decimal. So here you need to select binary. Here you can see option binary. Click on it. So now it will show binary. Enter binary number that is 101101 and press is equal to. Here you can see number 1011101. Now I want to convert this binary number into decimal. Here you can see option decimal. So click on it. So answer is 93. So similarly, I want to convert this binary number into octal. So just click on octal. Here you can see option octal. Click on it. So answer is 135. If you want to convert this binary number into hexadecimal, here you can see hexadecimal button. Just click on it. Answer is 5D. This is how we convert a binary number into decimal, octal and hexadecimal. For example, I want to convert octal number 125 into binary, decimal and hexadecimal. So here at first you need to click on mode and here select option 4 that is base n. Here by default you will see decimal, but I want to convert octal number. So here select octal. Here you can see option octal. Click on it and enter number that is 125 and press is equal to. So now you can see here octal number 125. just click on binary in order to convert this octal number into binary. So just click on binary. This is answer. That is, guys, don't count zeros, count from 1. That is 1 0 1 0 1 0 1. And if you want to convert this octal number 125 into decimal, then just click decimal button. You can see here, click on it. So answer is 85. And if you want to convert this octal number into hexadecimal, then just click on hexadecimal button. You can see here, click on it. Answer is 55. This is how we convert octal number into binary, decimal and hexadecimal. Next I will explain how to convert hexadecimal value A into decimal, binary and octal. First click on mode, select option 4, that is base n. Here by default you will see decimal. Here you need to select hexadecimal because you want to convert hexadecimal number. So click on hexadecimal. Here you can see alphabets A, B, C, D, E, F, where A mean 10, B mean 11, C mean 12, D mean 13, E mean 14 and F mean 15. Here you can see alphabets from A to F. Here I want to convert this hexadecimal number A. Here you can see A. Click on it and press is equal to. So here you can see hexadecimal number A. Now I want to convert this hexadecimal number A into decimal. So just click on decimal. Answer is 10. And if you want to convert this hexadecimal number into binary, then just click on binary. Answer is 1010. And if you want to convert this into octal, then just click on octal. Here you can see octal. Click on it. Answer is 12. This is how we convert hexadecimal number into decimal, binary and octal. Next topic is Introduction to C programming. In this video, I will cover complete C basics. What are header files? What is main function? Difference between int main and void main. Printf, scanf. What are variables, data types and format specifiers. In this video, I will cover all these topics. C is a programming language developed by Dennis Ritchie in the year 1972. The C language was developed by Dennis Ritchie. He is one of the famous computer scientists. He developed C language in the year 1972 at AT and T Bell laboratories. This AT and T Bell laboratories are one of the famous laboratories located in USA, where AT stands for American Telephone and T stands for Telegraph. This is history of C language. At first in the year 1960, Algol 60 was introduced. After that, updated version of this Algol 60 is CPL, where CPL stands for Combined Programming Language. It was introduced in the year 1963. Updated version of this CPL is BCPL, where BCPL stands for Basic Combined Programming Language. It was introduced in the year 1967. Updated version of this BCPL is B language. It was introduced in the year 1969. After that, updated version of this B language is C language. It was introduced in the year 1972. This is history of C language. BCPL was developed by Martin Richards and B language was developed by K.L. Thomas and C language was developed by Dennis Ritchie. We can also call this C language as system programming language because by using C language we can develop various kinds of system softwares like operating system. Most of the Unix and Linux operating system is developed by using C language. C is case sensitive language. For example, if you consider small a and capital A, both are not same. It will treat capital A and small a differently. This is meaning of case sensitive language. C is also a robust language because by using C language, we can develop complex programs. So we call this C language as robust language. We can also call this C language as middle level language because C has capability to understand both low level language and as well as high level language. So we call this C language as middle level language. C also supports portability. Portability means, for example, if I write program in one system, if I write C program in one system, simply I can copy this program and I can run this program in another system. This is meaning of portability. You can write program once and you can copy that program into various systems. Now I will explain first C program by using print function. At first you need to write hash include stdio.h. You need to write hash include open angle bracket stdio.h, where stdio.h stands for standard input output header file. Meaning of printf and scanf is present in stdio.h header file. So for each and every program we use printf. So by default you need to write hash include stdio.h starting. After that you need to write void main. We call it as main function. Whatever the code that you write inside this main function, this code will be executed. So write here void main, open curly bracket, and inside this you need to write printf, where printf stands for print function, open bracket, open double quotations. Whatever the text that you write inside this double quotations, it will be displayed on my output screen. For example, I want to print text that is I am Nagendra. So inside double quotations I am writing I am Nagendra and close double quotations and close bracket. definitely you need to give semicolon, otherwise it will display error. So definitely you need to give semicolon and close curly bracket. Whenever you execute this program, you will get output as I am Nagendra. Some students will directly write like this, main printf, and they will write some text. But in exam you should not write like this. Definitely you need to write hash include stdio.h, because meaning of printf is present in stdio.h header file. For each and every program we use printf. So by default you need to write hash include stdio.h. After that you need to write void main. Meaning of void is nothing. So there is no need of returning anything. For example, same program, in place of void, if I write here int, where int is nothing but this is integer data type. So void is nothing but no return type. I am not returning anything. Meaning of void is nothing. There is no need of returning anything. But whenever you write here int main, definitely you need to return something. So here you need to write return 0. Here I given an integer type. So you need to write here 0. 0 is integer type, or you can also give here 1 and definitely give here semicolon. This is difference between void main and int main. Whenever you write here void main, there is no need of returning anything. But whenever you write here int main, whenever you give here return type as int, definitely you need to return any integer value. So I return here return 0. This is with no return type. Void main no return type. Int is with return type. In exam they may ask difference between void main and int main. There are two common escape sequences that we use in C. On that first one is /t, where /t stands for horizontal tab, and next one is /n, where n stands for new line. I will explain use of these escape sequences by using program. Guys, this is program. Here I want to print numbers from 1 to 8. So I want to print numbers from 1 to 8. So I written here printf, where printf stands for print function. After that, open bracket and take double quotations. Inside double quotations, you can write numbers. So I written here numbers from 1 to 8. By writing this program, I will get output as, this is my output. I will get output as 1, 2, 3, 4, 5, 6, 7, 8. But I don't want output like this. I want to get output like this. 1, in next line 2, next line 3, next line 4, after that next line 5, so on. So if you want to get output like this, you need to use escape sequences, that is /n, where /n stands for new line. So I want to print numbers from 1 to 5. So I written here printf, open bracket, inside double quotations I am writing 1 /n, 2 /n, 3 /n, and so on, 4, 3 /n, 4 /n. Close double quotations, close bracket and give semicolon. Whenever you write like this, you will get output as 1, where /n stands for new line. So 2 will be printed on next line. After the /n, 3 will be printed on next line. After that 4. This is my output. For example, I want to print how are you. So I am writing here printf, double quotations, how /n r /n u. Whenever you execute this program, you will get output as how /n means next line. After again /n, that means this is my output. This is use of /n. Next I will explain use of /t, where /t stands for horizontal tab. For example, I want to print output like this one. After some gap I need to get 2, and after some gap I need to get 3. Here at first I am writing 1 /t, where /t stands for horizontal tab. Whenever you click on tab, how much space that you will get, that much space you will get by using /t. Similarly 2 /t 3. Close double quotations, close bracket and give semicolon. Whenever you execute this program, you will get output as 1 /t mean tab. Whenever you click on tab, how much space that you will get, that much space you will get here. After 2 /t 3. This is my output, where /n and /t are two common escape sequences that we use. Next I will explain what is use of CLR-SCR function, where CLR-SCR stands for clear screen. CLR-SCR function will remove previous program's output and then it will display only present program output. For example, here I written two programs. Here at first I want to print how are you, so I written this program. Whenever I execute this program, I will get output as how are you. After writing this program, I written another program. I want to print btech, so I written here printf btech. Whenever you write this program, you will get both present program output and as well as previous program output. But I don't want previous program output. I want only present program output. That is, I want to print only btech. For that purpose, you need to use clr function. So here just you need to write clr open bracket, close bracket. Definitely you need to give semicolon. Though you write like this, you will get error because whenever you write clr meaning of this clr is present in conio.h header file. So you need to write here hash include open angle bracket conio.h where conio.h stands for console input output header file. Meaning of this clr is present in conio.h header file. So definitely you need to write here hash include conio.h. Whenever you execute this program, then you will get output as btech. So clr function is used to remove previous program's output. The C program which I written in order to get this output, name Nagendra, and in next line rule number 25, in next line place Hyderabad. This is output which I want. So for that purpose, at first I took printf and inside double quotations I written name Nagendra, and here I given /n. Whenever you give /n, next statement will be printed on next line. So I given here /n. Definitely you need to give /n inside double quotations. You should not give /n outside double quotations. It will display error. After that again I took printf rule number 25. So in next line I will get output as rule number 25, and again I took printf and I given place Hyderabad. Whenever you write this code, you will get output as name Nagendra, rule number 25 and place Hyderabad. Or you can also write like this by taking single printf. You can write name Nagendra /n rule number 25 /n place Hyderabad. By taking single printf also you can write this program. Instead of taking 3 printf functions, you can also take single printf function, and inside this printf function you can write like this. Next I will explain variables and data types. Guys, these two topics are very important. If you don't understand these two topics, then you will not understand entire C program. So listen this topic carefully. At first I will explain what are variables. Variables are used to store data. It is nothing but variables are used to store any values, like for example int a equal to 10, where this int is data type and a is variable. Variables are used to store values. This 10 is value. This value 10 is stored in variable a. So this is use of variables. This 10 is value. 10, 20, 100, all these are integer types. So we use data type int. So for integer values we need to use data type int. So here I am using data type int and I took variable name as a, and this variable a will store value 10. This is use of variable. Variable is used to store data, or you can also say value. Its value can be changed and reused many times. We can also change this value and we can also use this value multiple number of times. There are some rules which we need to follow before declaring a variable. And the first rule is a variable can have alphabets and underscore. We must start variable name with alphabet, or you can also start variable name with underscore. This is an example. Here I written int a equal to 10. This a is alphabet. We can start declaring variable with an alphabet, or you can also start declaring variable with an underscore. This is an example. Here I written int underscore a equal to 10. You can also declare like this. Second rule is we cannot start variable name with number. For example, here I written int 10 equal to 10. This 10 is number. So you should never start variable with number. Whenever you write like this, you will get error. You can write like this int a 10 equal to 10. You can write like this because as per rule we must start declaring variable with an alphabet. So here I am starting variable with an alphabet, or you can also start with underscore. And third rule is no white space is allowed. You should not give space in between variable name. For example, here I written int, I given variable name as number, num. You can write like this int number equal to 10. You can write like this, but you should not give space in between variable name. Here I written int n space um equal to 10. Whenever you declare like this, you will get error. So you should not give space in between variable name. Next I will explain data types in C. Along with data types, I will also cover what are format specifiers. There are 3 data types in C. First one is primary data type, second one is derived data type, and third one is user defined data type. Primary data type contains integer data type, character data type, and float data type. Guys, in unit 1 I will cover only this primary data type. Here I am taking variable name as a. I am assigning value as 10. This 10 is integer data type. For example, if you want to assign any integer values to a variable, then you need to use data type int. 10, 20, 1000, 100, all these are integer values. So you need to use data type int. Whenever you use data type int, you need to use format specifier %d. You need to remember this. And similarly, for example, if you want to assign any floating point values to a variable, for example, b equal to 10.25, point represent floating point value. So whenever you want to assign any floating point values to a variable, then you need to use data type float. For example, 10.5, 25.25, 100.1, all these are floating point values. So whenever you want to use any floating point values, then you need to use data type float. Whenever you use float data type, you need to use format specifier %f. Here you need to give float. For example, if you want to assign any single character to a variable like c equal to a, this a is character. So whenever you want to assign any character like C, A, D, so on, then you need to use data type character. Shortly we call it as char. You need to use this data type char, and whenever you use character data type, you need to use format specifier %c. So I will explain C programs so that you can clearly understand what is use of these variables, data types and format specifiers. Now I want to store one integer value, that is 10. So here I am taking data type as int, and I am taking variable name as a, and I am giving value of a as 10, where this 10 is integer data type, where this 10 is integer value. So I took here data type int. Now I want to print this value 10. For that purpose I need to write printf. As I already said before, for integer values you need to use format specifier %d. So in double quotations you need to write %d, close double quotations, comma, value 10 is present in variable a, so you need to give here a, close bracket, semicolon, close curly bracket. Whenever you execute this program, then you will get output as 10, because integer value which is present in variable a will be generated as output. So I will get output as 10. For example, I want to store one float value, that is 10.5. For that purpose I need to write float. I am giving variable name as a, and I am giving value as 10.25, semicolon, printf. Printf function is used to generate output, so I am taking here printf in double quotations. For float you need to use format specifier %f. So I am taking here %f, close double quotations, comma, this 10.25 is present in variable a, so I am taking here a, semicolon. Whenever you execute this program, then you will get output as 10.25, because float value which is present in variable a will be generated as output, so I will get output as 10.25. Similarly, I want to store character. So guys, you need to remember one thing, character data type is used to store only single character, that is it can store only single alphabet, it cannot store multiple alphabets. I want to store one character value, that is character. I am giving variable name as a, and I am giving value as c, and definitely you need to include this c in single quotations, otherwise it will display error. So take single quotations for this c, semicolon, printf. For character you need to use %c, so close double quotations, comma, this c is present in variable a, so I am taking here a, close with semicolon. Whenever you execute this program, then you will get output as c. I will explain C program in order to generate output 10, 20, 30. Here I need to store 3 values in 3 variables, so I am taking 3 variables, that is int a equal to 10. I already given variable name a, so I cannot take this variable name a again. I am taking another variable name, that is int b equal to 20 and int c equal to 30. I want to print 3 values 10, 20, 30. So for that purpose I need to take 3 variables. So I took 3 variables as a, b, c. Now I want to print these 3 values as my output. So I am taking a printf %d, because this 10 is integer value, so I am taking here %d. 10 will be printed on first line and 20 will be printed on second line. So I need to use here /n, and next %d, and next %d /n. Total there are 3 integer values. So I need to take 3 format specifiers, that is %d, close double quotations, comma, a, comma, b, comma, c, because 10 is present in variable a, 20 in variable b and 30 in variable c. So I took 3 format specifiers, %d/n, %d/n, %d, double quotations, comma. This %d is for variable a, and this %d is for variable b, and this %d is for variable c. So I took here a, comma, b, comma, c, close bracket, semicolon. Whenever you execute this program, then you will get output as 10, 20, 30. Guys, this 10, 20, 30, these 3 are of similar data type, that is int. So instead of writing like this, you can also write like this, int a equal to 10, comma, b equal to 20, comma, c equal to 30, semicolon. Instead of taking 3 data types for 3 variables, you can also take single data type, because all these are with similar data type. So I took here single data type. For example, I want to get output as 1, 20, 10.5 and d. I want to get this output. For that purpose I will write program. This 1 and 20 both are integer values, so I took here data type int. I am storing this value 1 in variable a, so I am taking here a equal to 1, comma, b equal to 20. This 20 is stored in variable b, C, and this 10.5 is float data type. This 10.5 is float value. So I need to take here float, data type float. Already I took variable AB. I'm taking another variable name, that is C equal to 10 semicolon, and this D is character. So I'm taking a data type char, and you can take any variable name. I'm taking variable name as F equal to D, and you need to give this D in single quotation semicolon. Now I want to print this value, so I need to take here printf. This A is integer type, so I took here %d for A, and next /n. Next 20 is present in variable B. This variable B is integer data type, so again I need to take %d/n. This is for B, and next 10.5 is present in variable C. This variable C is float type, so I need to take here %f/n comma. This is for C. Last one is D. D is present in variable F, and this variable F is character data type, so I need to take here %c comma F close with semicolon. Whenever you execute this program, then you will get output as 1, 20, 10.5 and D. This is my output. Next I will explain what is use of scanf function. I will explain this scanf function with an example. Let us consider one example. Here I am taking data type int and variable name as A. This variable A will store value 10. So in order to print this output, I need to write printf. 10 is integer type, so here I need to use %d comma. This 10 is present in A. So whenever you execute this program, you will get output as 10. Int A equal to 10, we call this as variable initialization, because we given value to this variable A. So we call it as variable initialization. Instead of directly assigning value to a variable, by using scanf function, you can assign values after executing a program. I will give an example so that you can clearly understand. Here I am not initializing value. I just declared int A and I did not assign any value to it. So we call it as variable declaration. You can assign value to this variable by using scanf function. So I am taking here scanf. By using scanf function, you can assign value to this variable A. This A is integer type, so I am taking here %d comma. For scanf, you need to use and A. Whenever you write this line of code, you can assign value to this variable A after executing a program. Meaning of this is, I can assign integer value and this value is stored in address A, where and represent address. Next I am writing printf. My output is %d comma A semicolon. Whenever you execute this program, it will show blank screen. Here you can give any value. For example, I want to assign value 10. So just I will enter 10. Whenever you enter value 10, then you will get output as my output is 10, because I given here value 10. This is use of scanf. By using scanf, you can assign value to a variable after executing a program. I will give another example. Guys, this is another program. Here I took int A because I want to store one integer value. So I took here int A. And similarly, I want to store one float value, so I took here float B. I want to assign value to this variable A and variable B after executing a program. I can do this by using scanf. So I written here scanf %d, because this A is integer type, so I am using here %d, and this B is float data type, so I am using here %f comma and A comma and B. So whenever I write this line of code, I can assign value to this variable A and variable B after executing a program. So whenever I execute program, I can enter value, that is 10, which is stored in address A, and next 10.5, which is stored in address B. And by using printf, I will get output. So I will get output as 10, 10.5. By using scanf, I can enter values after executing a program, and printf function is used to display output. So I will get output as 10 and 10.5. Next topic is how to create, compile and execute a program, and also I will explain software development lifecycle and various types of errors in C. At first I will explain how to create a program. For example, I want to create one C program. So in order to create C program, at first you need to open text editor. For example, if you consider Turbo C is an example of text editor. So at first you need to open Turbo C. In Turbo C, you need to write your program. After writing your program, you need to save your program with .c extension. Here I am saving my program with name program.c. After creating program, next step is compiling program. Whatever the C program that you written, the C program is in high level language, that is in English like language. So in order to convert this program into machine understandable language, you need compiler. Whenever you click on Alt F9, then compiler will convert this program into machine understandable language, that is into zeros and ones. At the time, object file will be created. After compiling program, next step is linking program. Now your program is linked to header file stdio.h. This process is known as linking. After linking your program with header files, then executable file will be created. Now your program.c file is converted into executable file, that is program.exe, where exe stands for executable file. So whenever you click on Alt F9, both compiling and linking will be done. Whenever executable file is created, if you click on Control F9, then you can execute your program. After executing your program, in order to display output, you need to click on Alt F5. Whenever you click on Alt F5, then you will get your output. This is how we create, compile and execute a program. Next, I will explain software development lifecycle. We also call this software development lifecycle as application development lifecycle or program development lifecycle. Before starting this, you need to know some basics. At first, you need to know who are clients. Person who give project to software company is known as client. For example, I want to design one college website. So I went to software company and I asked them to design one college website. So I am considered as client because I am giving project to software company. So I am considered as client. Next, you need to know who are software engineers. Person who do coding to our software is known as software engineer, and person who creates flowchart or algorithm is known as software designer. Person who perform testing in order to find errors in our software is known as testing engineer. What testing engineer will do is, whatever the code that software engineer written, testing engineer will test this code in order to find errors in software. This is duty of testing engineer. These are 4 basics that you need to remember. Totally there are 6 stages in software development lifecycle. On that first stage is analysis. For example, client given project to this software company in order to design one college website. How much time and how much cost required in order to complete this project is known as analysis. In this, we need to identify time, how much time that this software required to complete and how much cost it will take, and what are the programming language that we required in order to complete this project. All these are identified in analysis phase. After analysis, next phase is designing. After detailed analysis of project, software designers will design flowchart and algorithm for this project. After designing flowchart and algorithm for this project, next step is implementation. This is third stage. In implementation phase, software engineers will write software code for this project. After creating software code for this project, then software engineers will submit this code to testing engineers in order to identify errors present in software. For example, if there are any errors present in this software, then this testing engineers will submit this code back to software engineers. So again, software engineers will correct that code and again they will submit that code back to testing engineers. For example, if there are no errors present in this project, then in release phase we will submit project to client. Last step is maintenance. Maintenance is nothing but updating that software time to time. These are 6 stages in software development lifecycle. Next, I will explain programming errors in C. Any faults that occurs in program which makes behavior of program abnormal is known as programming error. We also call this programming error as bugs or faults, or you can also call it as mistakes. Even experienced developers can also make these errors. Totally there are 5 types of errors in C. On that first one is syntax error. Any error made in syntax is known as syntax error. For example, actually in int I should be small, but instead of taking I as small letter, if I take I as capital letter, then it is considered as syntax error because data type should not start with capital letter. So instead of taking small letter, if I take capital I, then it is considered as syntax error. And we need to declare variables with data type. Like actually we need to write like int a equal to 10. If I write just like a equal to 10 without writing data type, then it is also considered as syntax error. Next one is runtime error. Actually runtime error is nothing but whenever you compile your program, that is whenever you click on Alt F9, then it will not display any error, but after executing your program, that is at runtime, it will display error. Like for example, if I write here int a equal to 2 by 0, if we divide any number by 0, then result will be undefined. So whenever you write like int a equal to 2 by 0, it will not display any error during compilation, but after executing your program you will not get output, because if we divide any number by 0, then result will be undefined, so I will not get any output. This is known as runtime error. Third one is linker error. Actually in main function you need to write m as small letter, but instead of taking m as small, if you write here m capital, then it is considered as linker error. And fourth one is logical error. In logical error, during compile and runtime, it will not display any error, but it will display wrong output. For example, I took value of a as 10, value of b as 20, and I return c equal to a plus b. Now this c contains result. So now I need to write printf %d comma c, because c contains result. So I need to print c. But instead of printing c, If I write here %d comma a, now I will get output as 10, which is wrong answer. Mainly beginners will perform such kind of logical errors. In logical error, we will get undesired output. It is error free but incorrect output. This is known as logical error. And last one is semantic error. Whatever the statements that we written in our C program, if these statements are not understandable by compiler, then it is considered as semantic error. These are 5 types of errors in C programming. Next topic is operators in C. I will explain what is an operator. An operator is a symbol that tells compiler to perform specific mathematical or logical operations. By using operator, we can perform mathematical or logical operations. For example, if you consider a plus b, where this a and b are operands and this plus is operator. This plus symbol is used to perform addition. That is nothing but mathematical operation. C language is rich in built-in operators and provides following type of operators. Built-in operators are nothing but meaning of these operators are already present in header file. So we call it as built-in operators. These are various types of built-in operators supported by C. On that first one is increment and decrement operator. At first I will explain what is increment and decrement operator. Increment operator will increment value by 1. For example, here I took variable as a and I given value of a as 10. We denote increment operator with plus symbol. So here I am using increment operator for variable a. Plus a is equal to 11. I will get output as 11 because increment operator will increment value by 1. So 10 plus 1, that is 11. So I will get output as 11 for increment operator. Similarly for decrement operator will decrement value by 1. For example, here I took variable name as a and I given value as 10. Now I want to use decrement operator. Here I written minus a, where minus represent decrement operator. By writing minus a, I will get output as 9 because decrement operator will decrement value by 1. So here 10 minus 1, that is 9. I will get output as 9. And we denote decrement operator with minus symbol. Increment operator is further classified into 2 types. One is pre-increment and next one is post-increment. If you use increment operator before variable, then we call it as pre-increment. And if you use increment operator after variable, then we call it as post-increment, where plus a represent pre-increment and a plus represent post-increment. Similarly, minus a represent pre-decrement and a minus represent post decrement. Now I will explain what is pre-increment, pre-decrement and what is post-increment and post-decrement by using programs. Now I will explain C program for pre-increment and pre-decrement. At first I will explain C program for pre-increment. Here I took variable name as a and I given value as 10. This 10 is integer type. So here I written data type as integer. Now I took printf and inside printf I written %d because for integers we use %d comma plus a, where plus a represent pre-increment. The name itself says pre-increment mean at first it will increment and then it will generate output. So by writing this program I will get output as 11. Similarly I will explain program for pre-decrement. Here I written int a equal to 10 and here I written printf. Inside printf I written %d comma minus a, where this minus a represent pre-decrement. Pre-decrement mean it will decrement value by 1 and then it will generate output. So here I will get output as 9. This is program for pre-increment and pre-decrement. Next I will explain program for post-increment and post-decrement. This is same program which I written before for pre-increment and pre-decrement. Here I written int a equal to 10 and after that I written printf %d comma a plus, where a plus represent post-increment. Post mean after. Pre mean before, whereas in pre-increment at first it will increment value and then it will generate output, but whereas in post-increment by writing this program I will get output as 10. I will not get output as 11, I will get output as 10. Meaning of this a plus is at first it will print same value, after that it will increment value. So by writing this program I will get output as 10. And similarly again if I write printf %d comma a, I will get output as 11 because meaning of this post increment is at first it will print the same value, after that next time it will increment value. So by writing this program at first I will get output as 10, next time it will increment value, so I will get output as 11. Similarly for post decrement, meaning of this post decrement is at first it will print that same value and next time it will decrement value. So again I need to write printf %d comma a. By writing this program I will get output as 10, after that next time I will get output as 9. This is C programs for post increment and post decrement. Next I will explain arithmetic operators. Arithmetic operators are used to perform arithmetic calculations, like for example addition, multiplication, subtraction. Totally there are 5 arithmetic operators. On that first one is addition, we use symbol plus, and next subtraction we use symbol minus, and next the symbol is for multiplication, we call it as asterisk. Next division, and last one is modulus. Let us consider two variables. One variable name is a and another variable name is b. A holds value 10 and b holds value 20. We can call this a and b as operands. First arithmetic operator is addition. We use symbol plus. Addition is used to add two operands, where we call this a and b as operands. This addition is used to add two operands, that is a plus b. Value of a is 10 and value of b is 20, that is 30. I will get output as 30. Similarly, next arithmetic operator is subtraction. We use symbol minus, that is a minus b. I will get output as 10 minus 20, that is minus 10. I will get output as minus 10. Next multiplication, a asterisk b, that is 10 into 20, that is 200. Next one is division, that is b by a. Value of b is 20 and value of a is 10. So I will get output as 2 by 1, that is 2. Last one is modulus. Modulus will provide remainder as output. For example, here I want to divide value of a by b. If we divide value of a with b, that is 10 divided by 20. 10 to the 20, remainder is 0. Modulus will provide remainder as output. So here I will get output as 0. These are 5 arithmetic operators in C. I will explain C program for these arithmetic operators. This is C program for arithmetic operators. Here I took 3 variables, where variable a contains value 10 and variable b contains value 20 and variable c will store result. At first I want to perform addition. So here I written c equal to a plus b. Value of a is 10 and value of b is 20. So I will get result as 30 and this 30 will be stored in variable c. So now I need to print variable c. So I written here printf addition is %d comma c. By writing this I will get output as addition is 30. And similarly next I want to perform subtraction. So I written here c equal to a minus b. Now again I need to write printf subtraction is %d comma c. Here you need to write variable c because this variable c will contains result. In place of c, if you write here a or b, then it will print value 10, which is wrong answer. So here you need to write %d comma c. Next I want to perform multiplication. Here I written c equal to a asterisk b. By writing this I will get output as multiplication is 10 into 20, that is 200. Next I written c equal to a by b, and after that I written printf division is %d comma c. A by b, that is 10 by 20, that is 1 by 2. I will get output as 0.5. Similarly last one is c equal to a modulus b. I already said before, modulus will provide remainder as output. So here I will get output as mod of c is 0. This is C program for various arithmetic operators. Next I will explain relational operators. Relational operators are used to identify relation between various operands. These are various types of relational operators in C. First one is equal to, next one is not equal to, greater than, less than, greater than or equal to, and less than or equal to. All these are relational operators in C. Let us consider two operands where a holds value 10 and b holds value 20. At first I will explain what is use of is equal to operator. Is equal to operator is used to check whether value of operand a is equal to value of operand b or not. If value of a is equal to value of b, then this condition is true. This is how we represent is equal to operator, that is a double equal to b. And similarly not equal to. Not equal to operator is used to check whether two operands are equal or not. If they both are not equal, then condition is true. Here value of a is 10 and value of b is 20. So a is not equal to b. This condition is not satisfied. And similarly here value of a is 10 and value of b is 20. So a is not equal to b. This condition is satisfied. So this condition is true. Next, greater than symbol. This is how we represent greater than symbol, that is a greater than b. Value of a is 10 and value of b is 20. 10 is not greater than b. So this condition is not satisfied. If value of a is greater than b, then condition will be true. In this condition is false. Next, less than operator. This is how we represent less than operator, that is a less than b. Value of a is 10 and value of b is 20. 10 is less than 20. Condition is satisfied. So in this condition is true. Next one is greater than or equal to. This is how we represent greater than or equal to, that is a greater than or equal to b. Here value of a is 10 and value of b is 20. This condition is not satisfied because value of a is not greater than b. Value of a is less than or equal to b. Similarly last one is less than or equal to. This is how we represent less than or equal to. Here value of a is 10 and value of b is 20. This 10 is less than or equal to b. Condition is satisfied. For example, if value of a is 10 and value of b also 10, even though condition is satisfied, because here I have written less than or equal to. So if value is less than or equal to, this condition will be satisfied. Now I'll explain C program for various relational operators. First relational operator is equal to. Here at first I written a equal to 10. This 10 is integer type. So here I written data type as int and value of a is 10 and value of b is also 10. Here I given condition, that is if value of a is equal to b, then I should get output as value of a is equal to b. This is condition which I given. Here value of a is 10 and value of b is also 10. So this condition is satisfied. I will get output as value of a is equal to b. Similarly, next I will explain C program for less than operator. Here I written a equal to 10, b equal to 20. If a value is less than b, then I should get output as value of a is less than b. Here value of a is 10 and value of b is 20. This 10 is less than 20, so I will get output as value of a is less than b. For example, if I give value of a as 30 and value of b as 20, this 30 is not less than b, this 30 is greater than b. So here I will not get any output. If condition is not satisfied, then I will not get any output. This is C program for various type of relational operators. Next I will explain various types of assignment operators. Is equal to, plus is equal to, minus is equal to, multiplication is equal to, and division is equal to. After arithmetic operators you need to place is equal to. That's it. First one is equal to. This is example C equal to a plus b. This is an example of this assignment operator is equal to. Next operator is plus equal to. This is an example of plus is equal to operator, that is C plus is equal to a. Meaning of this C plus is equal to a is nothing but C equal to C plus a. This is meaning. Similarly, C minus equal to a. Meaning of this is C equal to C minus a. C multiplication is equal to a. Meaning of this is C equal to C into a. C division is equal to a. Meaning of this is C equal to C by a. This is meaning of this operator. Now I will explain C program for assignment operator. This is an example of assignment operator. Here I took three variables where variable a holds value 10, variable b holds value 20, and where variable c holds result. Here I am using assignment operator, that is equal to. I written here C equal to a plus b. This C contains result, so I need to print C by using printf. Addition is %d comma c. By writing this program I will get output as 30. This is C program for assignment operator. We represent assignment operator with is equal to symbol, and these are various types of assignment operators supported by C. Whenever assignment operator question comes in exam, then you need to write this table and as well as program. Next I will explain bitwise operators. These are various types of bitwise operators. On that first one is AND, second one is OR, third one is NOT, fourth one is left shift, fifth one is right shift, and at last sixth one is XOR. These are various types of bitwise operators. Guys, you need to remember this table for bitwise AND, bitwise OR, and bitwise XOR. At first I will explain bitwise AND. For bitwise AND, if both values are 1, then result will be 1, else result will be 0. And next for bitwise OR. For bitwise OR, if both values are 0, then result will be 0, else result will be 1. This is for bitwise OR. Next for bitwise XOR. For bitwise XOR, if both values are 0, then result is 0, and if both values are 1, result is 0. Else if one value is 0 and one value is 1, result is 1. This is for bitwise XOR. You need to remember this table. Now I will give example for bitwise AND. Let us consider two numbers. One number is 7 and another number is 4. Now you need to convert this 7 and 4 into binary, that is into zeros and ones. If you convert this 7 into binary, then you will get value as 0 1 1 1. And similarly, if you convert this 4 into binary, then you will get value as 0 1 0 0. Now you need to compare this both bits. Now we are performing bitwise AND for this. For bitwise AND, if both values are 1, result will be 1, else result is 0. So compare this both 1 and 0 from last. 1 and 0, that means value is 0. Next 1 and 0, value is 0. And for 1 and 1, value is 1. And for 0 0, value is 0. After performing bitwise AND, for 7 and 4, we got result as 0 1 0 0. Now you need to convert this 0 1 0 0 into decimal. If you convert this 0 1 0 0 into decimal, then you will get value as 4. This is how we perform bitwise AND operation for two numbers. Similarly, we will perform bitwise OR operation. For bitwise OR, if both values are 0, then result will be 0, else result is 1. Now we will perform bitwise OR for number 7 and number 4. If you convert this 7 into binary, then you will get value as 0 1 1 1, and if you convert this 4 into binary, you will get value as 0 1 0 0. Now you need to compare this both, that is 1 and 0. For bitwise OR, if value is 1 and 0, then result is 1. Similarly for 1 and 0, result is 1, and similarly for 1 and 1, result is 1, and for 0 0, result is 0. If you perform bitwise OR operation for this 7 and 4, then you got result as 0 1 1 1. If you convert this 0 1 1 1 into decimal, then you will get value as 7. This is how we perform bitwise OR operation. Guys, this is C program for bitwise AND operator. I took two numbers, one number is 7 and one number is 4. These both are integers, so I took here data type as int. After that, now I am performing bitwise AND operation. So here I written %d comma a and b, where and represent bitwise AND operator. So I written here a and b. By writing this program, I will get output as 4. Guys, I took this same example for this program. I will get output as 4. Guys, for bitwise OR operator, just in place of AND, you need to take OR. If you take a bitwise OR and b, then you will get output as 7. Same as previous example. This is C program for bitwise AND and bitwise OR operator. Guys, now I will give table for bitwise NOT operator. This is table for bitwise NOT operator. Here 0 is represented as 1 and 1 is represented as 0. That is just opposite. This is table for bitwise NOT operator. For example, let us consider any number, that is 7. If you convert this 7 into binary, then you will get value as 0 1 1 1. Now I want to perform bitwise NOT operation for number 7. 0 is represented as 1 and 1 is represented as 0. So 1 is represented as 0, 1 as 0, 1 as 0 and 0 as 1. 1 0 0 0. If you convert this binary number into decimal, then you will get value as 8. This is an example for bitwise NOT operation. Next, I will explain logical operators. Totally, there are 3 types of logical operators, and that first one is logical AND, second one is logical OR, and third one is logical NOT. These are 3 types of logical operators, where single AND represent bitwise AND and where double AND represent logical AND. You need to remember this difference. At first, I will explain what is use of this logical AND. Guys, you need to remember this table. Guys, I already explained this table in bitwise AND operator, where single AND represent bitwise AND, where double AND represent logical AND. Guys, you need to remember this, where 1 represent true and 0 represent false. For logical AND, if both conditions are true, then result will be true, else result will be false. That means if both conditions are true, only then I will get output. This is for logical AND. I will give one example so that you can clearly understand what is this logical AND operator. This is an example. Here I took a value as 5. This 5 is integer, so I took here data type as int. And here I am giving condition, that is if a value is greater than 0 and where this double AND represent logical AND operator. If a value is greater than 0, logical AND, a value is less than 10, then I should get this output. If both conditions are true, then I will get this output, that is condition true. Here I given value as 5. This 5 is greater than 0. Condition is true because 5 is greater than 0. And similarly, next condition is a value is less than 10. This 5 is less than 10. This condition is also true. So if both conditions are true, only then I will get output. Now I will get output as condition true. For example, if I give here value as 15, this 15 is greater than 0. This condition is true, but this 15 is not less than 10. 15 is greater than 10. So this condition is false. If any single condition is false, then I will not get output. Here I will not get any output because a value is 15. 15 is not less than 10, 15 is greater than 10. So I will not get any output. This is logical AND operator. Next I will explain logical OR operator. For logical OR operator, if both conditions are false, then I will not get any output. If single condition is true, then I will get output. If any single condition is true, then I will get output. Only if both conditions are false, then I will not get any output. I will give one example so that you can clearly understand what is this logical OR operator. Guys, same example. Here just in place of logical AND, you need to write logical OR. That's it. Just in place of logical AND, write logical OR. For logical OR, if any single condition is true, then I will get output. Here I given value as 15. 15 is greater than 0. This condition is true. But 15 is not less than 10. 15 is greater than 10. So this condition is false. If any single condition is true, then I will get output. So now I will get output as condition true. This is logical OR operator. So whenever logical operator question comes in exam, then write this table for both logical AND logical OR and then give these examples. Guys, we also call this ternary operator as conditional operator because based on the condition, output will be generated. This is syntax of ternary operator. At first you need to write condition. After that you need to give question mark symbol where question mark represent ternary operator. At first you need to write condition question mark statement 1 colon statement 2 at last semicolon. Meaning of this is if this condition is true, then this statement will be executed. Else this statement will be executed. So this ternary operator is same as if-else statement. If condition is true, then one statement will be executed. If condition is false, then else statement will be executed. So if condition is true, statement 1 will be executed. If this condition is false, then statement 2 will be executed. I will give one program so that you can clearly understand what is this ternary operator. This is C program for ternary operator. Here I took variable name as age and I given value as 20. And now I am giving condition, that is, if age is greater than 18, then I should get output as major. Else, I need to get output as minor. Here I given age as 20. 20 is greater than 18. Condition is true. Then I will get output as major. For example, in place of 20, if I give here 5, 5 is not greater than 18. 5 is less than 18. So I will get output as minor. So this is same like if-else statement. If condition is true, this statement will be executed. Else, next statement will be executed. This is C program for ternary operator. For increment and decrement operator, we use only one operand. For example, a plus plus or a minus minus. Here we use only one operand. So we call this increment and decrement operator as unary operator. And for arithmetic, relational, logical, bitwise and assignment operators, we use two operands. For example, a plus b, where this a and b are two operands. So we call arithmetic, relational, logical, bitwise and assignment operators as binary operator, where bi mean 2. Next topic is what are conditional statements. We also call these conditional statements as decision making statements. So conditional statements are used to make decision based on the conditions. Conditional statements are classified into 5 types. First one is if statement, next one is if else, third one is else if, fourth one is switch statement, and fifth one is nested if. I will explain each of them in detail. At first I will explain what is if statement. If statement execute block of code only if particular condition is true. If condition is false, then whatever the statements that are present inside if will not be executed. I will give an example so that you can clearly understand what is if statement. This is syntax of if statement. At first you need to write if, and inside brackets you need to give any condition. Open curly bracket, and inside curly bracket you can write some statements. Only if this condition is true, then these statements will be executed. For example, this condition is false, then the statements will not be executed. I will give one program. First I written hash include stdio.h. After that I written int main, open curly bracket. Here I written int a equal to 10. I given value of a as 10. Now I written if a value is less than 20, guys, you need to give condition inside brackets. If a value is less than 20, open bracket, printf, value is less than 20. Here I given one statement, that is value is less than 20. If a value is less than 20, then I need to get this output. Here I given value of a as 10. 10 is less than 20. This condition is true. So whatever the statement that is present inside if will be executed. So I will get output as value is less than 20. For example, here if I give value of a as 100, 100 is not less than 20. 100 is greater than 20. So whatever the statement that is present inside if will not be executed because condition is false. 100 is not less than 20. So I will not get any output if I give value of a as 100. Guys, you need to remember one important thing, that is here you need to use int main, not void main, because based on the conditions we may skip some statements. So you need to use here int main. Whenever you use here int main, definitely you need to write here return 0. For example, if you want to execute each and every line without skipping any statements, then you can use here void main. But here we are skipping some statements based on the condition. So here you need to use int main. Same program I will explain by using scanf. Here instead of initializing value 100, I am just declaring value, that is int a. I want to give value of a after executing a program. So for that purpose I need to use here scanf. But before that I will write one statement, that is printf enter number. So whatever the statement that is present inside this printf will be seen on my output screen. So here I can see enter number. Now I can enter number by using scanf. So I'm writing here scanf. This a is integer, so I need to use here %d in double quotations comma and a. You should not write a, you should write and a, where and represent address. Whenever I write this line of code, I can enter any number after executing a program. So whenever I execute program, I can see here enter number, and here I can enter any number by using scanf. Now I am giving condition, that is if value of a is less than 50, then I should get output as printf. I need to get output as value is less than 50. Value is less than 50. Close double quotations, semicolon, close bracket, return 0. Because I am using here int main, so you need to write here return 0. So close main function. CC program. At first I written int a and I did not initialize any value. I will give value after executing a program by using scanf. So I just written here printf enter number, and by using scanf I can enter any number, and this number will be stored in address A. That is, this number will be stored in variable A, and if A value is less than 50, then I should get output as value is less than 50. So after executing program, I can see here enter number. So I will enter number, that is 40. 40 is less than 50. This condition is true. So I will get output as value is less than 50. This is use of scanf. I can enter value after executing a program by using scanf. For example, if I give here 400, then 400 is not less than 50. 400 is greater than 50. So I will not get any output. This is C program for if statement. Next, I will explain flowchart for this. As this is flowchart for if statement. If condition is true, then statements will be executed. Else, if condition is false, then directly it will end if. This is flowchart for if statement. Guys, you need to give condition in rhombus. Next, I will explain if else statement. If condition is true, then whatever the code that is present inside if will be executed. If condition is false, then whatever the code that is present inside else will be executed. This is syntax. Here you need to write if and you need to give condition. If this condition is true, then whatever the code that is present inside if will be executed. Or if condition is false, whatever the code that is present inside else will be executed. This is program. Here I written int a equal to 10. I given value of a as 10, and I am giving condition, that is if a value is less than 20. Guys, you need to write this a less than 20 in brackets, and you should never use semicolon here. Open bracket. Here I am giving statement, that is printf value is less than 20. If this condition is satisfied, then the statement will be executed. Or if condition is false, so I am writing here else printf value is greater than 20. If condition is true, then if statement will be executed. Or if condition is false, then whatever the statement that is present inside else will be executed. So I am using here int main. So at last you need to write here return 0 and close main function. Here I given value of a as 10. 10 is less than 20. This condition is true. So I will get output as value is less than 20. For example, in place of 10, if I give here 100, 100 is not less than 20. 100 is greater than 20. So this condition is false. So whatever the statement that is present inside else will be executed. So I will get output as value is greater than 20. If condition is true, whatever the statement that is present inside if will be executed. If condition is false, then whatever the statement that is present inside else will be executed. This is if else statement. I will explain flowchart for if else statement. Guys, this is flowchart for if else statement. Here you need to give condition. If this condition is true, then if statements will be executed. If condition is false, then else statements will be executed. And at last, you need to give stop. This is flowchart for if else statement. Next, I will explain else if statement. By using else if statement, you can give multiple conditions. If any particular condition is satisfied, then whatever the statements that are present inside that block will be executed. I will give one program so that you can clearly understand what is else if statement. This is syntax of else if statement. At first, you need to write if and you need to give condition. If this condition is satisfied, then whatever the statements that are present inside if will be executed. Next, you need to write else if and you need to give else if condition. If this condition is satisfied, then whatever the code that is present inside this else if will be executed. Again, you need to write else if and you can give another condition, and if this condition is satisfied, then this code will be executed. At last, if all these conditions are false, then whatever the code that is present inside else will be executed. Guys, you can take multiple else if conditions. This is program. At first I written int a equal to 10. I given value of a as 10. At first I am taking if condition. Here I written if a equal to 10. Guys, definitely you need to use here double is equal to. If a double equal to 10, printf value is equal to 10. Else if a double equal to 20, printf value is equal to 20. Again I written else if a double equal to 30, printf value is equal to 30. At last, if all these conditions are false, then take else printf number not found. Here I given value of a as 10. 10 is equal to 10. This condition is true. So I will get output as value is equal to 10. Here in place of 10, if I give here 20, 20 is equal to 20. So I will get output as value is equal to 20. For example, here if I give 30, then 30 is equal to 30. So I will get output as value is equal to 30. For example, here if I give 100, 100 is not equal to 10, 100 is not equal to 20, and 100 is not equal to 30. So I will get output as number not found. So here I written increment. So at last you need to write return 0 and close main function. This is C program for else if statement. Guys, you can use multiple else if statements. You should never use semicolon here for if, for else if, and for else. You should never use semicolon. And here for else, you should never give any condition. Else statement does not contain any condition, so don't give any condition for else. This is flowchart for else if statement. By using else if statement, you can give multiple conditions. So at first I written here start. I given 3 conditions, condition 1, condition 2 and condition 3. Guys, you need to give conditions in rhombus. So I took here rhombus. If this condition is true, then the statement will be executed. If this condition is false, then it will go to condition 2. If this condition 2 is true, then the statement will be executed. If condition is false, then it will go to condition 3. If this condition 3 is true, then it will print statement 3. If this condition is false, then it will exit. This is flowchart for else if statement. Next I will explain switch statement. This switch statement is same as else if statement. It is an alternative to else if statement. This is syntax of switch statement. Here at first you need to write switch and inside brackets you need to write expression. Expression is nothing but variable name. For example, here I took int a equal to 0. So here you need to give variable name a. After that you need to give case and give value, and here you need to use colon, not semicolon. You need to use here colon. This case contains some code. If this condition is satisfied, then this code will be executed. We need to break this case and we need to start new case. So again take case value to colon. This case contains some code and give break. Guys, you can take multiple number of cases, and at last you need to give default. If all these conditions are false, then default condition will be executed. So default condition also contains some code. Guys, I will give one program so that you can clearly understand what is switch statement. Here I took int a equal to 0. I given value of a as 0, and after that I took switch. Inside bracket I given variable name. Here I took variable name as a. So I given here a. Open bracket. Here I took case 1. This is nothing but value. I took here value as 1. This is case 1 colon printf number is equal to 1. Here inside this case 1 I am writing statement, that is number is equal to 1. Now you need to break this case 1. Again I took case 2. After that I am writing statement, that is number is equal to 2, and I am breaking this case 2. So I am using here break. Next I took case 3 colon printf number is equal to 3. At last I return default colon number not found. Here I given value of a as 0. So it will compare this with this case value. Here I given value of a as 0. Now we need to compare this value with case value, that is 1, 2 and 3. 0 is not equal to 1. So this will not be executed. Similarly 0 is not equal to 2. This will not be executed. 0 is not equal to 3. It will not be executed. So I will get output as number not found. So if all these conditions are false, then default statement will be executed. So I will get output as number not found. Here I written int main. So you need to write return 0 semicolon close main function. This is program. Here I will get output as number not found. For example, here in place of 0, if I give value of a as 1, here case 1, this 1 is equal to 1. So I will get output as number is equal to 1. If I give value of a as 2, then case 2. This 2 is equal to 2. So I will get output as number is equal to 2. This is C program for switch statement. Next I will explain flowchart. This is flowchart for switch statement. This flowchart is same as else if statement. At first you need to write start or begin. Case 1 contains statement 1. Case 2 contains statement 2, so on. At last you need to use default statement. If this case 1 is true, then whatever the statement that is present inside this case 1 will be executed. Similarly, if this case 1 is false, then it will go to case 2. If this case 2 is true, then whatever the statement that is present inside this case 2 will be executed, so on. So if all these cases are not satisfied, then at last it will print default statement. At last you need to end this. This is flowchart for switch statement. Next I will explain nested if statement. If we place one if statement inside another if statement, then we call it as nested if statement. This is an example. Here I took int a equal to 5. I given value of a as 5. Here I am using two if statements. At first I written if a value is less than 10. Inside this I am giving another condition, that is if a value is equal to 5. So at first a value is placed here 5. 5 is less than 10. This condition is satisfied. So again it will compare another if condition, that is a is equal to 5. Value of a is 5. 5 is equal to 5. This condition is true. So I will get output as number is equal to 5. This is flowchart for nested if statement. At first you need to give if condition. If this condition is true, then again it will go to nested if condition. And if this nested if condition is true, then it will print statement which is present in nested if. If these conditions are false, then it will exit. This is flowchart for nested if statement. Next I will explain loops in C. What is loop? Anything that is repeating multiple number of times is known as loop. For example, I want to print one statement, that is my name is Nagendra. So I written here printf, in double quotations I written my name is Nagendra. Close double quotations, close bracket and semicolon. Whenever I execute this program, then I will get output as my name is Nagendra. For example, I want to get output as Nagendra 3 times. So I need to write printf 3 times. So I am writing here printf. By writing this program, I will get output my name is Nagendra 3 times. But I want to write my name is Nagendra 100 times. So 100 times I need to write printf, and inside the printf I need to write my name is Nagendra. But it is impossible to write 100 times. It is very complicated. So in order to overcome this problem, we use loops. By using loops, we can write code once and we can repeat this code multiple number of times. So this is main use of loops. Instead of writing my name is Nagendra 100 times, I can simply write my name is Nagendra once and I can repeat this multiple number of times. So loops are used to repeat block of code until specific condition is met. For example, if I give condition like 10, then I will get my name is Nagendra 10 times. So loop is used to repeat block of code until specific condition is met. This is definition of loop. C programming has three types of loops. They are for loop, while loop and do while loop. At first I will explain what is for loop. This is definition of for loop. For loop executes statements of a program several number of times repeatedly until given condition is met. For loop keep on executing the statements until given condition is satisfied. This is syntax of for loop. First you need to write for open bracket, and here you need to write initialization. Initialization is nothing but here you need to initialize value to a variable like int a equal to 10 semicolon, and here you need to give condition semicolon. At last you need to give increment or decrement operator, close bracket. Inside this for loop you can give multiple number of statements. So until this condition is satisfied, the statements will be printed. I will give one program so that you can clearly understand what is this for loop. Here at first you need to write for open bracket and you need to initialize value to a variable. So I am giving here int a equal to 0 semicolon. After that you need to give condition. Here I am giving condition, that is a less than 10. This is condition semicolon, and I am using increment operator I++. I will explain this. Here inside this for loop I am writing statement, that is how are you. So I am writing here printf open bracket open double quotations how are you. This is statement which I written. Use here /n, because whenever you use here /n, how are you will be printed on next line. So use here /n inside double quotations, close this double quotations, close bracket, semicolon, close this for loop, and at last close main function. You need to close for loop and at last you need to close main function. I given value of a as 0. So 0 is less than 10, condition is satisfied. So if condition is satisfied, whatever the statement that is present inside for loop will be executed. So I will get output as how are you. After that here I am using increment operator. So it will increment value of 0. I++ is nothing but I plus 1. 0 plus 1, that is 1. So it will increment value to 1. 1 is less than 10, condition is satisfied. So again I will get output as how are you. Again it will increment value of 1. After incrementing value 1 I will get 2. 2 is less than 10, condition is satisfied. So again I will get output how are you. After that 3 is less than 10, condition is satisfied. 4 is less than 10, condition is satisfied. I will get how are you. 5, 6, 7, 8, 9. From 0 to 9. 9 is less than 10. So again I will get output how are you. After incrementing value 9, I will get 10. 10 is not less than 10. 10 is equal to 10. This condition is not satisfied. So it will stop this loop. So starting from 0 to 9. Total 10 times I will get output how are you. This is C program for loop. For example, if you want to print multiple statements like how are you, I am Nagendra. So right here printf my name is Nagendra /n double quotations close bracket semicolon. Whenever you execute this program, then how are you and Nagendra both will be printed 10 times. This is C program for loop. Instead of writing how are you 10 times, you can simply write how are you once and you can repeat this until particular condition is satisfied. For example, if I give condition here a less than 100, then I will get output how are you 100 times. For example, I want to print numbers from 0 to 9 by using for loop. So at first I am taking here int a equal to 0 because I am starting number from 0. So I written here int a equal to 0. I am starting from 0. So I given value of as 0 semicolon, and I am giving condition. I want to print numbers from 0 to 9. So at last I need to get 9. So I am giving here condition, that is a less than 10 semicolon. I keep on incrementing values like 0, 1, 2, 3, 4 like that. So here you need to use a++. Close bracket. Inside this you need to write printf %d. Definitely you need to use here /n, because whenever you use here /n, next statement will be printed on next line. For example, if you don't use here /n, then you will get output 0, 1, 2, 3 like that. So use here /n double quotations close comma a. Value is present in variable a. So I am giving here a semicolon. Whenever you execute this program, then at first it will take value 0. 0 is less than 10. So it will print value 0 and it will increment value. After incrementing 0, I will get 1. 1 is less than 10. Condition is satisfied. So it will print 1 in next line, and again it will increment value 2. 2 is less than 10, condition is satisfied, it will print 2, and again it will increment value. So now I will get 3. 3 is less than 10, so it will print 3, and again it will print 4, 5, 6, 7, 8. 8 is less than 10, so it will print 8, and again it will increment value, that is 9. 9 is less than 10, so it will print 9, and at last it will increment value to 10. 10 is not less than 10. 10 is equal to 10. So this condition is not satisfied, so it will break loop. This is C program in order to print numbers from 0 to 9. For example, if you want to print numbers from 0 to 99, then you need to use here a less than 100. So it will place 0, 1, 2, 3, so on until 99. For example, if you want to print numbers from 0 to 100, then just you need to write here a less than or equal to 100. So at last it will take 100. 100 is less than or equal to 100. So I'll get output from number 0 to 100. This is C program for loop. At first you need to write start. After that you need to initialize value to a variable. So you need to write initialization in rectangle. After that you need to give condition. I already said before, you need to give condition in rhombus. So give condition in rhombus. Until given condition is satisfied, statements will be printed. Whenever it prints statements, it will increment values. So write here increment or decrement operator in rectangle. Until this condition is true, statements inside this for loop will be printed. And whenever it prints statement, it will increment value. And after incrementing value, again it will check condition. And at last, if condition is false, then we can stop for loop. So at last right here stop. This is flowchart for loop. Next I will explain while loop. Guys, this definition is same for all these three loops. So you can write this definition for while loop. This is syntax for while loop. At first you need to write while, and inside brackets you need to give condition. Until this condition is satisfied, then whatever the statements that are present inside this while loop will be executed. Guys, definitely you need to give here increment and decrement operator. Guys, I will give one example so that you can clearly understand what is this while loop. Same program which I have explained before for loop, I will explain the same program by using while loop. Here I want to print how are you 10 times. So at first I am writing here int a equal to 1 starting from number 1. So I written here int a equal to 1. After that, inside while I am giving condition, that is a less than or equal to 10. Open curly bracket. Inside this you can give your statement, that is how are you slash n double quotations close bracket semicolon. Here you need to write increment operator, that is a plus plus. Guys, definitely you need to give here increment operator, because we are incrementing each and every value. So at first it will take value 1. 1 is less than 10. Condition is satisfied. So it will print how are you. Again it will increment value to 2. 2 is less than 10. Condition is satisfied. So again it will print how are you. It will increment value to 3. 3 is less than 10. It will print how are you. Again it will increment value to 4, 5, 6, 7, 8, 9, 10. At last it will take value 10. 10 is equal to 10. So this condition is satisfied. So I will get output how are you from 1 to 10. So total 10 times it will print how are you. For example, if you want to print how are you 100 times, just in place of 10 you can give here 100. So whenever you give like this, you will get output how are you 100 times. For example, I want to print numbers from 1 to 5. So at first I written int a equal to 1 because I am starting from 1, and I am giving condition, that is while a less than or equal to 5. Here I am giving a less than or equal to 5 because I want to print numbers from 1 to 5. So starting from 1 to 5. In order to print this value, you need to write printf %d comma a, because value is present in variable a. So I written here %d comma a, and here you need to write a plus plus. Whenever you execute this program, at first it will take value 1 because I given here a equal to 1. So at first it will take 1. 1 is less than 5. So it will print value 1. Printf %d comma a. Whatever the value that is present inside this variable a will be printed as output. So I will get output 1. So by using increment operator a plus plus, it will increment value 1. So after incrementing value 1, I will get value 2. 2 is less than 5. Condition is satisfied. So it will print 2. And again it will increment value to 3. 3 is less than 5. So it will print 3. Again it will increment value to 4. 4 is less than 5. So it will print 4. And again it will increment value to 5. 5 is equal to 5. Condition is satisfied. So I will get output 5. So again it will increment value, that is 6. 6 is not less than or equal to 5. 6 is greater than 5. So it will break while loop. We call this for loop and while loop as entry controlled loops, because at first it will check condition. Only if this condition is true, then whatever the statements that are present inside this loop will be printed. If this condition is false, then whatever the statements that are present inside this loop will not be printed. So we call this for loop and while loop as entry controlled loops, and we call this do while loop as exit control loop, because at first it will print statements. After printing statements, it will check condition. For entry controlled loops, at first it will check condition. Only if condition is true, then whatever the statements that are present inside this loop will be printed. But whereas for exit control loop, at first it will print statements. After printing statements, it will check condition, whether condition is true or not. I will explain this do while loop. This is syntax for do while loop. At first you need to write do. Inside this do, you need to give some statements, and at last you need to give here increment or decrement operator. Here write while, and inside bracket you need to give condition. And you need to remember one important thing, that is here definitely you need to use semicolon. For do while loop, for while condition, at last you need to give semicolon. I will give one program so that you can clearly understand what is this do while loop. Here I want to print numbers from 1 to 10 by using do while loop. So at first I am writing here int a equal to 1 because I am starting from 1, and here you need to write do. In order to print this value, you need to write printf %d/n comma a. Guys, for all these three loops, definitely you need to use increment operator or decrement operator. Here I want to get output from 1 to 9. I keep on incrementing values, so here I need to use increment operator, that is a++. Close bracket, and inside while you need to give condition. So you need to write here while. Here I want to print output from 1 to 10. So here inside this while loop I am giving condition, that is a less than or equal to 10. And definitely you need to give here semicolon for do while loop, and close this main function. Whenever you execute this program, at first it will print value 1. After that it will check condition. So condition is true. So again it will print 2, 3, 4, 5, 6, 7, 8, 9, 10. So by writing this program, I will get output 1 to 10. For example, if I want to print numbers from 1 to 1000, then just in place of 10 you need to give here 1000. Whenever you give here 1000, then you will get output from 1 to 1000 numbers. Guys, this is flowchart for while loop and do while loop. This is flowchart for while loop. At first you need to start here. For while loop you need to give while condition. Until this condition is satisfied, whatever the statements that are present inside this while loop will be executed. Whenever condition fails, then it will stop this loop. This is meaning of this while loop flowchart. Next I will explain flowchart for do while loop. At first you need to write do. Inside this do, you need to give some statements, and these statements will be printed until this while condition is satisfied. Here you can give while condition. Until this while condition is satisfied, then whatever the statements that are present inside this do will be printed, and whenever condition reaches to false, then it will stop this loop. In exam they may ask difference between while loop and do while loop. Here I given value of a as 100, but here I given condition, that is a less than 10. 100 is not less than 10. 100 is greater than 10. So whatever the statements that are present inside this while loop will not be executed. So here I will not get any output, because in while loop at first it will check condition. Only if that condition is true, then whatever the statements that are present inside while loop will be executed. But whereas in do while loop, here I given value of a as 100. 100 is not less than 10. 100 is greater than 10. So here I will get output 100, because in do while loop at first it will print statement. After printing that statement, it will check condition. So here at first it will print 100. After that it will check condition. 100 is not less than 10. 100 is greater than 10. So it will stop this loop. So whereas in while loop it will not print any output, but whereas in do while loop it will print first value. Guys, in exam they may ask explain control structures. Control structures are classified into three types. They are conditional statements, loops, and conditional operator. Here conditional statements contains if, else, if, switch, and nested if statements. Whereas loops contains while loop, do while loop, and for loop. Conditional operator is nothing but ternary operator. So whenever control structures question comes in exam, then you need to explain all this in detail. Guys, just remember these basics. Int will occupy 2 bytes of memory, and for some systems it will occupy 4 bytes of memory, whereas character will occupy 1 byte of memory and float will occupy 4 bytes of memory. Next topic is break, continue, and goto statements in C. At first I will explain what is a break statement. This break statement is loop control statement. That means if you want to break any loop, then you need to use this break statement. I will give one example so that you can clearly understand what is this break statement. Now I am using break statement inside for loop. I want to print numbers from 0 to 9. So here I took for loop. Inside for loop I written int I equal to 0, I less than 10, I plus plus. And in order to print these numbers from 0 to 9, I need to write here printf 0, 1, 2, 3. All these are integers. So I written here printf %d comma I, because all these values are present in variable I. So I written here printf %d comma I. By writing this program, I will get output as, at first it will take value 0. 0 is less than 10. Condition is satisfied. So it will print 0. Here I written I plus plus. So again it will increment value, that is 1. 1 is less than 10. Condition is satisfied. So it will print 1. Again it will increment value. Now it will take 2. 2 is less than 10. Condition is satisfied. So again it will take 3. 3 is less than 10. Condition is satisfied. So it will print 3. Like that it will print up to 9 numbers. 5, 6, 7, 8, 9. 9 is less than 10. So it will print 9. and again it will increment value, that is 10. 10 is not less than 10. 10 is equal to 10. So it will break this condition up to 9. So it will stop this loop. Now here I am using break statement. If I equal to 4, break, and you need to give semicolon for break. That means if I get I value as 4, then I want to break this loop. This is meaning of this. If I equal to 4, break. Whenever I write this, at first it will print value 0, again it will print 1, 2, 3 and 4. Whenever it reaches to 4, then it will break this loop. So by writing this program, that is if I equal to 4 break, then I will get output as 0, 1, 2, 3, 4. This is my output. This is program for break statement. I am starting loop, and inside this loop I am writing condition in order to break the loop, like if I equal to 4, break. So inside for loop I am writing condition to break the loop. If this condition is true, then it will break the loop, else if condition is false, then it will continue this loop. This is flowchart for break statement. Next I will explain continue statement. This continue statement is same as break statement. Only difference is that break statement is used to terminate the loop, whereas continue statement is used to continue the loop. I will give one example so that you can clearly understand what is continue statement. In this program I given condition, that is if I is equal to 4, then I given condition as break. So by writing this program I will get output as 0, 1, 2, 3, 4. But here in place of break, if I write here continue, by writing this program I will get output as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. In continue, if I reach value to 4, it will continue the loop. So by writing this program I will get output as 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is my output. Whereas in break, if condition is false, then it will continue loop, and if condition is true, then it will break the loop. But whereas in continue, if condition is false, then it will continue the loop, and whereas if condition is true, even though it will continue this loop. Same example, if I reach value to 4, it will continue the loop. So if condition is false, then it will continue the loop, and if condition is true, even then it will continue this loop. So this is program and flowchart for continue statement. Guys, whenever break statement question comes in exam, you can also write switch statement example, because in switch statement also we use break condition. So you can also write switch statement as example. Next I will explain goto statement. If I write any program by using goto statement, then that program is very hard to understand, and modification of that program is very hard. So any programming language do not recommend goto statement. This is syntax of goto statement. At first you need to write goto, and you need to write label. Label is nothing but any text, any name is known as label. It should not contain any keywords. So at first you need to write goto label, and label contains some statement. I will give one program so that you can clearly understand what is goto statement. This is program for goto statement. At first you need to write goto. Label is nothing but any plain text. Here I am giving any text like college. I given label as college, and definitely you need to give here semicolon. Now you need to write label, and label contains statement. Here I given label as college, so you need to write here college colon. Statement is nothing but I am writing statement as printf my college. By writing this program I will get output as my college. Here at first I didn't go to, I given label as college. So this college contains statement, that is my college. So by writing this program I will get output as my college. This is flowchart for goto statement. Here at first I written label 1. This label 1 contains statement 1, and similarly label 2 contains statement 2, and label 3 contains statement 3. After that I return go to label 3. That means it will go to label 3. Label 3 contains statement 3. So whatever the statement 3 that this label 3 contains, I will get this statement 3 as output. For example, if I write here go to label 2, then whatever the statement that this label 2 contains, I will get this statement 2 as my output. This is flowchart for goto statement. Guys, now I will explain C program in order to print this 4 table by using goto statement. Here total I need to take 2 variables. One is for this number 4, and another one is for number 1, 2, 3, 4 up to 10. For example, I will take variable name as number num for this number 4, and I will take another variable that is for number 1, 2, 3, 4 up to 10. For example, let variable name be I. So here I am taking 2 variables. One is for number 4 and another one is for number 1 to 10. So here you need to write int. These both are integers. So here I need to write int number equal to 4, comma. Here I value starts from 1. So here I need to take I equal to 1. Now we will write goto statement. At first I am taking label. Let label name be table. You can also take any label name. Here I am taking label name as table. Give colon. Now write printf %d into %d is equal to %d. This %d is for number, that is number 4. And this %d is for variable I, and this %d contain result. Result is nothing but number into I semicolon. At first you need to write 4 into 1 equal to 4. After 4 into 1, you need to take 4 into 2. After 2, 3. After 3, 4. Like that you need to write up to 4 into 10 equal to 40. So here we keep on incrementing I value like 1, 2, 3, 4 up to 10. So here you need to write I plus plus. Now give condition. Here you want to print 4 table up to 4 into 10 equal to 40. So here you need to give condition, that is if I value is less than or equal to 10, that is from 4 into 10. If I value is less than or equal to 10, go to table. Here I given label name as table. So here you need to write go to table semicolon. By writing this program, you will get output as 4 into 1 equal to 4, 4 into 2 equal to 8, 4 into 3 equal to 12. Like that you will get up to I less than or equal to 10. That is 4 into 10 equal to 40. Up to 4 into 10 equal to 40, I will get my output. This is how we print tables by using goto statement. For example, if you want to print 10 table, then here in place of 4 you need to write 10. That's it. This is how we print tables by using goto statement. This is important question. Like in exam they may ask like write 5 table by using goto statement. So whenever that question comes in exam, you need to write this program. Next topic is storage classes in C, and also I will explain scope and lifetime of a variable in C. At first I will explain scope of variable. A defined variable can have its existency, and beyond that we cannot access that variable. That means, for example, if we define any variable, like I am defining variable as int a equal to 10. This a is my variable, and I declared this variable inside main function. Inside main function, I declared variable name as a. Scope is nothing but existence of a variable. For example, here I return int a and I return this inside main function. So this variable a existence is only inside main function, and I cannot access this variable a outside the main function. So a defined variable, this defined variable is a. A defined variable can have its existence, and beyond that we cannot access that variable. So I cannot access this variable a outside the main function because this existence is present only inside main function. This is meaning of scope of variable. In C programming we can declare variables in two places. One is inside the function and another one is outside the function. For example, variables which are declared inside the function is known as local variable, and variables which are declared outside the function is known as global variable. I will give example of local variable. At first you need to write hash include stdio.h. After that void main. This is main function which I am taking. Inside main function I am declaring variable, that is int a equal to 10. I given variable name as a and value as 10, data type as int. Now I want to print value 10. So for that purpose we need to use printf. This a is integer, so you need to take here %d comma a. So by writing this code I will get output as 10. So this a is local variable because we declared this a inside main function. So we call it as local variable. Now I will explain program for global variable. Same program which I written before. At first I written hash include stdio.h. After that I written int a equal to 10. Here I am declaring variable outside the function. So we call this a as global variable. After that you need to write void main. Inside void main you need to write printf %d comma a. By writing this program you will get output as 10. Here we declared variable inside main function, so we call this variable a as local variable, and whereas here we declared variable a outside the main function, so we call this a as global variable. Here variable existence is only inside the function, that is only inside this block, and whereas here variable existence is present until entire program. Lifetime of a variable is a time for which particular variable is present in our memory. How much time particular variable is present in our memory, this is known as lifetime of a variable. We can store variable either in main memory or in CPU register. These are two storage locations in order to store particular variable. Scope and lifetime of a variable is specified by storage classes. Storage classes are used to specify where to store the variable, that is either we need to store variable in main memory or in CPU register, and storage classes are used to specify scope and lifetime of a variable. Storage classes are classified into four types. One is auto, and next one is static, and next one is extern, and last one is register. These are four storage classes that we need to use. Guys, you need to remember this table. First one is auto. Here I written auto int a equal to 10. Whenever you declare like this, then this variable a is stored in main memory and the scope is within the block. That means I can access this variable only within this block. I cannot access this variable outside the block, and lifetime of a variable is until end of block. That means this variable will expire whenever I close this block. In place of auto, if you use static, then this variable a is stored in main memory and scope is within this block. That means we cannot access this variable outside the block. And lifetime is till end of the program. That means variable is present whenever we declare this variable and until end of the program this variable will be present. So this lifetime is until end of the program. And next one is register. In place of static, if you declare register, then this variable a is stored in CPU register and scope is within this block. That means I can access this variable a only within this block, and lifetime is until end of the block. That means from starting variable declaration to until end of this block, this variable will be present. Next one is extern. If you use extern, then variable is stored in main memory and scope of variable is global multiple files. Whereas in auto, static and register, scope is only within the block. That means we can access this variable only inside this block and we cannot access this variable outside the block. But whereas in extern, scope is global multiple files. That means we can access this variable even outside the block, and lifetime is till the end of the program. Now I will explain program. Guys, this is program for auto. Here I written hash include stdio.h. After that I written void main, and here I declared auto int a equal to 10. Whenever you declare like this variable a is stored in main memory. And here I written printf %d comma a. Whenever you write like this, you will get output as 3 because value of a is 3, so I will get output as 3. For example, if you want to use static, then just in place of auto you need to declare static, and if you want to use register, then just you need to write here register in place of auto. So whenever you write register int a equal to 3, then this variable a is stored in CPU register. Next, this is program for extern. If you want to use extern storage class, the name itself says extern mean we need to declare variable outside the main function. So if you want to use extern storage class, then you need to declare variable outside the main function. So here I written hash include stdio.h. After that I written extern int a equal to 1. After that I written void main, and inside void main I written printf %d comma a, where auto, static and register are declared inside main function. But if you want to use extern storage class, then you need to declare this extern storage class outside the main function. So I written here extern int a equal to 10, and inside main function I written printf %d comma a. Whenever I write like this, I will get output as 1 because value of a is 1. Next topic is what is type conversion. Converting one data type value into another data type is known as type conversion. We also call this type conversion as typecasting. There are two types of type conversion. One is implicit type conversion and next one is explicit type conversion. Now I will explain what is implicit type conversion. Implicit type conversion converts smaller data type value to larger data type. For example, if you consider integer, this integer is smaller data type. So if we convert this integer to any larger data type like float, then we call it as implicit type conversion. In implicit type conversion, converting one data type to another data type is done by system itself automatically. So definition of implicit type conversion is the type conversion which is done by system itself automatically is known as implicit type conversion. I will give one example so that you can clearly understand what is implicit type conversion. In this program, I written int a equal to 10 by 3. After that I written printf %d comma a. For example, if you calculate this 10 by 3 in your calculator, actually you should get value as 3.333, so on. But here I will get output as 3 because here I took integer, so it will print only integer value. So computer automatically converted one data type into another data type. This is known as implicit type conversion. In implicit type conversion, conversion which is done by system itself automatically is known as implicit type conversion. So it automatically converted this 3.333 value into 3. Next I will explain explicit type conversion. Implicit type conversion converts smaller data type to larger data type, whereas explicit type conversion will convert larger data type to smaller data type. And definition of explicit type conversion is type conversion which is done by user manually is called explicit type conversion. In implicit type conversion, converting one data type to another data type is done by system itself automatically. But whereas in explicit type conversion, converting one data type to another data type is not done by system automatically. So user should manually convert one data type to another data type. I will give an example so that you can clearly understand what is explicit type conversion. This is program. Here I written float a equal to 10 by 3. Value of this variable a is 10 by 3. After that I written printf. For float we need to use %f comma a. By writing this program, I will get output as 3.000. Actually value of 10 by 3 is 3.333. But here I got output as 3.000, which is wrong value. Why I got wrong output? Because though I given here data type as float, here I took value as integer. This 10 is integer and this 3 is integer value. So I got output as 3.000. In explicit type conversion, converting one data type to another data type is not done by system automatically. So here system unable to convert this integer value to float value. So I got here wrong output. For example, here in place of 10, if you give here 10.0 and in place of 3, if you give here 3.0, then you will get output as 3.333. So here system unable to convert this integer values to float value. So here I got output as 3.000, which so user should manually correct it. So here I manually changed this value of 10 to 10.0 and 3 to 3.0. This is known as explicit type conversion. Next I will explain C program to check whether number is even or odd. Before that you need to know what is even number and what is odd number. For example, if we divide any number by 2 and if we get remainder as 0, then we call it as even number, else we call it as odd number. I will give one example. For example, if you consider 4, if we divide this 4 by 2, 2 2s are 4, so we got remainder as 0, so 4 is even number. For example, if you consider 5, 2 2s are 4, I got remainder as 1, so this 5 is not even number, this 5 is odd number. I will write C program to check whether number is even number or odd number. I took here int, I given variable name as number num. I want to check whether 5 is even number or odd number, so I given here value of number as 5. Now I want to check whether this 5 is even number or odd number. If number is divided by 2 and if we get remainder as 0, then it is known as even number. So write here printf even number, semicolon, close bracket, else printf odd number, close bracket for else, and next close bracket for this main. This is program to check whether number is even or odd. Here if we divide 5 by 2, we will get remainder as 1, not 0. So this 5 is odd number, so output is odd number. Next I will explain what is an expression. Here I written b equal to c plus d. We call this c plus d as expression, where c and d are operands and plus is operator, and this b is variable. Not only c plus d, for example, if you consider a into b plus c, we call this abc as operands and this into and plus as operators. We call this as expression. A into b plus c is an expression. A plus b plus c by 3. This is also an expression. Expression is combination of operands and operators. There are various types of expressions. These are the examples of arithmetic expressions like 10 into 20, 10 plus 20, a plus b into c. All these are examples of arithmetic expression. Next, examples of logical expressions. They are a or b, a and b. These both are examples of logical expression. And next, a not equal to b, a less than or equal to b. These are the examples of relational expression. Next, I will explain what is precedence and associativity. Precedence means priority, which operator has high priority and which operator has low priority. Here first priority is for brackets, and next second priority is for multiplication and division, and third priority is for plus and minus. This is an example. Here we need to give first priority for multiplication. So at first we need to calculate 1 into 2, that is 2. After that we need to give priority for addition. So after that 2 plus 3 is 5. This is another example. Here we need to give first priority for brackets. So at first we need to calculate 1 plus 2 because they are present in brackets. So 3 into 3 plus 1. After that next priority is for multiplications. After that we need to multiply 3 into 3, that is 9 plus 1. Last priority is for addition. So 9 plus 1 is 10. This is my answer. Precedence is nothing but priority, which operator has high priority and which operator has low priority. Based on that we need to perform calculations. Next I will explain what is associativity. Here this plus and minus, both operators has same priority. Precedence of this plus and minus is same. If two or more operators of same precedence appear in expression, then at that time we need to use associativity. That is from where we need to start calculation. We can start calculation either from right to left or left to right. This plus and minus both are arithmetic operators. For arithmetic operators, associativity is from left to right. So we should start from left to right. So at first we need to perform 1 plus 2, that is 3. After that 3 minus 3, that is 0. This is my result. This is precedence and associativity table. Definitely you need to write this table in exam. Whatever the examples that I explained, you need to write these examples and as well as this table in exam. Next topic is command line arguments in C. Why we call it as command line arguments? Because whenever you write command line argument program and then you execute it, then it will open command prompt. Whenever you execute command line argument program, then it will open command prompt, and inside command prompt you need to pass arguments. For example, testing. Testing is argument. So arguments which are passed from command line is known as command line arguments. Arguments passed from command line are called command line arguments. These arguments are handled by main function. Normally we write main function like this, and we do not pass any arguments inside this main function. But whereas in command line arguments you need to write syntax like this: void main, and inside main function you need to pass two arguments. One is argc, that means argument count, and next one is argv, that means argument vector. So in order to support command line arguments, you need to change structure of main function like this. This is syntax you need to remember. In above syntax, the command line arguments, they are argument count and argument vector, have been handled via main function. In above statement, these command line arguments are handled by main function, where argc mean argument count, that denotes number of arguments to be passed. How many arguments we are passing, it will count that arguments. And next one is argv, that means argument vector, that denotes a pointer array. This is pointer array that is pointing to every argument that has been passed to your program. That means by using this argument vector, we can pass arguments. These arguments are string type. So character along with array represents string. And whereas argument count is integer, because how many arguments that we are passing, it will count those arguments. For example, in command prompt, I am passing two arguments like testing and testing. I can pass these arguments, that is testing and testing, by using argument vector, because character along with array represents string. So this testing is string character, so I can pass this arguments by using argument vector. And whereas argument count, name itself says, it will count how many arguments that we are passing. So we are passing two arguments, so count will be 2. This 2 is integer, so here I written int argc, that is to count arguments. And next one is argument v. By using argument v, we can pass arguments. You must make sure that in your command line arguments, argument vector 0 stores the name of your program, and similarly argument vector 1 gives a pointer to the first command line argument that has been supplied by the user, and argument vector n denotes the last argument. Meaning of this is, for example, this a.out is my program name. This program name is stored in argument vector 0, and I am passing argument, that argument name is testing. So this testing is stored in argument vector 1. For example, if I write testing again, then this is stored in argument vector 2. I will give one program so that you can clearly understand. This is program for command line arguments. At first you need to write hash include stdio.h. After that you need to write int main, and inside main you need to write int argument count, that is argc, comma character pointer argument vector. Now open bracket, inside this you need to write printf program name. Inside this you need to write program name. Program name is string type, so you need to write here %s/n, comma this program name is stored in index number 0. So here you need to write argument vector 0. Meaning of this is, this program is string type that is stored in argument vector 0. Next, write if argument count is equal to 2. If argument count is 2, for program name count is 1, and if you pass any argument, then count will be 2. So if argument count is equal to 2, then printf the argument supplied is %s/n, comma argument vector 1. Whenever you write this, for example, my program name is a.out. This a.out is stored in argument vector 0, and for example, I want to pass argument, that is testing. Whenever you pass this argument, then you will get output as the argument supplied is testing, and this testing is stored in argument vector 1. This testing is string character, so I written here %s. Next, else if argument count is greater than 2, that means if I pass multiple arguments, then I will get output as printf too many arguments. For example, if I pass this same argument again, that is if I pass this testing again, then I will get output as too many arguments, because for this program name count will be 1, and for this argument count will be 2, and for this count will be 3. So condition is if argument count is greater than 2, so I will get output as too many arguments. Next, else if I do not pass any arguments, then I will get output as printf no arguments. For example, if I do not pass any arguments, then I will get output as no arguments. Next, I will explain unit 2. I will explain all these topics in unit 2. At first, I will explain what is an array and what is one-dimensional array and two-dimensional array. Guys, arrays are used to store multiple values in single variable instead of declaring separate variable for each value. For example, if I want to declare value to a variable, then I need to declare like int a equal to 10, comma b equal to 20, comma c equal to 30, comma d equal to 40. For each value, I took separate variable. For example, if I want to store value 10, I took variable a. And if I want to store value 20, I took B. And similarly, if I want to store 30 and 40, then I took variable C and variable D. But if I want to store all these values 10, 20, 30 and 40 in single variable, for that purpose we use arrays. For example, instead of taking separate variable for each value, I can take only single variable and then I include values in that. Int a of, this is square bracket. To create an array, define data type, array name and square brackets. This is an example. Here I took int a of 5 equal to 10, 20, 30, 40 and 50. Where int is data type, a is name of an array and 5 is size of an array. We need to include size in square brackets. Here 5 represents size of an array. For example, if I want to store 5 values like 10, 20, 30, 40 and 50. If I want to store 5 values, then I need to include size as 5. For example, if I want to store 15 values, then here I need to include size as 15. You need to include values inside curly brackets and you need to close with semicolon. An array contains data type, array name and size of an array, where we need to include size of an array in square brackets. Or you can also write like this: data type, variable name, size. Variable name and array name both are same. Example, int a of 5, where we need to include 5 in square bracket. Guys, it is not mandatory to include size of an array. You can also write like this. Int a open square bracket and close square bracket is equal to 10, 20, 30. Whenever you declare like this, whenever you do not include size, then automatically this array will take size. Automatically it will count these values 10, 20, 30. Total there are 3 values. So automatically it will take size as 3. So it is not mandatory to include size of an array. An array must contain only similar type of elements. For example, here I took int a. So I need to declare only integer elements here. And array should not contain mixed type of elements. For example, here I took one value as integer, one value as float and one value as character. I should not declare like this. If I declare like this, it will display error. So if I declare here float, I need to take only float elements. If I declare here character, I should take only character elements. And if I take here integer, I should take only integer elements. I should not declare mixed type of elements in an array. Here I took int a of 5. That means size of an array is 5. Whenever I declare size as 5, this array will create 5 memory locations 1, 2, 3, 4, 5 because I given size as 5. So an array will give index numbers for this. You need to remember one important thing, that is index number always starts with 0, not with 1. Here I given values 10, 20, 30, 40. Here I took size as 5 but I given only 4 values. So this value 10 is stored in index number 0, value 20 is stored in index number 1 and 30 and 40 are stored in index number 2 and 3. This is how values are stored in an array. Example, if I declare here value as 50, then this 50 is stored in index number 4. Total I given 5 values 10, 20, 30, 40 and 50. So it created 5 memory locations and first location starts with index number 0. So this first value is stored in index number 0. Similarly, second, third, fourth, fifth values are stored in index number 1, 2, 3, 4. This is how we store elements in an array. This is simple program of how to access elements in an array. Here I took int a. This square bracket represents array. Here I took integer because I want to declare integer values. So I took data type as int. Int a square brackets open and close is equal to, I given values as 10, 20, 30, 40. All are integer values. You need to include values inside curly brackets. Otherwise, it will display error message. And close statement with semicolon. Printf %d. Here I took %d because for integer we use format specifier %d, comma a of 0. That means whatever the value that is present inside index 0 will be printed as output. I already said before, first value is stored in index number 0 and second value is stored in index number 1, third in index 2 and fourth in index 3. Here I took a of 0, so output is 10. For example, if I take here a of 1, then value which is present in index number 1 will be printed as output. So output is 20. This is example. This is another example. Here I took float data type because I want to declare float values. So I took here float data type. I want to print all these values. I want to print 1.5, 1.6, 1.7. So for that purpose, I need to write %f, %f, comma %f. I took 3 format specifiers because I want to print three values as out, comma, a of 0, comma, a of 1, comma, a of 2. That is values which are present in index number 0, index number 1 and index number 2 will be printed as output. So output is 1.5 which is present in index number 0, 1.6, comma, 1.7. This is output. Here for this program I got output as 10 because here I declared index number 0. So I got output as 10. But I want to change this value 10 to 100. So for that purpose I need to write a of 0 is equal to 100. That means value which is present in index number 0 is changed to 100. So now I will get output as 100. For example, if I want to change this value 20 as 200, then I need to write a of 1 is equal to 200. This is how we manipulate elements in an array. For example, I want to get output values along with index numbers like a of 0 is equal to 25, a of 1 equal to 35. I want to get output like this. So for that purpose I use for loop. These are the four values that I declared to an array A. They are 25, 35, 45 and 55. And similarly for these index numbers are integers. So here I took int I. Now I need to write for loop for index numbers. So here I took four values. 25 stored in index number 0, 35 in 1, 45 in 2 and 55 in index number 3. So every index number starts with 0. So here I took I is equal to 0, semicolon, I less than 4 because till 3 now. So I took here I less than 4, semicolon, I plus plus. Inside for loop, I need to write statement in order to print output. For that purpose, I use printf. Inside double quotations, I need to write a of percentage d is equal to percentage d. This percentage d belongs to index number and this percentage d belongs to array of elements. So by writing this statement, I will get output as a of 0 is equal to 25, a of 1 is equal to 35, a of 2 equal to 45 and a of 3 equal to 55. This is output. Here value of I starts with 0. So at first it will replace value of I with 0. And similarly a of I, value of I is 0. A of 0 means value which is present in index number 0 will be printed as output. So I will get output as a of 0 is equal to 25. Until this condition is satisfied, I will get output. Till now what we have discussed is one dimensional array. In one dimensional array contains only one square bracket where we will include size in it. But in two dimensional array contains two square brackets where first square brackets represent size of rows and second square bracket represent size of columns. This is one dimensional array. It contains only one square bracket where we include size in it. But in two dimensional array it contains two dimension, that is two square brackets where first square bracket represents size of rows and second square bracket represent size of columns. For example, if I declare a of 2 into 2, that means it will create 2 rows and 2 columns where I can store 4 elements in it, that is 2 into 2, that is 4 elements I can store in it. And this two dimensional array looks same like matrix. In matrix also we store same like this. So we can also call this two dimensional array as matrix. This is syntax of two dimensional array. It contains data type, array name, size of rows and size of columns where we need to include square brackets for size of rows and size of columns. This is example int a of 2 into 2, that means it will create 2 rows and 2 columns where 2 into 2 I can store 4 elements in it. A of 0 0, it will start with 0. A of 0 0 represents first row first column and a of 0 1 represents first row second column and a of 1 0 represents second row first column and similarly a of 1 1 represents second row and second column. This is an example. In this example I took int a of 2 into 2, that means it will create 2 rows and 2 columns. 2 into 2 means I can store 4 values. So I am declaring 4 values as 1 2 3 4. Whenever I declare this, it will create 4 storage locations, that is 1 is stored in first row first column, 2 is stored in first row second column, 3 is stored in second row first column and 4 is stored in second row second column. You can also declare like this, both are same. This is an example of two dimensional array. In this example I took 3 rows and 3 columns. So I can store 9 values in it. So I am taking values as 1 2 3, 2 3 4 and 4 5 6. Without including these curly brackets also you can write. And next I took int I equal to 0 and j equal to 0. That means this I belongs to rows and this j belongs to columns. As I said before, every index number starts with 0. So here I took I equal to 0 and j equal to 0. So now I need to take two for loops. One is for rows and one is for columns. So here I took for loop as I equal to 0, I less than 3 and I plus plus. That means it will create 3 rows 0, 1, 2. And similarly for column, j equal to 0, j less than 3, j plus plus. That means it will create 3 columns. They are 0, 1 and 2. And in order to generate output, I need to write printf percentage d. This percentage d belongs to row I, and similarly next percentage d that belongs to column j is equal to percentage d. This percentage d belongs to values. So by writing this printf statement, I will get output like this. As I said before, every index number starts with 0. So I took value of I as 0 and j as 0. That means it will replace value of I row with 0 and value of column with 0. And a of 0 0 means value which is in first row and first column. So I will get output as 1. Similarly 0 1 means value which is in first row and second column. So I will get output as 2. This is output. This is an example of 2-dimensional array. Next topic is 3-dimensional array. For example, if you consider 2-dimensional array, in 2-dimensional array it contains only 2 dimensions, where first dimension represent rows and second dimension represent columns. That means total I can store 2 into 2. That means I can store 4 elements. Let elements be 1, 2, 3, 4. This is how 2-dimensional array looks like. But in 3-dimensional array, it contains 3 dimensions. This is an example of 3-dimensional array. Here I given A of 2 into 2 into 2. That means total I can store 2 into 2, 4, and 4 into 2, that is 8. I can store 8 elements. Let elements be 1, 2, 3, 4, 5, 6, 7, 8. This is how we represent 3-dimensional array. I will explain 3-dimensional array program. At first I written hash include stdio.h. After that I written void main. Inside void main I written int a, where a is array name. Inside square brackets I written 2 into 2 into 2. Where this 2 represents first dimension, this 2 for second dimension, and this 2 for third dimension. This represents 3-dimensional array. 2 into 2 4 and 4 into 2 8. Total I can store 8 elements in this 3-dimensional array. Let 8 elements be 1, 2, 3, 4, 5, 6, 7, 8. These are the 8 elements that I am going to store in this 3-dimensional array. I want to print output along with index numbers. So for that purpose here I took 3 for loops. This first for loop is for first dimension, second for loop is for second dimension, and third for loop is for third dimension. Here I given size as 2. That means it will store 2 elements. First element is in index number 0 and second element in index number 1. So here I written for int I equal to 0 semicolon I less than 2 semicolon plus plus I. Similarly for the second dimension I written int j equal to 0 j less than 2 plus plus j. And for this third dimension I written here int k equal to 0, a less than 2, and plus plus k. Inside this we need to write printf open double quotations a of percentage d for first dimension, next percentage d for second dimension, and percentage d for third dimension, that equal to percentage d. This is for element. First dimension is I, so this is for I, and the second dimension is for j, and third dimension is for is equal to percentage d. This is for element. These are the elements present in this 3-dimensional array. Now I want to print this element. So for that purpose I written here percentage d that belongs to a of ijk will be printed as output. By writing this program I will get output as this is output for this 3-dimensional array. We open 3 for loops so that we need to close this 3 for loops, and at last this curly bracket is for void main. This is how we write 3-dimensional array program. Next I will explain program for transpose of a matrix. Before that you need to know what is transpose of matrix. For example, this is 2 cross 2 matrix. It contains elements like 1, 2, 3, 4. It contains 2 rows and 2 columns. So it is 2 cross 2 matrix. Now I want to find transpose for this matrix. Let this matrix be A. Now I want to find A transpose. Transpose is nothing but we need to represent columns as rows. For example, this is first column. This first column contains 1 and 3. Now we need to represent this column as rows. So I need to write here 1, 3. And similarly second column as second row 2, 4. Now we call it as transpose of matrix. I will explain program for transpose of a matrix. Here I written int a, where a is array name, and inside square brackets I written 2, where these 2 represent rows and these 2 represent columns. 2 into 2. That means total I can store 4 elements. Let 4 elements be 1, 2, 3, 4. These are the 4 elements 1, 2, 3, 4, where this 0 represent first row and this 0 represent first column. Similarly this 1 represent second column and this 1 represent second row. Here I written a of 0 into 0. That means value which is present in first row and first column will be printed as output. So I will get output as 1. And similarly 0, 1. That means value which is present in second row first column will be printed as output. So I will get output as a of 0, 1 equal to 2, and similarly a of 1, 0 equal to 3, and a of 1, 1 equal to 4. I want to print output like this. Let int I represent rows and int j represent columns. Here total there are 2 rows and 2 columns where this row starts with 0 and end with 1. Similarly columns start with 0 and end with 1. Here I took 2 for loops. This for loop is for row and this for loop is for column. Here rows and columns starts with 0 and ends with 1. So here I written here int I equal to 0, I less than 2, I plus plus. Similarly j equal to 0, j less than 2 and j plus plus. Inside this I written printf a of percentage d. This percentage d is for row I and similarly this percentage d is for column j, that equal to percentage d. This percentage d is for value. In order to get output as value, I need to write a of ij. By writing this, I will get output as a of 0, 0 equal to 1, a of 0, 1 equal to 2, a of 1, 0 equal to 3 and a of 1, 1 equal to 4. Now I want to find transpose of a matrix. In order to store transpose of a matrix, I need to take another matrix int b and size as 2 cross 2 semicolon. In order to store transpose, here I took int b size as 2 cross 2. For example, this is our matrix, that is 1, 2, 3, 4. I should get transpose as 1, 3, 2, 4. Similarly, take 2 for loops. Whatever the for loops that you took before, to take same for loops. Transpose is nothing but we need to interchange rows and columns. So for that purpose, I written here b of ij is equal to a of ji. Now in order to print output, for that purpose again we need to write 2 for loops. For of inside this you need to write printf double quotations b of percentage d is equal to percentage d slash n double quotations close comma I comma j comma b of ij. By writing this entire code you will get output as this is output. This is output for transpose of a matrix. Guys, you need to remember one main formula, that is b of ij is equal to a of ji. This is formula in order to find transpose of a matrix. Next, C program for addition of two matrices. Let two matrices be matrix A and matrix B. This example, let two matrices be matrix A and matrix B. These both are 2 cross 2 matrix. That means it contains 2 rows and 2 columns. I want to add this matrix A and matrix B, and I want to store this result in matrix C. This program, this is matrix A and this is matrix B. Both are 2 cross 2 matrices. Matrix A contains elements, they are 1, 2, 3, 4. So here I written 1, 2, 3, 4 and matrix B contains elements, that is 5, 6, 7, 8. And then I want to add these two matrices and then I want to store this result in matrix C. So here I given C as 2 cross 2 matrix. Here total there are 2 rows and 2 columns. Row starts with 0 and ends with 1. 0 and 1 are 2 rows and 0 and 1 are 2 columns. So here I took 2 for loops. One is for rows and another one is for columns. And here I given condition, that is into I equal to 0, I less than 2 and I plus plus. Meaning of this is row starts with 0 and ends with 1. And similarly here I written for int j equal to 0, j less than 2 and j plus plus. This is for column, and inside this I written printf a of percentage d into percentage d is equal to percentage d. This is for row, this is for column and this is for result. By writing this code, I will get output as a of 0, 0 equal to 1. That means value which is present in first row and first column, that is 1. And similarly value which is present in first row and second column, that is 2. And similarly value which is present in second row first column, that is 3. And similarly value which is present in second row second column, that is 4. I will get this as output. By writing this code, my matrix A is printed on my output screen. Similarly I want to print matrix B. So for that purpose again we need to take same for loop. One is for row and another one is for column. I took 2 for loops which I took before, and inside this I written printf b of percentage d is equal to percentage d slash n comma I comma j comma b of ij. By writing this code, matrix B is printed on my output screen. Now I want to add these two matrix and I want to store this result in matrix C. So for that purpose again we need to take same 2 for loop, and inside this we need to write C of ij. I is for row and j is for column. C of ij is equal to a of ij plus b of ij. That means I am adding matrix A and matrix B, and I am storing this result in matrix C. Now by writing this code, addition of this matrix A and matrix B is stored in matrix C. Now I want to print this matrix C. Now I want to add this matrix A and matrix B, and then I want to store this result in matrix C. By writing this code, addition of matrix A and matrix B is stored in matrix C. Now I want to print this matrix C. So for that purpose again I need to take same 2 for loops, and inside this I need to write printf C of percentage d is equal to percentage d. This percentage d is for row I, and this percentage d is for column j, and this percentage d is for value which is present in rows and columns. So by writing this code, I will get output as addition of two matrices, that is matrix A and matrix B. So I will get result as 1 plus 5, that is 6, 2 plus 6, that is 8, and 3 plus 7, that is 10, and 4 plus 8, that is 12. This is output. This is how we perform addition of two matrices. Next, matrix multiplication. This is same as matrix addition, except here for matrix addition we took 2 for loops, but for matrix multiplication we need to take 3 for loops. Here you need to take another for loop, that is for of int k equal to 0, k less than 2, and k plus plus. Inside this we need to write c of ij plus equal to a of ik into b of kj, b of kj, and here you need to write before for loop k, you need to write c of ij is equal to 0. Rest everything is same program which you have written for matrix addition, except here you need to take 3 for loops, and inside this you need to write c of ij plus equal to a of ik into b of kj. This is program for matrix multiplication. By writing this, I will get output as, this is output for matrix multiplication. Next topic is strings and various functions of strings. We call group of characters as string. For example, college, boy, CSE, hello world, all these are group of characters. We call group of characters as string. For example, if you consider character data type, by using character data type, we can store only single character. For example, character A equal to C. We can only store single character by using character data type. But if you want to store multiple characters in single variable, then you need to use string. For example, if you consider other programming languages like Python, PHP, there is string data type, but in C there is no string data type. So if you want to create any string, then you need to use character data type along with array. By using character data type and along with array, you can create string. This is example. Character A, open square bracket and close square bracket. The square brackets represent array. Character A equal to hello world. You can write any string inside this, like name, college, etc. And definitely you need to include double quotations for string. For single character you need to include single quotations, but for multiple characters you need to include double quotations. Another important thing that you need to remember is, for string we use format specifier %s, where s stands for string. This is example program. Here I written character A, I open square bracket and then I close the square bracket. Inside square bracket we need to write size of string. For example, if my string contains 10 characters, then I need to write size of string as 10. This is example. For example, here my string name is boy. It contains 1, 2, 3 characters. So here I given size as 5. Whenever you give size as 5, that means maximum you can assign only 5 characters, or you can also assign less than 5 characters. This boy is 3 characters. So whenever you declare size as 5, that means you can assign 5 characters or less than 5 characters to the variable A. It is not mandatory to include size. You can also write like this: A, I open square bracket and then I close the square bracket. Inside this I did not given any size. Whenever you do not assign size to this variable, then automatically this variable A will count how many characters are present, like it will count 1, 2, 3. Total there are 3 characters, then by default it will take value as 3. So it is not mandatory to assign size of the variable. Next, string declaration. String declaration means I am not assigning any values to the string, just I am declaring string, like character A of 10. Here I did not assign any value. I will assign value by using scanf. So here I written just character A of 10. I will give one program. Here I written character A of 10. That means I can store up to 10 characters. And after that I written printf enter text. By writing this printf function in output screen, I can see enter text. And next I written scanf %s comma and A. And after that I written printf your text is %s comma A. By using this scanf function I can write string. So here I given string as hello. So whenever I write hello, I can see output as your text is hello. As I already said, in this first character is stored in index number 0 and second character in index number 1, third in 2 and so on. Index number starts with 0. First character is stored in index number 0. So whenever I write here printf %c comma A of 0, here I written %c because I want to print only single character. So here I written %c comma A of 0. That means value which is present in index number 0 will be printed as output. So in index number 0 value is h. So here I will get output as h. For example, if I want to change this value h to j, then here I need to write A of 0 equal to j. We need to write j in single quotations. That means value which is present in index number 0 will be changed to j. Now h is changed to j. That means value which is present in index number 0 will be changed to j. Now I will get output as JELLOWRLD. Instead of declaring string like this, you can also declare like this: character A, open square bracket, close square bracket, that equal to open curly bracket, and inside curly bracket for each character I need to include single quotations. After writing enter character, you need to write /0 at the end, where /0 is null terminator. Meaning of /0 is end of string. There are various functions present in string. I will explain each with an example. First one is strlen function, where strlen stands for string length. If you want to find the length of string, then you need to use strlen function. This is example. Here I written character A of 20 equal to Nagendra, and inside printf I written length of string is %d comma strlen of A. By writing strlen of A, it will count length of string A. That means it will count how many characters are present. 1, 2, 3, 4, 5, 6, 7, 8. Total there are 8 characters present. So now I will get output as length of string is 8. You may get doubt like why I am using here %d. As it is string, I need to use here %s. But why I am using here %d? Because I am printing length of string. Length of string is integer characters. So here I am using %d, where strlen stands for length of string. I will get output as 8 because this length of string is 8. Next one is strcpy function, where strcpy stands for string copy. If you want to copy data from one string to another string, then you need to use strcpy function. This is example. Here I written character A of 20 equal to Nagendra. And similarly I took another character, that is character B 20. Now I did not given any value to it. Now I want to copy this data, that is Nagendra, to this character B. So for that purpose I need to use string copy. Here I written string copy A comma B. By writing strcpy of A comma B, that means data which is present in A, variable A, will be copied to B. Here I written printf value of second string is %s comma B. Now by writing this function, this data is copied to this variable B. Now I will get output as value of second string is Nagendra. One is strrev function. Strrev stands for string reverse. For example, if you want to convert string in reverse manner, then you need to use strrev function. This is example. Here I written character A of 20 equal to Naga, and here I written printf %s strrev of A. Now by writing this strrev of A, the string is converted in reverse manner. I will get output from last to first. So now I will get output as AGAN. This is output. One is strlwr function, where strlwr stands for string lower. For example, if you want to convert string in lower case, that is to small letters, then you need to use strlwr function. This is example. Here I written character A of 20 equal Naga, which is in capital letters. And I written printf %s comma strlwr of A. Whenever you write this string is converted to lowercase letters. So I will get output as NAGA, which is in small letters. And next one is strupr. This is opposite to lower. Strupr stands for string upper function. For example, if you want to convert string to uppercase, then you need to use strupr. Here I written character A of 20 equal to Naga, which is in lowercase. Now I want to convert this Naga to capital letters. So for that I need to write printf %s comma strupr of A. By writing this strupr of A, I will get output as NAGA, which is in capital letters. Next one is strcmp function, where strcmp stands for string compare. If you want to compare two strings, then you need to use string compare function. This is example. Here I written character A equal to Naga, comma B equal to Naga. If strcmp of A comma B equal to 0, that means values which are present in variable A and variable B, if both are same, then I need to get output as equal. Else printf not equal. If these both values are not equal, then I should get output as not equal. Here I written A equal to Naga and B equal to Naga. These both are same. So I will get output as equal. For example, here I written Naga, and then here I written some other name like Raju, then both are not equal. So I will get output as not equal. This is example of string compare function. Next I will explain getS and putS functions. This both getS and putS function are string functions. This getS function is like scanf. By using getS function we can enter text, and whereas by using putS, whatever the text that we entered, it will be displayed on our screen. So this putS function is like printf. Both getS and putS functions are present in stdio.h header file. This is program. At first I written hash include stdio.h, after that void main. Inside void main I written character A and I given size as 15. So character along with array represents string. Now I can enter string by using getS function. So I written here printf enter text. By writing this code I will get output as enter text. and by using getS of a, I can enter text. This text is stored in string a. For example, I will enter text, that is college. Now this text is stored in string a, and putS of a is nothing but whatever the text that we entered, it will be displayed on our output screen. So I will get output as your text is college. This putS function is like printf. This is program for getS and putS function. Next topic is structures in C. For example, if you consider arrays, in arrays we can store only similar type of elements. For example, if you consider this example, I written int a and I open square bracket and close the square bracket. Whenever you write like this, you can store only integer type of elements, and I cannot store mixed type of elements. Here I written int a equal to 10, 10.5 and C, where 10 is integer type and 10.5 is float data type, and this C is character data type. I cannot declare like this in arrays. I cannot store mixed type of elements in an array. If you want to group variables of different data types in one place, then you need to use structures. Structures are a way to group variables of different data type in one place. Each variable in structure is also known as member of structure. Whatever the variables that we are declaring inside structure, we call these variables as members. Like arrays, a structure can contain many different data types. As I said before, by using structures, we can store variables of different data types. This is syntax of structure. Structure tag. Structure tag is nothing but name of structure. And open curly bracket. Inside this, we need to write members. Members are nothing but variables of different data types. This is an example. For structures, we need to use keyword struct. For integers, we use keyword int, and similarly for character char. And similarly for structures, we need to use keyword struct. Here I written struct book. Book is name of structure, and after that I open curly brackets, and inside curly brackets I written int pages, float price, character author, where this pages is variable name and this int is data type. As I said before, by using structures, we can store variables of different data types in one place. So here I stored variables pages, price and author. These three are variables of different data types. I stored these variables in single place by using structure. Only pages contain numbers like 10 pages, 20 pages, 30 pages. So that I written here int pages. And for price, I am declaring price as 10.5 rupees, 10.23 rupees, 30.5 rupees, like that. So here I written float price, and here I written character author, and inside square brackets I written 30. Whenever you declare here 30, I can write author name of 30 characters, maximum 30 characters. Next, initialization and accessing of structures. That means how we will initialize values to structures. Normally we will initialize values like this: int pages equal to 10, float price equal to 30.52 and character author equal to Nagendra. But in structures we should not initialize values like this. Whenever you initialize values like this, it will display error. So there are some rules which we need to follow before initializing values. We can initialize and access structures in three ways. This is first way. Here I written hash include stdio.h, that is header file, and normal will declare structure outside the main function. So after writing header file, I written structure, and name of the structure is data. You can also call this name as structure tag. Here I written structure data. I open curly bracket. Inside this I written int a, character b and float c. Here I took three variables of different data type. After that I closed curly bracket, and here I written d equal to, where d is short name of this data. I am giving short name of this data as d. So here I written d equal to, for int a I took value as 10, and for character b I took b, and for float c I took value as 10.5. We need to include these values inside curly brackets, and we need to close this by using semicolon. This is how we assign values to the variables. I should not assign like this, int a equal to 10. I should not assign like this. There are three ways to assign values. This is first way. And after that I written int main, and inside int main I written printf value of a is %d comma d dot a. Normally we will write like %d comma a, but here we need to write d dot a. That means value of a which is stored in d. This is meaning. So here I need to write d dot a, and similarly printf value of b is for character %c comma d dot b, and similarly printf value of c is for float %f comma d dot c, and here I return 0. So by writing this program, I will get output as value of a is 10 and value of b is b and value of c is 10.5. This is output. This is first way of assigning values to structure, and this is another way. This is second way of assigning values to structures. Here at first I return header file hash include stdio.h, and here I return structure data, where data is name of structure, and inside that I return int a, character b and float c, and I closed curly bracket and I given semicolon. After that I return int main, and inside this int main I am assigning values to structure. So I return structure data d, where d is short name of this data. So here I return structure data d equal to 10, b and 10.5, where we need to give values inside curly brackets and close with semicolon. After that I written printf value of a is percentage d comma d dot a, printf value of b is percentage c comma d dot b, printf value of c is percentage f comma d dot c, because all these values are stored in d. So here I written d dot a, d dot b and d dot c. By writing this program I will get output as value of a is 10, value of b is b and value of c is 10.50. This is output. This is third way of assigning values to structures. Here I written hash include ratio.h. After that I took structure data, where data is structure name, and inside that I written int a, character b and float c. After that I written int main function and I opened curly bracket. After that I declared structure data d, where d is short name of this data. So now I am assigning values d dot a equal to 13, d dot b equal to b and d dot c equal to 10.5. Now for these three values I took three printf functions. By writing this program I will get output as value of a is 10, b is b and c is 10.5. This is how we assign values to structures. These are the three ways to assign values to structures. Next, arrays of structures. Normally by using structures we can store details of only single book or single student, like that. But if I want to store details of multiple books or multiple students, for that purpose I need to use arrays of structures. This is example program. Here I took hash include ratio.h and hash include string.h, and here I took structure student. I given structure name as student, and inside this I written int rule number. Normally we will store rule numbers in integers like rule number 10, 20, like that. So here I written int rule number and character name 10. I given size as 10. You can store up to 10 characters, and I closed this structure with curly bracket, and after that I included semicolon. After that I took int main, and inside int main I written int I. Here this int I is for loop. So here I written int I and struct student std of 5. By writing this I can include details of 5 students. After that I written here printf enter records of 5 students. Whenever you write this printf statement on output screen you can see enter record of 5 students. After that I took for loop, and inside for loop I written I equal to 0, I less than 5, I plus plus. That means I can show details of 5 students starting from 0, 1, 2, 3, 4. So inside this for loop I written printf enter rule number. By writing this I can see enter rule number on output screen. After that I written scanf percentage d and std I dot rule number, where std is short name of the student. So here I written std of I comma rule number. Whenever you write this you can enter rule number after executing a program. After that again I written printf enter name, and after that I written scanf percentage s. Here character name of 10 is string. So here I written percentage s comma and std I dot name. Whenever you declare this you can write name of student after executing a program. This for loop is just for giving input of rule number and student name, and I need to take another for loop, that is for output. So in order to generate output I need to take another for loop, that is I equal to 0, I less than 5, I plus plus, which you have given for input. Take same for loop I equal to 0, I less than 5, I plus plus. And inside this for loop I written printf rule number. Normally we store rule number with percentage d and name with percentage s, comma std I of rule number, std I dot rule number, comma std I dot name. Whenever you write this printf function, whatever the names that you have entered, it will be displayed on output screen. So by writing this program you will get output as enter record of 5 students. Here I written enter record of 5 students. So here I will get enter record of 5 students, and by using this for loop I can enter details of 5 students. So here I took 2 scanf. This is output print enter roll number of student. So here I can see enter record of 5 students. By taking this for loop and declaring 2 scanf functions, I can enter details of 5 students. So here I given 5 student names and roll numbers. After this I took another for loop. This is for output. So by writing this printf function I will get output as student information list, rule number 1 Nagendra, whatever the details that I entered here, it will appear here. This is how we use arrays of structures. Next topic is unions in C. Whatever the variables of different data types which we are including in this union, all members share the same memory location. To define a union, you must use union statement in the same way as you did in structures. For structures, we use struct keyword. For unions, we need to use union keyword. That's it. Whatever the syntax that we declared in structures, same syntax we need to write for union. This is example. Here I written syntax union, union tag, and inside this we can declare members. This is an example. Here I written union book, and inside union I written int payers, float price, character author 30, and close curly bracket, and at last we need to include semicolon. This example is same as structures. Only difference is in structures here we use struct keyword, and whereas for unions we need to use union keyword. By using unions we can print size size of variables. Whatever the variables of various data types that you included in this union, it will print size. This is example program of union. Here I written hash include st.h and hash include string.h. Here I took union data, where data is union name, and after I opened curly bracket, inside curly bracket I written int a, float b and character c of 20. I closed curly bracket and then I closed with semicolon. After that I took int main, and inside main function I written union data d, where d is short name of this data. Here I written printf %d comma size of d. Whenever I write here size of d, so it will print size of all these variables of different data types. So by writing this %d comma size of d, I will get output as 20. The name itself says union min. By combining all these data types, it will print size. So I will get output as 20 bytes. Next topic is pointers in C. The pointer in C language is a variable which stores the address of another variable. By using pointers, we can store address of variable. Either variable can be of any type like integer, character, float, etc. This pointer will store address of variable. As we all know, by using scanf, we can assign value to the variable after executing a program. I will give an example. Here I took int a, and I did not given any value to this variable a. I will give value by using scanf function. So that I written scanf %d comma and a, where and represent address of a, and is nothing but it is address. So by using this scanf function, I can enter value after executing a program. So after executing a program, I given value as 10. Whenever I assign value 10, this value 10 is stored in the address of a, where and a represents address of a. Whatever the value that you give, this value is stored in the address of a. I will give one example so that you can clearly understand how pointers will work. As we know, we need to start C program with header file. I written hash include st.h, and after that I written int main, and inside main function I written int a equal to 43. That means I am assigning value 43 to this variable a, where a is variable and 43 is value. Here I written printf %d comma a. Whenever you write this printf function, whatever the value that is present inside this variable a will be generated as output. So I will get output as 43. But I want to find address of this variable a. I don't want this value. I want address of this variable a. So for that purpose I need to write printf %p, where p represents pointer, comma and a. For address you need to write and. Even in printf you can use and a, where and represents address. So here I written %p comma and a. Now whenever I write this printf function, I will get address of variable a. This is the output. For first printf function I will get output as 43, and for second printf function, that is %p comma and a, I will get address of variable a. This is address of variable a, that is 0x7ff. This is nothing but it is address of variable a. This variable a is stored in this address. Here address is nothing but storage location where our variable is stored. Here variable a is stored in this address. Here and a represents pointer, so that I written here %p. We represent pointer by using and symbol. Also create pointer variable, and then we can assign address of various variables to this pointer variable. I will give an example. Here I written int a equal to 43. After that I written int star b, where star represents pointer variable. Whenever I write int star, then this variable b is treated as pointer variable. By using pointer variable, we can store address of various variables. Now I will store address of this variable a in this pointer variable b. So for that purpose I written int star b equal to and a, where and represents address. Now this pointer variable b contains address of this a. Next I written printf %d comma a. Whenever you write this printf function, whatever the value that is present in variable a will be generated as output. So I will get output as 43. And similarly next I written printf %p, where p represents pointer, %p comma b. That means this pointer variable p contains address of a. Now I will get output as 0x7ff, so on. So this is nothing but this is address of a. Variable a is stored in this address. We can also create pointer to array. This is example. Here I written int a of 10. As we know, we will create array by using square brackets, and inside square brackets I given array size as 10. Now we need to create pointer in order to store address of this array a. So that I written int star, as I said before, star represents pointer, int star p of 10 equal to and a. That means this pointer will store this address of this array. We can also create pointer to structure. This is example. As we know, we will create structure by using struct keyword, and I am giving structure name as st. And inside this structure variable st, I written int I and float f, and I am giving short name of this st as s. Now we need to create pointer. For that I written struct st whatever I written here, I need to write here. Struct st star p, where star represents pointer variable. Now whenever you represent pointer variable, now you can store address of variable. Now I'm storing address of this structure. I given short name of this st as s. So here I need to write and s. That means this pointer variable p will store address of this structure s. So the advantages of pointer. First advantage is it reduces code and then improve performance. And second advantage is it returns multiple values for a function. By using pointers we can return multiple values from a function. And third advantage is by using pointers we can access any memory location in our computer. These are the applications of pointers. First application is dynamic memory allocation. Dynamic memory allocation is done by malloc and as well as scanf functions. In this we use pointers. And second application is arrays, functions and structures. In arrays, functions and structures, we use pointers so that it will improve performance. In exam, you can write this diagram. Pointers contains address of variable that contains value. Next topic is enumeration data type in C. The enumeration in C is a user-defined data type that provides integer values to meaningful names. That means whatever the names that we are giving by using enumeration data type, this enumeration data type will convert these names into integer values. By using enumeration data type, it is easy to maintain program and as well as it is easy to understand. The enumeration is defined by using enum keyword. For example, if you consider integer values, we will define integer with int keyword. Similarly for character, char keyword, and similarly for enumeration data type, we use enum keyword. This is syntax of enumeration data type. First write enum keyword and then write enum name. And inside curly brackets you can write n number of integer constants. Integer constants are nothing but names. You can write n number of names inside this curly brackets. This enumeration data type will convert these names into integer constants. This is an example. Here I took, at first I written enum keyword and after that I took enum name as fruits and I opened curly brackets. Inside this I written some fruits names like mango, apple, strawberry and papaya. By default it will take starting name as 0. So value of mango is 0 and value of apple is 1, for strawberry 2 and similarly for papaya 3. So you will get output as 0, 1, 2, 3. But I don't want default values. I want some other values as output. For that purpose I need to assign integer values to these names. Here I took mango value as 3 and similarly apple as 4, strawberry as 19 and papaya as 27. So I will get output as 3, 4, 19 and 27. I will give one simple program so that you can clearly understand how this enumeration data type will work. Here I took enumeration data type outside main function. I took enum keyword and then I took enum name as week, and inside curly brackets I written names of week like Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday. Inside this write printf double quotations %d/t %d/t. Here I took total 7 names. Here I took total 7 names. So I need to write 7 format specifiers. Here you may get doubt like why I am using format specifier %d, as %d belongs to integers. Why I am using this? Because it will convert these names into integer values. Here I did not given any values to these names. So by default it will take first value as 0 and second value as 1, 2, 3, 4, 5, 6, comma, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday. Now I will get output as 0, 1, 2, 3, 4, 5, 6. This is use of enumeration keyword. By using enumeration keyword, you can convert these names into integer constants. If you don't give any value, by default it will take first value as 0 and it will keep on incrementing the value. This is another example. Here I written enumeration keyword and I took enumeration name as week, and here I given value of Monday as 10. Whenever I assign any value to this first name, then it will keep on incrementing the value. Here I given Monday value as 10. So it will keep on incrementing the value. Value of Tuesday is 11. Next value of Wednesday is 12, Thursday 13, Friday 14 and Saturday 15 and Sunday 16. So whenever I give any value to this first name, it will keep on incrementing the value. So I will get output as 10, 11, 12, 13, 14, 15, 16. This is output. Whatever the names that I am using inside enumeration, same names I need to use here inside printf. For example, if I use here capital M, then here also I need to use capital M. Otherwise, I will get error. For example, if I written here full name, then here also I need to write full name. This is another example. In this example, I written printf %d, Tuesday. As I said before, by default, it will take first value as 0 and second value as 1. Here I written %d and Tuesday. So I will get output as 1. For example, if I written here Friday, then I will get output as 4. Next, I will explain unit 3. I will explain all these topics in unit 3. Let's get started. First topic is preprocessor in C. Preprocessor is not a part of the compiler, but it is separate step in compilation process. In simple terms, we call preprocessor as Text submission tool. Preprocessor is not a part of the compiler, but it is separate step in compilation process. That means whatever the task that we perform before compilation, we call the task as pre-processing task. All preprocessor commands begin with hash symbol. Example, hash include stdio.h. This is diagram of how preprocessor will work. As we know, whatever the program that we write in C, we call this program as source code, and we will save this program by using .c extension. Example, program.c. This is how we save program. Whenever you compile this program by clicking on Alt F9, before compiling program, compiler will check whether any preprocessor commands available in our program or not, and then it will perform pre-processing task. After completion of pre-processing task, our program.c file is converted into program.i file, where this program.i is extensible file. This program.i file is converted to object file by compiler, and then this object file is sent to linker in order to create executable file. So after generating executable file, we can execute our program. Preprocessor directives are classified into 4 types. We can also call these preprocessor directives as preprocessor commands. They are: first one is macros, second one is file inclusion, third one is conditional compilation, and fourth one is other directives. First one is macros. Hash define directive is used to define macro. Whenever you want to define macro, you need to use directive that is hash define. Macros are piece of code in a program that is given some name. Whenever this name is encountered by the compiler, then this compiler will replace this name with value. I will give an example so that you can clearly understand. This is syntax of macro, that is always we need to include hash define directive in order to define macro, and macro name, and this is value. Normally we write program like this: hash include stdio.h, and after that I written void main. Inside void main I written int a equal to 10, where int is data type, a is variable name, and 10 is value. After that I written printf %d comma a. Whenever I write this code, then whatever the value that is present inside this variable a will be generated as output. So my output is 10 because value of a is 10. Same program I written like this: hash include stdio.h, and after that I written hash define a10. Whenever you write like this int a equal to 10, we call a as variable, but whenever you write like this hash define a10, we call this a as macro, and value of this macro is 10. After that I written void main, and inside void main I written printf %d comma a. Here I written %d because this 10 is integer, so I written here %d. So by writing this code, I will get output as 10. Here there is no need of declaring data type. Directly you can write like this: hash define a10, where a is macro and 10 is value. For example, if you want to define float value, then here I written float value as 10.5, and just we need to change format specifier to %f, so that I will get output as 10.5. Next one is undiff directive, where undiff stands for undefined. For example, whatever the macro that you define, if you want to remove that macro, then you need to use undefined directive. This is example. Here I written hash include stdio.h. After that I written hash define a10. Here I define macro a, and I given value of this macro as 10. After that I written hash undiff a. That means whatever the macro that I define, now I am removing that macro. So here I written hash undefined a. After that I written void main. Inside void main I written printf %d comma a. Whenever I read this code, then I will get output as error, because actually I should get output as 10 because value of this macro is 10. But I removed this macro. Whenever you write undefined a, that means I am removing this macro. So this macro is removed and I will get output as error message. Next one is file inclusion directive. For example, if you want to include any files to our program, then we need to use file inclusion directive. For each and every program, we use file inclusion directives. For example, if you consider this program, here I written hash include stdio.h, where stdio.h is header file. This is file. So whenever you want to include any files to our program, then you need to use file inclusion directive. This is syntax of file inclusion directive, that is we start file inclusion with hash include, and inside angle brackets I written file name, or you can also write like this: hash include double quotations file name. This is an example. Here I written hash include stdio.h. After that I written void main, and inside void main I written printf hello world. Here I took file, that is header file stdio.h, because meaning of printf is present in stdio.h. So I took here hash include stdio.h. This is example of file inclusion directive. And next one is conditional compilation. For example, if you consider conditional statements like if, else, if, how this conditional statement works, in same way this conditional compilation directives also work. That is, if you want to generate output based on the condition, then we need to use conditional compilation directives. These are the 6 types of conditional compilation directives. First one is if defined, and next one is if and if, that means if not defined. Third one is if, fourth one is else, fifth one is ELIF. ELIF stands for else if, and sixth one is end if. This is example program for hash if defined directive. Here I written hash include hdo.h. After that I written hash define a10. That means I am defining macro a and value of this macro a is 10. After that I written void main, and inside void main I written hash if diff a. That means hash if define a printf hello. And at last I written end if. We need to write conditional compilation directives inside main function. So that inside main function I written hash if define a. The meaning of this is, if I define macro a, then I need to get output hello. Did I define macro a? Yes, I define macro a here. Hash define a. If I define macro a, then I need to get output hello. So now I will get output as hello. For example, if I do not define this macro a, then I don't get output hello. And definitely at last you need to close conditional compilation directives by using hash end if. So for each and every conditional compilation directives, at last you need to use hash end if. That means we are closing this condition. This is example program for if and if directive, where if and if stands for if not defined. Previous program is for if defined, and this program is for if not defined. That means if I do not define macro, then I need to get output. So here I written hash include hdo.h. After that I written hash define a10. That means I am defining macro a and value of this macro is 10. After that I written void main. Inside void main I written hash if and if a. That means if I do not define macro a, then I need to get output hello. And we need to close this if and if condition by using hash end if. So at last I written hash end if. Whenever I write this condition, then I will get output as nothing. I do not get any output, because here if I do not define a, then I need to get output hello. But here I already defined a. So then you do not get any output. Condition is if not defined a, then I need to get output. But here I defined a, so I don't get any output. This is example program for hash if, hash elif and hash else directives. This program is same as if, else if and else program. By seeing this example, you can clearly understand. At first I written hash include hdo.h. After that I written hash define a15. That means I am taking macro as a and value of this macro a is 15. And inside void main I written hash if a less than 10, printf value is less than 10. That means if value of a is less than 10, then I need to get output as value is less than 10. Hash elif a less than 20, that is if value is less than 20, if a value is less than 20, then I need to get output as value is less than 20. Else I need to get output as number not found. As I said before, every conditional compilation directive ends with hash end if. So at last I written hash end if. Whenever I write this code, here I given value of macro a as 15. This 15 is less than 20. So now I will get output as value is less than 20. For example, if I give value as 100, here if I give value of macro a as 100, then I will get output as number not found. Last one is other directives. Other directives includes undefined directive and pragma directive. I already explained this undefined directive. Last one is pragma directive. This pragma directive is special directive. For example, if you want to turn on or turn off any special features, then you need to use this pragma directive. This is example hash pragma startup, hash pragma exit and hash pragma warn, where this startup, exit and warn are special features. Next topic is file handling in C. First, what is file? File is collection of records. For example, if you consider PDF file contains some text information. We call this text information as collection of records, or you can also call this information as collection of related information, because we store only related information in our files. And we store files in hard disk. Hard disk is permanent storage device. This is an example to declare a file. We declare file by using file type along with pointer variable. Here I took pointer variable as a. where star represents pointer variable. Next, types of files. In C language, files are classified into two types. One is text file and another one is binary file. At first, I will explain what is text file. Text file contains alphabets, numbers and special symbols which are easy to understand by human beings. For example, if you consider MS Word, in MS Word we can write text. So we call it as text file. And in text file we can write numbers, alphabets and as well as some special symbols. And if there is any error in text file, it can be eliminated easily. For example, if I do any spelling mistakes in text file, then it is easy to correct. In text files, all alphabets, numbers and as well as special symbols are treated as characters and each character occupies 1 byte of memory. If you consider this example, in this total there are 4 numbers. Each number is treated as single character and each character occupies 1 byte of memory. So total there are 1, 2, 3, 4 characters. So it will occupy 4 bytes of memory. For example, this is text file. This text file name is my file and this file contains total 7 characters. 1, 2, 3, 4, 5, 6, 7. 7 characters. So it will occupy 7 bytes of memory. Next, binary file. Binary file is combination of zeros and ones. It do not contains any special symbols or any alphabets. It contains only zeros and ones. Whereas text file is easily understood by human being and whereas binary file is easily understood by computer. It is not easy to eliminate errors in binary file. And in binary file, the integer value 1245 will occupy 2 bytes of memory. For example, if you consider in text file each number is treated as single character, so it will occupy 4 bytes of memory. But whereas in binary file, this 1245 is treated as single integer value and it will occupy 2 bytes of memory. For example, if you consider this 1234, this is single value, it will occupy 2 bytes of memory. For example, 2345, it will occupy 2 bytes of memory and as well as 12455, it will occupy 2 bytes of memory. A binary file always needs a matching software to read or write it. For example, if you consider movies, if you want to watch any movie, then we need VLC player in order to view that movie. And similarly, if you want to access binary files, you need matching software in order to open that binary file. Files are classified into two categories. One is sequential files and next one is random access files. In sequential files, data is arranged in sequence manner. For example, if you consider your rule numbers, data is arranged in sequential manner like rule number 1, rule number 2, rule number 3, so on. And whereas in random access files, data is not arranged in sequential manner. Data is arranged in random way. For example, rule number 1 and rule number 32 next and rule number 44 next, like that. Next one is file operations. Totally there are 5 major file operations. They are, first one is creation of new file, second one is opening an existing file, third one is reading file, fourth one is writing file and fifth one is closing file. In order to perform these file operations, you need to know what are various file functions and as well as you need to know what are various modes of the file. At first I will explain what are various file functions. In order to open a file, you need to use fopen function, and in order to close a file you need to use fclose function. By using getc, getw, fscanf and gettest, you can read file information. Reading file information means whatever the text that is present inside a file, you can see the text on our output screen. We call it as reading a file. And by using putc, putw, fprintf and fputtest, you can add text to our file. Next, various modes of the file. First one is R. R stands for read mode. By using read mode, you can only read that file. You cannot add any text to that file. You can only read that file. Next one is R plus mode. By using R plus mode, you can read and as well as you can write text to a file. And next one is W mode, where W stands for write mode. If you want to remove previous text and if you want to add new text, then you need to use write mode. This write mode will remove previous text and then it will add new text. For example, I want to add CSC. By using write mode, we can remove previous text and then it will add new text to the file. Next one is W plus mode. By using W plus mode, you can read and as well as you can write data to a file. And next one is append mode. Meaning of append is adding data at the end of the file. Already there is some data in my file. I want to add new data, then I need to use append mode. If you consider this example, already some text is present in my file like btech. Now I want to add new text at the end of the file, then I need to use append mode. By using append mode, you can add data at the end of the file. Now I want to add CSC, so I can add CSC at the end of the file. Last one is A plus mode. By using A plus mode, you can read and as well as you can append data to a file. All these are various modes for text file. Now let me explain various modes for binary file. It is same as text file. First one is RB mode. By using RB mode, you can read binary file, where RB stands for read binary. And next one is RB plus mode. By using RB plus mode, you can read and as well as you can write binary file. Next one is WB mode, where WB stands for write binary. By using WB mode, you can write binary file. And next one is WB place mode. By using WB place mode, you can read and as well as you can write binary file. Next one is AB mode, where AB stands for append binary. Already there is some information in my binary file. Now I want to add new information to binary file. Then I need to use AB mode. By using AB mode, you can add data at the end of the file. For example, already there is some information in my file. Now I want to add some more information at the end of the binary file. Then I need to use AB mode. And last one is AB place mode. By using AB place mode, you can read and as well as you can append binary file. Normally how we create a file, like we will go to notepad in my system and then I will write some text in that notepad. Then I will save that file with some name like file.txt. This is how we create files. But our topic is about how to create a file by using C programming. Now I will explain how to create a file and then how to add text to that file, and also I will explain how to close a file by using C programming. Normally we can store values in C programming like int a equal to 10. We can store value 10 in variable a. But now I want to store file in C programming. But in C programming we cannot store files. So here I can only store address of a file. In order to store address of a file, we need to use pointers, and we will create file by using file type. At first I need to write hash include stdio.h. After that write void main. In order to create a file, we need to use file type, file in capital letters. In order to create pointers, we need to use star. Star represent pointer variable. I am taking pointer variable name as a. After that write a equal to, we can create file by using fopen function, where fopen stands for file open. I already said before, by using fopen function we can create new file. Already if there is file present in our system, then we can open that file. Now I want to create file in local disk E. So I am giving address local disk E and I am giving file name as myfile.txt, because I am creating text file now. So I written here .txt, where txt stands for text file, comma, I want to add some information to this file myfile.txt. So for that purpose I need to use mode, that is write mode. By using write mode we can add any information to the file, semicolon. Whenever you write this line of code, then this fopen function will create myfile.txt text file in local disk E. Now I want to add some information to this file. So for that purpose I need to use fprintf. By using fprintf we can add information to the file. Open bracket. This file is present in address A. So I need to write here A, comma. You need to include double quotations, and whatever the text that you want to write, you need to write the text in double quotations. I want to add information like my name is Nagendra. Close double quotations, bracket, semicolon. Whenever you open fprintf function and you write some information, by using fprintf function you can add information to the file. We can close this file by using fclose function. So write here fclose and write address here. Address is A and then close bracket. This is how we create a file. We add text to the file and then we close a file. Whenever you run this program, you do not get any output here. But whenever you run this program, you do not get any output, but it will create file in local disk E. After executing this program, you open computer and inside computer open local disk E. Whenever you open local disk E, you can see file. That file name is myfile, because we given here file name myfile. If you open this file, then you can see text, that is my name is Nagendra. This is how we create file by using C programming. This is another program in order to read a file. Read a file is nothing but whatever the text that is present inside my file, I can see this text in my output screen. This is example program. Here I written file star A, where star represent pointer variable A. After that I write A equal to fopen. By using fopen function, we can create new file and as well as we can open existing file. So now I want to open existing file. This file name is file.txt and this file contains information, that is my name is Nagendra. Now I want to open this file. So for that purpose I give an address, that is E, local disk E, and file name is file.txt. I want to read this file. So for that purpose I need to use read mode. In order to see this file information on my output screen, at first I need to create one string variable and then I need to store this file information in this string variable. After storing this file information in string variable, we can see output. So in order to store file information in string variable, I need to take one string, that is character, and I am giving variable name as B and I am giving 50. Character data type along with arrays represent string. So now we created string and size of string is 50. That means I can store up to 50 characters. And now open while condition, while fscanf. By using fscanf, we can transfer file information from A to B. So here we need to write address A, comma, all these are strings. So we need to write here %s, comma B. By writing this, we can transfer file information, that is my name is Nagendra, from file A to B. Here I written %s because all these are string characters. So I want to transfer data from A to B until end of the file. I want to transfer data until last character. So for that purpose I need to write not equal to end of file. By using, whenever you write this end of file, this fscanf will transfer data from A to B until end of the file. Whenever you write this condition, then this character B will store file information. This file contains information, that is my name is Nagendra. So this character B will store information, that is my name is Nagendra. It will just store information. So in order to display this information, I need to use printf. So for that purpose I need to write printf, whatever the information that this character B stored. Now I want to display this information. So for that purpose I need to write printf %s, comma B. Printf %s, comma B. Whenever you write this statement, then you will get output as my name is Nagendra. Whatever the data that is present inside my file, I can see this data in my output screen. So output is my name is Nagendra. So at last we need to close file by using fclose function, fclose of A. This is program in order to read data from a file. Next topic is, if you want to place cursor at desired position, then you need to use random access file functions. Random access file functions are classified into three types. First one is rewind function, next one is fseek function, and last one is ftell function. For example, this is my file. My file contains text, that is engineering. Normally cursor will be at starting position. But if you want to place cursor at any desired position, then you need to use random access file functions. For example, I want to print last character, that is G as output. So for that purpose, I need to place cursor to last position like this. If you want to place cursor at any desired position, then you need to use random access file functions. First, I will explain rewind function with example program. By using rewind function, you can bring cursor to the beginning. That is, by using rewind function, you can place cursor to the starting position. For example, my file name is file.txt. My file contains text, that is college. Now I will write program in order to see this text information, that is college, on my output screen. At first I need to place file text in one string variable, and then I can see output by using printf. So at first I written file type, and then I took one pointer variable, and pointer variable name is a. After that I written a equal to fopen of file.txt. This file.txt is present in local disk E. So I given this address. So by using fopen function, I can open this file which is present in local disk E. Whatever the data that is present inside my file, I want to see this data in my output screen. So for that purpose, I need to use read mode. Now we need one string variable in order to store our text information. My file contains this text, that is college. Now I need to store this information in one string variable. So for that purpose, I written here character B. I given string name as B, and I given size as 50. Character along with arrays represent string. Now I need to transfer file data to variable B. For that purpose, we need to use fscanf. By using fscanf, we can transfer text which is present in my file A to string B. So by writing this fscanf A comma %s comma B, whatever the data that is present in my file, the data is transferred to string B. I want to transfer this text until last character. Till last character I want to transfer. So for that purpose, I took while loop, and I given condition as not equal to EOF, where EOF stand for end of file. By writing this line of code, my data is stored in string B. So now my string variable B contains text, that is college. Now this variable B contains information, that is college. Now whatever the data that is present inside my variable B, now I want to print this information. For that purpose, I written here printf %s comma B. By writing this, I will get output as college. It will print first character, and then it will print second character until not equal to end of file. That means until last character it will print output, and my cursor will be at last position. Now I want to print this information again. Now I want to print this college again. So for that purpose, again I written same two lines of code. Here again I written while loop, and again I written printf. By writing this code again, I need to get output twice. I need to get output as college again, but I do not get output college again because already when I printed this file information for the first time, my cursor is placed at last position. So in order to print the same information again, I need to bring this cursor to first position. So when I bring my cursor to first position, then I will get output as college. So for that purpose, here we need to write rewind function, that is rewind. My file is present in pointer A. So we need to write here rewind A and semicolon. Whenever you write this rewind A, then your cursor will be placed at first position. So now you will get output as college. Now you will get output twice. First time it will print college and then again it will bring cursor to first position and then again you will get output as college. And at last we need to close this file by using fclose. So at last I written fclose of A. Next I will explain fseek and ftell with example program. At first I written file star A where star represent pointer variable A and I written A equal to fopen of my file is present in local disk E and my file name is sample.txt. So I written here E sample.txt. Now I want to read this file. So I written here read mode. I want to read only single character. So for that purpose I written here character B. I did not took string. I just took character because I want to read only single character. Next I written fseek. Fseek function will take 3 parameters. First one is file location. My file is present in A in pointer A. So I written here A comma. Next parameter is position. In which position you want to place your cursor? I want to place cursor at first position. So I written here 0. Fseek function starts with 0 where 0 represents first position. And third parameter is this fseek function contains 3 constants. First one is seek set. In order to place cursor from starting position, then you need to use seek set, and next one is seek current, and last one is seek end. I will explain these 3 with example. So at first I written here seek set, SEEK underscore SET. We need to write this in capital letters. Whenever I write this line of code, then my cursor is placed at first position. So my cursor will be at first position because I written here 0. After that I need to write here B equal to get C of A. That means I am placing single character to variable B. I am placing single character, that is H, to variable B. Whenever I write this, first character H is placed in variable B. Now this variable B contains character H. In order to print output, I need to write here printf int location %d. This %d is for ftell of A. I will explain what is use of this ftell of A. This %c is for character B. Character B contains value, that is H. So I will get output as in location 1 H. In location 1 H. This is output. This ftell function will say current location. Here my text is Hyderabad. So H is present in location 1, Y in location 2, D in location 3, so on. For example, if I write here 1 in place of 0, then I will get output as in location 2 Y. This is my output because here fseek function will start from 0 and whereas ftell function will start from 1. For example, in place of seek set, if I write here seek end and if I give here -1, whenever I write here seek end, then my cursor will be placed at last position. Now I want to print this last character, that is D. So for that purpose I need to write here -1. That means we are going back, so we need to write here -1. Whenever I write here A comma -1 comma seek end, then I will get output as in location 9. In location 9 value is D. This is my output. This is use of seek end. For example, if I write here -2, whenever I write here -2, then it will go 2 position backward. So I will get output as in location 8. In location 8 character is A. This is my output. For example, if I write here fseek A comma -3 comma seek end, at first it will place my cursor to last position and then it will move 3 positions backward, 1, 2, 3. So I will get output as in location 7 B. This is my output. And next I will explain what is use of seek current. Here I written fseek of A comma 1 comma seek current. That means from current position it will move 1 step forward. So my current position is here because here I written -3 seek end. So my position will be in place of B. So from B it will move 1 position forward. So now I will get output as in location 8 A. This is my output. Definitely we need to include semicolon for this fseek function. At last we need to write here semicolon. And at last we need to close this file by using fclose function. This is example of fseek and ftell function. Next topic is how to copy text from one file to another file using C program. For example, there is one file, let file name be myfile.txt, and this file contains text, that is Hyderabad. Now I want to copy this text to another file, that is file2.txt. At first I need to read this text, so I need to use here read mode for myfile.txt, and then I need to write this text, that is Hyderabad, into file2.txt. So I need to use here write mode. I am reading this file, and then whatever the text that is present inside this myfile.txt, I am writing this text into file2.txt. So I am using a write mode. Whatever the text that is present inside myfile.txt, at first I will store this text into character variable C, and then I will copy this text from character variable C to file2.txt. This is C program in order to copy text from one file to another file. Here there are two files. So I took two pointer variables, one is A and another one is B, and I written A equal to fopen of myfile.txt, which is present in local disk E. After that I written B equal to fopen of file2.txt. As I said before, I want to copy text from myfile.txt to file2.txt. So for myfile.txt I need to use read mode, and for file2.txt I need to use write mode. Myfile.txt is present in pointer variable A and file2.txt is present in pointer variable B. At first I need to copy text from pointer variable A to character C. So I need to write here C equal to f get C of A. By writing this, I can copy text from pointer variable A to character C. I want to copy text until last character. So I need to give here condition, that is not equal to end of file. I want to copy text which is present in pointer variable A to character C until last character. So here I given not equal to EOF, where EOF stands for end of file. Here I am using condition. So here I need to take while loop, while close bracket. Here I am taking condition, that is end of file. So here I am using while loop. By writing this line of code, data which is present in pointer variable A, that is data which is present in myfile.txt, is copied to character variable C. Now this file contain text, that is Hyderabad. Now I want to copy text which is present in character C to file2.txt, which is present in pointer variable B. For that purpose I need to write here f put C of C comma B. That means whatever the text that is present inside character variable C is copied to pointer variable B. At last we need to close both files by using fclose function. By writing this code, my text is copied from one file to another file, that is from myfile.txt to file2.txt. Next I will start unit 4. I will explain all these topics in unit 4. Let's get started. At first I will explain function and various types of functions, and also I will explain various types of user defined functions. At first I will explain what is function. Function is a block of code that can be reused n number of times. The main use of function is code reusability. For example, when you want to develop any software, there are situations where you need to repeat some lines of code again and again. So instead of writing same lines of code again and again, we use functions. Whatever the code that we written inside our function, we can repeat this block of code multiple number of times. I will give one example so that you can clearly understand how function will work. Before that, you need to know what are the types of functions. Functions are classified into two types. One is standard library functions and next one is user defined functions. At first I will explain what are standard library functions. The standard library functions are built-in functions. That meaning of these functions are already present in header files. For example, if you consider printf, scanf, this printf and scanf meanings are present in stdio.h header file. We call this printf and scanf as built-in functions because these meanings are present in stdio.h header file. Next, user defined functions. Function which is created by user for his need is known as user defined function. For example, you can give any name for your function like sum. The sum is function name, or you can also give any other name like fun, so on. This is user defined function. Now I will explain program for user defined function. This is program to create a function. At first you need to write #include stdio.h. After that you need to write void. Now you need to write here your function name. For example, I want to give my function name as fun, so I am giving here function name as fun. As we know, we will denote function by using brackets. Here I am not giving any return type, so I written here void fun. Inside this you need to write your code. For example, I want to print some statements like college, and I want to print another statement like CSC. I created my function name is fun. Inside my function, I written both like printf college and printf CSC. Now I want to print this statement. Now you need to write void main. Inside void main, you need to call your function by giving your function name. I given here function name as fun. So I am calling this function fun, and definitely you need to include semicolon here. By writing this code, you will get output as college and CSE. For example, if you write function again, if you write your function name again, I return my function name twice. So I will get output as college and CSE twice because I return here function twice. For example, if you want to repeat this code thrice, then you need to write here function. This is use of function. By using function, you can repeat block of code multiple number of times. Now I will explain program for addition of two numbers by using function. At first I return hash include stdio.h. After that I return void because I am not giving any return type. So I return here void and I given function name as add. Inside this I am writing code for addition of two numbers. So I return here int a comma b comma c. After that I return printf. After that I return scanf %d and a and b. By writing this I can enter two values of a and b. After that I return c equal to a plus b. Now this c will contain result. So we need to print c by writing printf %d comma c. After that you need to write void main and you need to call your function inside main function. So I return here void main. Now you need to call this function by giving function name. Here I given function name as add. So you need to write here add. By writing this you will get output as enter values of a comma b. Now I can enter values like I want to add two numbers 10 and 20. Whenever you enter 10 and 20 you will get output as 30. For example, if I write my function name again inside this main function, now I can enter values twice. So again I will get output as enter values of a comma b. Now I can enter two values. For example, I want to add 5 and 5. So by writing this I will get output as 10. For example, again if you write your function name here, you can enter values 3 times. Whenever you execute your program, at first control goes to main function. So inside main function I return add. After that it will check whether any add function is present in program or not. So add function is present here. So it will run this code. So you need to remember that whenever you execute your program, at first control goes to main function. After that inside main function I given function name as add. So it will check whether add function is present in our program or not. So add function is present here. So control goes to add function and it will execute code which is present in add function. For example, if you want to use return type for function, just in place of void you need to write int. And here you need to write return 0. This is return type of a function. Next I will explain passing parameters to a function. We also call these parameters as arguments. I will explain program in order to pass arguments to a function. At first you need to write hash include stdio.h. Now you need to create your function void. I am giving function name as fun. Whatever the information that you write inside these brackets, you call it as arguments. Now I want to pass two arguments to this function. First one is int a because I want to pass one argument as integer value and I want to pass another argument as string. How we declare string? Like character b. Whenever you write character data type along with array, it represents string. Inside this you need to write printf for integer %d and %s /n comma a comma b. By writing this it will print one integer value and one string value. After that you need to write void main. You given function name as fun. Here you may get doubt like where to give values. Here I just written int a and I did not given any value, and similarly I written here string b and I did not given any value. So you need to give values here. Inside this function you need to write first value is integer, so I am giving value as 10 comma next one is string. For example, I want to print string that is college. So you need to write college in double quotations. By writing this code you will get output as 10 and college. This is my output. For example, if you want to give another value like function 20 comma btech. So I am calling function twice with different values. So I will get output as 20 btech. Similarly, if I call three functions like function 40 comma CSE, I will get output as 10 college, 20 btech and 40 CSE. This is my output. Next I will explain various types of user defined functions. User defined functions are classified into 4 types. First one is functions with no arguments and no return values, and second one is function with no arguments and with return values. Third one is function with arguments and no return values. Fourth one is function with arguments and with return values. I will explain programs for all these categories. This is program for function with no arguments and no return values. No return value mean I am not returning anything. So I return here void and I given function name as my fun, and I am not passing any arguments inside this function. So we call it as function with no arguments and no return value. Inside this I return printf and I return statement as how are you, and inside void main I return my function name. Here I given my function name as my fun. Here I return my function name as my fun. So you need to write here my fun. You need to close this function with semicolon. I return my function 3 times. So I will get output as how are you, and how are you. This is my output. And next one is function with no arguments and with return type. Functions with no arguments mean I am not passing any arguments inside this function, and with return type mean I am using return type. So I return here int, and inside this function I return 0. This is program for function with no arguments and with return type. So this is same program which I written before. So by writing this I will get output as how are you, and how are you. This is my output. And next program is for function with arguments and no return values. First I return hash include stdio.h. Here this program is for function with arguments and no return values. No return value mean I am not returning anything. So I return here void, and I given my function name as my fun. Function with arguments mean I am passing arguments to this function. I am passing 2 arguments. One is string and another one is integer value. So I return here character A, I open square bracket, I close the square bracket. This represent array. Character data type along with array represent string. And next I return int B, and after that I return printf. For string we need to use %s, and for integer we need to use %d, comma a, comma b. And inside void main I return my function name. Here I given my function name as my fun. So you need to write here my fun, and inside this you need to give values. I am giving character as Madhu and integer value as 3. And similarly again I return my fun, and inside this I return string name as Sai and value as 4. By writing this program I will get output as Madhu 3, Sai 4. This is my output. Next I will explain program for function with arguments and with return type. This program is same as function with arguments and no return values. Difference is that in place of void you need to write int, and here you need to write return 0. Rest everything is same. Function which contains return type and as well as parameters, we call it as signature of a function. So whenever signature of a function question comes in exam, then you need to write this syntax, and then you can write this example because it contains both return type and as well as parameters. Guys, in this example here I written void my function. We call it as function definition, and I written here void main. Inside this I am calling my function. So I call this my function which I written inside void main as calling function. Instead of writing this program like this, you can also write in another way. The same program you can write like this. Here I return hash include stdio.h. After that I return void my function, and I am closing this with semicolon. Whenever I write like this, we call it as function declaration. I am not defining function, I am just declaring my function. After that I return void main. Inside void main I return my function because I am calling this function. So we call this my function as calling function. After writing void main my function, now you need to define your function. So I return here void my function, and inside my function I given printf hello. So we call it as function definition. Instead of writing like this, you can also write like this. In previous example, instead of directly defining function, you can just declare function. After that you can define function after void main. Whenever function declaration question comes in exam, then you need to write this example, and whenever function definition question comes in exam, then you need to write this example. And they may also ask like difference between function definition and function declaration. Instead of directly defining function, I just declared my function, and then I am defining my function after writing main function. Next topic is standard library functions in C, and also I will explain passing arrays to functions. At first I will explain standard library functions in C. Standard library functions are built-in functions that are present in header files. For example, if you consider printf, scanf, this printf and scanf are built-in functions because meaning of printf and scanf is present in stdio.h header file. So we call it as built-in functions, and we include header files in our program by using hash include. For example, hash include stdio.h. This stdio.h is standard input output header file. These are some of the header files. First one is stdio.h, where stdio stands for standard input output dot header file. All input and output functions are present in stdio.h. For example, printf, scanf, so on. And next one is conio.h, where conio stands for console input output header file. And next one is string.h. All string functions are present in string.h header file. And next one is stdlib.h, where stdlib stands for standard library. Next one is math.h. All mathematical functions are present in math.h header file. And next one is time.h. Time and as well as clock related functions are present in time.h header file. Guys, these are the various functions that header files contains. First one is stdio.h. This header file contains functions such as printf, scanf, getc, putc, and getS and putS, where getc stands for get character, putc stands for put character. And similarly, getS stands for get string and putS stands for put string. Standard library.h header file contains these functions. And next, conio.h contains functions such as clr, getch, so on. And next, ctype.h contains functions such as is alpha, is digit, is lower, is upper, two lower and two upper functions. And math.h header file contains mathematical functions such as sqrt function, where sqrt stands for square root function, and POW, that means power function, so on. And string.h header file contains string handling functions such as strlen, where strlen stands for string length, strlwr, strupr, strrgv, that means string lower, string upper, and string reverse, and strcpy, that is string copy function, and so on. And process.h header file contains process and thread functions. fopen and fclose are file functions, and malloc, calloc, and realloc free. All these are dynamic memory allocation functions. Guys, whenever standard library function question comes in exam, then you need to write all this. Next, I will explain passing arrays to function. As we know, if you want to store multiple values in single variable, then you need to use arrays. Example, a of 5 equal to 1, 2, 3, 4, 5. Whenever you give size as 5, that means you can store 5 values in a single variable. This is use of arrays. If you want to pass array as parameter to a function, then there are three ways. This is first way. Here I written void fun. Here I given my function name as fun. Inside this I written int pointer array name. This is first way if you want to pass array as arguments to a function. And this is second way. Here I written void. I given function name as fun. Inside this I written int array name and I given size as 10. And this is third way. Here I written void fun, where fun is function name. Inside this function I written int array name. I open square bracket and then I close the square bracket, and I did not given any size inside this. This is third way. I will give one example. This is an example to pass array as argument to a function. Here I took void main. Inside void main I written int a. I open square bracket and then I close the square bracket. I did not given any size. After that I written is equal to. Inside curly brackets I written 10, 20, 30, 40. I am giving 4 values 10, 20, 30 and 40. Now I am creating function. Let function name be fun. Inside this you need to write array name. I given array name as a, so I need to write here a. Now I need to write separate code for this. So I took void. I given function name as fun, so I written here void fun. Inside this I written array. I given array name as a and data type is int. So here you need to write int a. I want to print all 4 values. All these are integers. So I written here printf percentage d, percentage d, percentage d, percentage d, comma a of 0. This percentage d is for a of 0, 1, a of 1, a of 2 and a of 3. That means value which is present in index number 0, index number 1, index number 2 and index number 3 will be printed as output. So I will get output as 10, 20, 30, 40. This is my output. This is an example of passing array as argument to a function. Next topic is parameter passing techniques in C. We also call these parameter passing techniques as interfunction communication. Parameter passing techniques are classified into 2 types. One is pass by value and next one is pass by reference. At first I will explain what is pass by value. I will explain this pass by value with program. At first I written hash include stdio.h. After that I written void main. Inside void main I will write int a equal to 10. I took 2 variables. One is a and one is b. Value of a is 10 and value of b is 20. Now I am creating one function. Let function name be fun. You can give any name to your function. I am taking function name as fun. Inside this I written a comma b. Value of a is 10 and value of b is 20. A will store value 10 and b will store value 20. After that I written printf. After that I written printf percentage d comma a comma b. Here I given my function name as fun. So now I am writing code for this function fun. Here I given my function name as fun. So write same here fun. I am passing two parameters to this function fun. One parameter is int x, comma another parameter is int y. Now inside this function I am writing x is equal to y. This is program for pass by value. I will explain this. Here inside void main I written int a equal to 10 and b equal to 20. After that I created one function. Let function name be fun. Inside this function I written a comma b. As we know, variable a contains value 10 and variable b contains value 20. So a will store value 10 and b will store value 20. Values which are present in variable a and variable b, that is 10 and 20, is transferred to this int x and int y. Now this x will store value 10 and y will store value 20. Data types and variables which are written inside our function is known as formal parameters, because I written int x and int y inside my function fun. So now we call this int x and int y as formal parameters. Variables which are present inside main function that are passed to formal parameters is known as actual parameters. So now we call this variable a and variable b as actual parameters, because values of variable a and variable b are transferred to formal parameters int x and int y. After that, inside this I given condition, that is x equal to y. Actually y value is 20. So now x value will be 20, because I given condition as x equal to y value is 20, that is equal to x. By using printf we can generate output. So I written here %d comma a comma b. Whenever I write this, actually I should get output as 20 comma 20, because here I given condition, that is x equal to y. That means x value is nothing but y value. So actually I should get output as 20 comma 20. But in pass by value, changes made to formal parameters will not affect actual parameters. Actually I should get output as 20 comma 20, but now I will get output as 10 comma 20, because whatever the changes that made to formal parameters will not affect actual parameters. This is pass by value. Next I will explain pass by reference. In pass by reference, changes made to these formal parameters will get transmitted back to actual parameters. That means whatever the changes made to these formal parameters will affect these actual parameters. I will explain this pass by reference program. This is program for pass by reference. This program is same as pass by value. Difference is that here in pass by value I written function a comma b, but here you need to write function and a comma and b, where and represent address. And next difference is in pass by value I written int x comma int y. Here you need to write, here in pass by reference you need to write int pointer variable x comma int pointer variable y. Inside this you need to write pointer x equal to pointer y. Same program, just difference is that here you need to take variable, and whereas here you need to take pointer variable. And here in pass by value I written a comma b, whereas in pass by reference you need to write and a comma and b, where and represent address. By writing this program I will get output as 20 comma 20, because in pass by reference changes made to formal parameters will affect actual parameters. So here I changed x value as y. Value of y is 20, value of x is 10. So I changed x value as y, that is 20. This value is sent back to this actual parameters. So definition of pass by reference is changes made to formal parameters will get transmitted back to actual parameters. We can also call pass by value as call by value, and we can also call this pass by reference as call by reference. Guys, whenever passing pointers to function question comes in exam, then you can write this example pass by reference, because here we are passing pointers to the function. So you can write this example. Next topic is what is recursion and limitations of recursion, and also I will explain programs for factorial of a number and Fibonacci series using recursion. At first I will explain what is recursion. Recursion is the technique of making a function call itself. Recursion is nothing but function which calls itself is known as recursion. This technique provides a way to break complicated problems into simple problems which are easy to solve. By using recursion we can break complicated problems into simple problems, so that we can easily easily solve those problems. This is an example of recursion. Here I created one function. Let function name be sum. Function which calls itself is known as recursion. So I'm calling this same function here. That means I'm calling this same function. So we call it as recursion because function which calls itself is known as recursion. These are the limitations of recursion. First disadvantage is recursion will consume more memory. This is first disadvantage. And second disadvantage is recursion can be slow because if recursion is not implemented properly, then it will be a slow process. And writing recursion function is not a easy task. It is complicated task to write a recursion program. And third disadvantage is it is difficult to analyze code in recursion function. As I already said before, by using recursion function, we can convert complex problems into simple problems. But before that, you need to understand what is that complex problem. So sometimes it is very difficult to understand this complex problem. By using recursive function, we can solve many mathematical problems such as calculating factorial of a number and Fibonacci series, so on. At first, I will explain program to calculate factorial of a number by using recursion. Before that, you need to know how to find factorial of a number. For example, if you consider 3 factorial, this is how we find factorial of a number. 3 factorial is 3 into 2 into 1, that is 6. And similarly, 4 factorial is 4 into 3 into 2 into 1, that is 24. And 5 factorial is 5 into 4 into 3 into 2 into 1. We must start from that number and then we need to keep on multiplying by decrementing each value until 1. This is how we find factorial of a number. Now I will explain program in order to find factorial of a number by using recursion. At first I written hash include stdio.h. After that I written int and I am giving function name as factorial. Inside this I written int n. N is nothing but number which you want to find factorial. For example, I want to find factorial of 5. This 5 is integer. So I written here int n where n will store number. After that inside this you need to write condition, that is if n is less than or equal to 1, return 1, else return n into factorial of, this is formula of factorial, that is n into factorial of n minus 1. That means we will start from that number and then we will keep on multiplying by decrementing each value until 1. So here I given condition as if n is less than or equal to 1, return 1. Whenever I reach value to 1, then I need to stop here. So I written here return 1. By writing return 1, we can break this multiplication. After writing your own function, you need to write void main. Inside this, you need to give number. Like I want to find factorial of 5. So you need to give here int n equal to 5. After that, you need to write printf. You need to write this in order to generate output. So you need to write here factorial of percentage d is percentage d. This percentage d is for n, comma factorial of n. This factorial of n is present here. So by writing this, I will get output as factorial of this percentage d is for n. This n value is 5. So factorial of 5 is this percentage d is for factorial of n. This factorial of n contains this block of code. Factorial of 5 is 5 into 4 into 3 into 2 into 1, that is 120. So this is output in order to find factorial of a number by using recursion. Next I will explain C program for Fibonacci series using recursion. Before that, you need to know what is Fibonacci series. For example, at first you need to take 0 and after that 1. 0 plus 1 is 1 and similarly 1 plus 1 is 2. And 2 plus 1 is 3 and 3 plus 2 is 5 and 5 plus 3 is 8. This is known as Fibonacci series. Fibonacci series is nothing but we must keep on adding present element with previous element. At first you need to take 0 and 1 and you need to add these two. 0 plus 1 is 1 and similarly now present element is 1 and you need to add this present element with previous element, that is 1 plus 1, that is 2, and again add present element with previous element, that is 2 plus 1, that is 3, and add this present element with previous element, that is 3 plus 2 5, and similarly add present element with previous element, that is 5 plus 3, that is 8. This is how we find Fibonacci series. We found Fibonacci series for 1 2 3 4 5 6 7 elements. So in order to find Fibonacci series, we need to use for loop. So here I written for int, all these are integers, so I written here int I equal to 0, I less than 7, starting from 0 1 2 3 4 5 6. So I written here int I is equal to 0, I less than 7, I plus plus. You need to remember this. For Fibonacci series we use for loop. Now I will explain program. Now I am writing program in order to find Fibonacci series up to 10 numbers, starting from 0. 0 plus 1 is 1 and similarly 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8 and 8 plus 5 is 13, 13 plus 8 is 21, 21 plus 13 is 34. So starting from 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So starting from 0 up to 9. So for that purpose I need to take for loop. I written here void main. Inside void main you need to take for loop. For all these are integers. So int I equal to 0 up to 9 mean I less than 10, I plus plus. Inside this you need to write printf percentage d slash n, comma. I am creating my own function. Let function name be Fibonacci because we are finding Fibonacci. So I'm giving function name also Fibonacci. You can also give any name as your wish. I'm giving function name as Fibonacci of I. This is I. So I insert this, I written I. Now we need to apply formula. I given function name as Fibonacci. So now I'm writing function int Fibonacci of int I. Inside this you need to write if I is equal to 0 return 0, else if I is equal to 1 return 1. Here I took if I is equal to 0 return 0, else if I is equal to 1 return 1 because here first two numbers are 0 and 1. So I return this both. After that else return. Now you need to write formula, that is Fibonacci of I minus 1 plus Fibonacci of I minus 2. At first we return 0 and 1. After that we are adding this two numbers 0 and 1. So I return here Fibonacci of I minus 1 plus I minus 2, that is I minus 1 is 1 and I minus 2 is 0. 1 plus 0 is 1. This is result of third element. And similarly we will keep on repeating this formula until this condition is satisfied, that is int I is equal to 0, that is int I is equal to 0, I less than 10, I plus plus. That means we will get result up to 10 numbers 1 1 2 3 5 8 13 21 and 34. This is output for this program. This is how we calculate Fibonacci series. Guys, in factorial example you need to remember this. Factorial of n is nothing but this is function which we created. So this function contains separate code that contains formula. So this is formula of factorial, that is if n is less than or equal to return 1, else return n into factorial of n minus 1. That means we will start from that same number and we will keep on multiplying by decrementing each value until we reach 1. This is break condition. That is whenever we find number 1, we will break that condition. So 5 into 4 into 3 into 2 into 1, that is 120. Whenever it finds 1, it will break that condition. Next topic is dynamic memory allocation in C. Normally we will initialize values like this. If you consider this array example, here I given size as 10. A of 10 is equal to 1 2 3. I given size as 10 but I given only 3 values. So whenever I declare like this, it will create 10 memory locations 1 2 3 4 5. So total it will create 10 blocks and this 1 is stored in first block, 2 in second and 3 in third block. As we know, integer will occupy 2 bytes of memory. So here I given size as 10. So it will occupy 10 into 2. That is 20 bytes of memory, but I given only 3 values. So this one will occupy 2 bytes, 2 bytes, 2 bytes, and all this remaining memory is wasted. Though I given size as 10, I initialized only 3 values, so that all this remaining memory is wasted. So in order to overcome this problem, that is in order to save memory, we use dynamic memory allocation. Guys, you need to remember one thing, that is each integer will occupy 2 bytes of memory, whereas each character will occupy 1 byte of memory. For example, if you consider 10 20 10, this 10 will occupy 2 bytes of memory, 20 will occupy 2 bytes of memory, and 10 will occupy 2 bytes of memory. For example, if you consider single character, this C will occupy 1 byte of memory, A will occupy 1 byte of memory, and D will occupy 1 byte of memory. By using dynamic memory allocation, we can allocate memory at runtime. That is, we can allocate memory during the execution of program. Dynamic memory allocation in C language is possible by 4 functions. For dynamic memory allocation, we use 4 functions. They are, first one is malloc, second one is calloc, third one is realloc, and fourth one is free. These are the 4 functions that we use for dynamic memory allocation. And these 4 functions are present in stdlib.h header file, standard library header file. At first I will explain malloc function. Malloc function allocates single block of requested memory. This is syntax malloc of number into size of integer. I will give example so that you can clearly understand. Here I written example malloc of 15 into size of integer. That means I am taking integer value and I am giving size as 15. That means it will create one single block and it will allocate size as 15. 15 into 2, that is 30. So now I can store 15 values inside this. For example, you may get doubt like, if I give only 3 values, then though I given size as 15, it will occupy size only for this 3. That is, it will occupy only 6 bytes of memory. This is use of malloc function. By using malloc function, we can create single block of memory of required size. Though I given here size as 15, but if I given here only 3 values, then it will occupy memory for only that 3 values. This is malloc function. Next I will explain calloc function. Calloc function allocates multiple blocks of requested memory. This is syntax calloc of number comma size of integer. This is an example. Here I written calloc of 15 comma size of integer. Whenever I declare like this calloc function will create 15 blocks and each block occupies 2 bytes of memory. This is difference between malloc and calloc. What malloc function will do is malloc function will create only single block of size 15. But whereas CLR function will create each block, like that it will create 15 blocks. The difference between malloc and CLR function is malloc function will create single block of memory, and whereas CLR function will create 15 small blocks of memory where I can store single value inside one block. For example, if I given here only 3 values like 3, 12 and 13, then though I given size as 15, it will consume memory only for these 3 values. So it will occupy only 2 plus 2 plus 2, that is it will occupy only 6 bytes of memory. This is use of CLR function. And next one is realloc. For example, in malloc function we given size as 15. But if you want to increase this size to 30, then you need to use realloc function. If you want to change given size, then you need to use realloc function. This is syntax in order to change size. Here I written realloc and this is variable name. And I am changing size 15 to 30. So you need to write here 30 into size of integer. Whatever the memory that you assigned, you need to delete this memory at last. So you can delete this assigned memory by using free function. This is use of free function. I will explain programs for this. This is program for malloc function. At first I written hash include stdio.h. After that I written hash include string.h because I am using string in this program. So I written here string.h header file. And next I written hash include stdlib.h. As I already said, this malloc is present in stdlib.h header file. So I written here hash include stdlib.h. After that I written void main. Inside void main I written character pointer p. I am taking pointer variable. I am giving this pointer variable name as p. And after that I written p is equal to malloc of 15 into size of character because I want to store character. So I written here character. Here also you need to write character. For example, if you want to store integer values, then you need to write here int, and then here you need to write int. But now I want to store characters, so here I written character data type. Whenever you declare like this malloc function will create single block of memory with size 15. As I already said before, character will occupy 1 byte of memory. So 15 into 1, that means each character will occupy 1 byte of memory. Total I given size as 15, so it will take 15 bytes of memory. If pointer is equal to null, then print couldn't able to allocate memory. For example, there is situation like there is no memory in our system, so at that time it will print couldn't able to allocate memory. If memory is not present in our system, then it will print this statement, couldn't able to allocate memory. Else, if memory is present in our system, then I want to transfer this string to pointer variable p. If memory is not present, then it will print couldn't able to allocate memory. Else, if memory is present, then by using string copy function, I can copy this text Nagendra to pointer variable p. So now my pointer variable p contains information Nagendra. Now I want to print this information by using printf. So I written here printf %s because this is string. For that purpose we need to use %s comma p. So by writing this I will get output as Nagendra. Though I given here size as 15, but my text contains only 8 characters. So it will occupy only 8 bytes of memory. This is use of malloc function. And at last you need to remove this allocated memory by using free function. So I written here free of p because p contains information. So I written here free of p. This is program for malloc function. Next I will explain program for cloc function. Guys, this program is same as malloc function. Only difference is that here you need to write p is equal to cloc of 15 comma size of character. Wherein before example we written malloc of 15 into size of character, but here you need to write 15 comma size of character. Whenever you write like this, cloc function will create 15 small blocks and each block occupies 1 byte of memory. Whereas malloc will create single block of size 15 and whereas cloc function will create 15 small blocks. These are the differences between malloc and cloc function. Next one is realloc function. For example, I assign value as 15, but now I want to change this value to 100. So for that purpose you need to use here, it first I written p is equal to cloc of 15 into size of character, but I want to increase this size 15 to 100. Then for that purpose I need to use realloc function. So I written here p is equal to realloc of p. At first you need to write p because this cloc is present in p, so you need to write here p comma 100 into size of character. So by writing this, my size is changed from 15 to 100. This is use of real of function. Next I will start unit 5. I will explain all these topics in unit 5. At first I will explain what is an algorithm and what are the characteristics of an algorithm. An algorithm is a step-by-step procedure to complete a task is known as algorithm. It is not like you are using algorithms only in computers. You are also using algorithms in your real life. For example, I want to make coffee. What I do is, at first in step 1, I will take a pan and I will add milk in it. After that in step 2, I will switch on the gas stove, and in step 3, I will add sugar and coffee powder. In step 4, I will boil it, and at last in step 5, my task gets completed, that is my coffee is ready. Here my task is to make coffee, so I followed sequence of steps in order to make coffee. This is known as algorithm. An algorithm is step-by-step procedure for solving problem or to complete a task is known as algorithm. Next you need to know what is meaning of pseudocode. Pseudocode is an informal and artificial language that helps programmers to develop an algorithm. Informal means user-friendly language. Artificial language means man-made language. Language which is created by human beings is known as artificial language. So, algorithm which is written in English-like language is known as pseudocode. Whatever the algorithm that we are writing in English-like language is known as pseudocode. There is no proper rule to be followed in order to write an algorithm. So, you can write algorithm as your wish. This is an example. Here I am writing algorithm for addition of two numbers. Step 1. Always step 1 is start because I am starting algorithm. And in step 2, I am reading two values. After reading two values, in step 3, I need to add these two values. After adding two values, in step 4, I need to store this result in another variable. And at last in step 5, I need to print variable that contains result. And at last step 6 is stop. This is how we need to write algorithm. There is no proper rule that we need to follow in order to write an algorithm. So you can also write this same algorithm like this. Step 1 is start, and in step 2 I am reading two values, that is A and B. After reading two values A, B, I need to add these two values and I need to store this result in another variable C, and I need to print this C because it contains result, and at last step 6 is stop. This is how we need to write algorithm. There is no rule that you need to write algorithm only like this. You can write algorithm as you wish. Here I written same algorithm like this. Here this is another example. Here I am writing algorithm for average of 3 numbers. Step 1 is start, and in step 2 I am reading 3 values. I am assuming values as A, B and C. And step 3 is sum A, B, C. That means I am adding A, B, C values. After adding, in step 4, divide sum by 3. And in step 5, I am storing result in another variable, that is variable D. I am storing this result in variable D, and in step 6 I am printing variable D because variable D contains result. So I am printing variable D in step 6, and in step 7 stop. Now, or you can also write end program. This is how we need to write algorithms. These are the properties which we need to follow before writing an algorithm. These are the characteristics. You can also say this as characteristics of algorithm. First one is input and output, and second one is finiteness, third one is definiteness. You can also say definiteness as unambiguous, fourth one is effectiveness, and at last fifth one is generality. First one is input and output. Each algorithm must take 0, 1 or more quantities as input and should produce at least one output. For example, in this example, algorithm took 2 quantities as input. An algorithm must take 0, 1 or more quantities. So, input can also be 0. For example, here I am not writing any input. For example, start. Next, directly I am printing C. Print C and stop. In this, I did not take any input. So, here quantity of input is 0. An algorithm must take 0 or 1 or more quantities as input. Input can be 0, that means there is no need of giving input, but there must be at least one output. An algorithm should produce at least one output. This is first property, and second property is an algorithm should terminate in finite number of steps. That means we need to complete algorithm in countable number of steps. There should not be any infinite steps in algorithm. For example, if you see this example, in this algorithm was terminated in 6 steps which are countable 1, 2, 3, 4, 5, 6. So always algorithm must terminate in finite number of steps and there should not be infinite number of steps in algorithm. Third point is definiteness. You can also say definiteness as unambiguous. Each step of an algorithm must be clear, means no ambiguity. Means whatever the steps that we are writing in an algorithm, each and every steps must be clearly understandable. There should not be any ambiguity. Ambiguity means mistake. There should not be any mistake. This is known as definiteness. For example, in previous example, I written read a comma b. This step is clear because I am reading two values a, b. But if I written here only read, then it will become ambiguous because what should I read? Should I read a or which variable? So it will become ambiguous. Step 4, effectiveness. Effectiveness means algorithm should contain only necessary steps. It should not contain any unnecessary steps. This is known as effectiveness. And at last, fifth one is generality. Whatever the input that we are giving to algorithm, an algorithm should work with our input. This is known as generality. Algorithm should run for any type of input or data. These are the 5 properties or characteristics of algorithm. Next topic is performance analysis of an algorithm, and also I will explain what is time complexity and what is space complexity. An algorithm is said to be efficient and fast if it takes less time to execute and consumes less memory space. Performance of an algorithm is said to be good only if it takes less time to execute and consumes less memory space. So in order to analyze performance of an algorithm, we use time complexity and as well as space complexity. That is, performance of an algorithm depends upon time and as well as space. At first I will explain what is time complexity. The time that an algorithm requires for its execution is known as time complexity. The amount of time that an algorithm requires for its execution is known as time complexity. There are 3 types of time complexities. First one is best case time complexity, second one is worst case time complexity, and third one is average case time complexity. If an algorithm gets executed in short period of time, then it is known as best case time complexity. If an algorithm requires minimum amount of time for its execution, then it is known as best case time complexity. And if an algorithm requires maximum amount of time, that is, if algorithm takes more time for its execution, then it is known as worst case time complexity. And third one is average case time complexity. If an algorithm requires average amount of time for its execution, then it is known as average case time complexity. I will explain best case, worst case and average case time complexities with an example, that is with linear search example. We know what is linear search. Linear search is the process of searching elements one by one until we found key element. In linear search, we will search each and element one by one in order wise until we get our required element, is known as linear search. Here I took example. There are 5 elements, that is 10, 20, 30, 40 and 50. In this I want to find element, that is element number 10. So we will start from first. Here first element is 10. So we got our required element at first. So it is known as best case time complexity. And another example, this is same example. Here I want to find element number 30. We will start searching from first. 30 is not found at first position, so then we will move for second position. Element is 30 element is not present in second position, so again we will move this element one step forward, that is 30. We got our element 30 in third position. It does not took minimum amount of time and it does not took maximum amount of time, so it is known as average case time complexity. And here third example, here I want to find element number 50. At first we will start with first element, that is 10. 50 is not present at first position, so we will move one step forward. 50 is not in second position, again we will move one step forward. In third position element is not found, and in fourth position element is not found. We got element 50 in last position, so time consuming is more. it is known as worst case time complexity because it took maximum amount of time, whereas in first it took minimum amount of time, so it is known as best case, and whereas last one is worst case time complexity. This is an example of time complexity. In order to calculate time complexity, we use two approaches. First one is frequency count. We also call this frequency count as step count, and second one is asymptotic notations. Now I will explain components of time complexity. There are two components of time complexity. First one is capacity of system and second one is computer containing single processor or multiple processors. I will explain first one, that is capacity of system. Capacity of system depends upon various factors such as RAM, processor and type of windows that we are using in system, so on. So if speed of computer is fast, then output will be generated fastly, but if speed of computer is slow, then output will get generated slowly. This is known as capacity of system. Second one is computer containing single processor or multiple processors. If computer contain only one processor, that is only single processor, then output is generated slowly, but whereas if computer contains multiple processors, then output is generated fastly. These are the two components of time complexity. Next topic is space complexity. Space complexity is same as time complexity, only difference is that in place of time we need to write space. So definition of the space complexity is amount of space that an algorithm requires for its execution is known as space complexity. Same as time complexity, space complexity is also classified into three types. First one is best case space complexity, second one is average case space complexity, and third one is worst case space complexity. If an algorithm requires less space, that is minimum amount of space for its execution, then it is known as best case space complexity. And if an algorithm requires average amount of space for its execution, then it is known as average case space complexity. And if an algorithm requires more space, that is, and if an algorithm requires maximum amount of space for its execution, then it is known as worst case space complexity. Next I will explain what is flowchart, and then I will explain flowchart and algorithms for addition of two numbers, average of three numbers and circumference of a circle. And then I will explain what is branched flowchart with an example. Diagrammatic representation of algorithm is known as flowchart. These are the various symbols that we use in flowchart. First one is ellipse. This ellipse is used to start and stop the algorithm. And next one is rectangle. If you want to write any expression like a plus b, a minus b, so on, we use rectangle. We can write expressions inside rectangle. And next one is parallelogram. In order to read input values like read a comma b and read a b c like that. And similarly, in order to print output, we use parallelogram. This is parallelogram symbol. And next fourth one is rhombus. We can write conditions inside rhombus like a greater than 10, a less than 20 like that. If you want to write any condition, then we need to use rhombus. And last one is arrow marks for flow of solution. This is algorithm and flowchart for addition of two numbers. Step 1 is start. After that, step 2 is read AB. That means I can store two values in variable A and variable B. Let two values be 10 and 20. I am storing value 10 in A and value 20 in B. And step 3 is C is equal to A plus B. Result is stored in variable C. So step 4 is print C. I am printing variable C which contains result, and at last step 5 is stop. This is an algorithm for addition of two numbers. Next, flowchart. Step 1 is start. After that, read A comma B comma C and write C is equal to A plus B. And at last print C because C contains result. So I am printing C, and last step is stop. This is flowchart for addition of two numbers. As I already said before, for start and stop we use ellipse. And for reading values and printing output, we use parallelogram. So here I am using parallelogram. And if you want to write any expression like A plus B, A into B like that, we need to use rectangle. So I return C is equal to A plus B in rectangle. Next, this is flowchart for average of three numbers. At first we need to write start in ellipse. After that I am declaring four variables. They are A, B, C and average. After that, read A comma B comma C. That means I am reading three values. That means I can store three values inside variable A, variable B and variable C. After that, you need to write average is equal to A plus B plus C by 3. In order to calculate average, you need to use this formula. And at last we need to print average because average contains result. So you need to print average and last step is stop. Reading values and printing output must be written in parallelogram. So I written this both in parallelogram and expressions must be written in rectangle. So here I written expression a plus b plus c by 3 in a rectangle and you need to write start and stop in ellipse. This is flowchart for average of 3 numbers. This is C program to calculate average of 3 numbers, but before that you need to know how to calculate average. For example, let 3 numbers be 10, 20, 30. Now I want to calculate average for these 3 numbers. For that formula is 10 plus 20 plus 30 by 3. Total there are 3 numbers. So I written here 10 plus 20 plus 30 by 3. For example, if I want to calculate average for 4 numbers, then formula is let 4 numbers be 10, 20, 30, 40. Now formula is 10 plus 20 plus 30 plus 40 by total 4 numbers. So by 4. This is formula to calculate average. Here I want to calculate average for 3 numbers. For that I written program. At first I written int a, b, c, d, where a, b, c contains numbers and d will store result. After that I written printf enter 3 numbers. By writing this I will get output as enter 3 numbers. After that I written scanf. I want to enter 3 integer values. So I written here percentage d, percentage d, percentage d, comma, and a, and b, and c. By writing this line of code, I can enter 3 values. So one value will be stored in variable a, and next value will be stored in variable b, and next value will be stored in variable c. For example, I want to enter 3 values like 1, 2, 3. These are the 3 values that I entered. Next formula to calculate average is a plus b plus c by 3. So I written here d equal to a plus b plus c by 3. This is formula where d will store result. So I written here printf average is percentage d comma d. This variable d contains result. So I written here printf average is percentage d comma d. By writing this I will get output. At last I written here get ch because whenever if you enter 3 values and if you click on enter, then your screen will be disappeared. So whenever if you enter 3 values and if you press enter, then you need to get output. So for that purpose I written here get ch, and this get ch is present in conio.h. So I written here hash include conio.h. This is an algorithm and flowchart for circumference of a circle. Circumference formula is 2 pi r. Value of pi is 22 by 7. That means if you convert this in calc, you will get value as 3.14. So first step is start. After that step 2 is read r. After that step 3 is calculate c is equal to 2 into 3.14 into r. This is formula of circumference, that is 2 pi r. So I written here c is equal to 2 into 3.14 into r. After that I am printing c because c contains result. So at last you need to print c and you need to write stop. This is an algorithm for circumference of a circle. Next this is flowchart. If you write the same algorithm in diagrammatic format, we call it as flowchart. Next I will explain what is branched flowchart. If we use conditional statements inside our flowchart, then we call it as branched flowchart. This is an example. Here I written start. We need to write start in ellipse. After that I written grade greater than 75. This is conditional statement. So we need to write this in rhombus. Whenever you use conditional statement in our flowchart, we call it as branched flowchart. If condition is true, then this statement will be executed. If condition is false, then this statement will be executed. For example, if person got 90 marks, 90. So 90 is greater than 75. So I will get output as student has passed. Else, for example, if person got only 60%, then this condition is not satisfied. This statement will be executed. So student has failed in examination. And at last you need to end this. Next topic is what is linear search and what is binary search. I will explain both example and algorithm, and also I will explain difference between linear search and binary search. At first you need to know what is meaning of searching. Searching means finding our required element from given set of elements. At first I will explain what is linear search. In linear search we will search our required element sequentially one by one, and if element is found then we will stop searching. This is an example. Here I need to find element 6. Find element 6. Here total there are 7 elements. Here I given index numbers for each element. As we know index number starts with 0. Here in index number 0 element is 5. 5 is not equal to 6. So we need to move cursor one position forward. In step 2, I placed cursor to next position, that is in index number 1. In index number 1 element is 2. So 2 is not equal to 6. So again we need to move cursor one position forward. In step 3, I placed cursor at index number 2. In index number 2 element is 3. Again 3 is not equal to 6. Again we need to move cursor one position forward. In next step, cursor is placed at index number 3, element is 7, 7 is not equal to 6. So again we need to move cursor one position forward. In step 5, we place the cursor at index number 4. Element in index number 4 is 1. 1 is not equal to 6. So again we need to move cursor one position forward. In step 6, I placed cursor at index number 5. In index number 5, element is 6. So here k value is 6. 6 is equal to 6. Therefore, we found our required element. Now we can stop searching and at last you need to write. Therefore, we found element 6 at index number 5. This is an example of linear search. For example, if I want to find element 30, but element 30 is not present in this array. So at that time, we will keep on searching each element, and when cursor reaches to last position, then you need to write element not found. This is an algorithm for linear search. In step 1, we will set k to 0. That means we will place k at index number 0. And in step 2, if array of k equal to required element, then go to step 6. Step 6 is print element found at index number I. Meaning of this is, if k value is equal to our required element, then we will print element found at index number, as you already discussed in before example. Else mean, if k value is not equal to our required element, then set k to k plus 1. That means we will move k one step forward. After that, again go to step 2. After placing k to one step forward, then again we need to check whether k value is equal to our required element or not. And in step 4, if k value is greater than n, then go to step 5. That means we need to write element not found, as I already said in before example. For example, if I want to find element 30, element 30 is greater than these elements. So we need to write element not found. And last step is stop. This is an algorithm of linear search. Next, I will explain binary search.
In linear search, in order to find particular element, we need to search each and every element line by line. So it is time taking process. So in order to overcome the limitation of linear search, new searching technique is developed, that is binary search, in order to save time. For example, this is an array of elements. It contains total 6 elements. I want to find element 6. So in linear search, it will search each and every element. First it go to first element. 6 is not present in first. So again it will go to second. 6 is not present in second. Again it will go to third, it will go to fourth, and at last it will go to sixth. Therefore we got sixth element here. In linear search, it will search each and every element in order to find particular element. It is time taking process. So in order to overcome the problem of linear search, binary search algorithm was created in order to save time. Binary search is fast searching algorithm with runtime complexity of O of log n. This is runtime complexity of binary search. And this binary search is based on divide and conquer strategy. In divide and conquer strategy, we will divide problem into sub-problems, and then we will solve sub-problems, and then at last we will combine these solutions of sub-problem into single solution. This is known as divide and conquer strategy. This binary search follows divide and conquer strategy. In binary search technique, we search an element in sorted array. Sorted array is nothing but elements which are arranged from small to big is known as sorted array. This is sorted array. This is example of sorted array because elements are arranged from small to big. That is 1, 2, 3, 4, 5, 6. And we need to find particular element in this sorted array in binary search. For example, here I want to find element 4. We search an element 4 in sorted array. This is example of binary search. I will give one example how to find element in binary search so that you can clearly understand. This is an example of binary search. In this they given list of sorted array. Here they are given total 1, 2, 3, 4, 5, 6, 7. Here there are total 7 elements. In this we need to find element 71, and this binary search is applicable only for sorted array. In order to perform binary search, elements should be arranged from small to big. So here elements are from small to big. So we can perform binary search. At first you need to write elements 11, 24, 55, 60, 71, 77 and 80. Total there are 1, 2, 3, 4, 5, 6, 7. Total there are 7 elements in the array. In this you need to find middle element. Formula to find middle element is lower element plus higher element by 2. This is formula. Lower element is nothing but first element, and higher element is last element in the array. First element in the array is lower element and last element in the array is higher element. Formula is lower element, that is 1, not 11, 1. 1 plus higher element, that is 7, not 80, 7 by 2, that is 8 by 2. 2 1 ja 2 4 ja 8, that is 4. So mid element is, value of mid is 4, that is 1 2 3 4. Middle element is 60. Here 71 is the value which we need to find. If value is equal to mid, then our result is true, we can close, that is we got our result. Here 71 is the value which we need to find, but here mid value is 60. 71 is not equal to 60. 71 is not equal to 60. 71 is greater than 60. So if value is greater than mid, then convert this mid into lower element, because 71 is greater than 60. Elements are already arranged in sorted format. So 60 is smaller element now. So we need to convert it into lower element. Convert this 60 as lower element. Again we need to find mid. Value of mid is lower element plus higher element by 2. Lower element is 4 plus higher element is 7 by 2. That is 11 by 2. That is 2 1 ja 2 5 point. Don't consider elements which is after point, that is 5. So mid element is 5. Value which we need to find is 71. If value and mid element is 71. Here value is equal to mid. So we found that element. So we found element 71. If value is equal to mid, then we can stop. We got our result. Our mid value is 71. This is how we can search particular element by using binary search. This is one more example. Here I need to find element 24. I need to find 24. So you need to apply formula, that is mid. Formula of mid is lower element plus higher element by 2. Lower element is first element in the array and higher element is last element in the array. That is 1 plus 7 by 2. That is 8 by 2. 2 1 ja 2 4 ja 8. 1 2 3 4. Value of mid is 4. So here mid value is 4. Value is not equal to mid. Here value which we need to find is 24. But here mid value we got is 60. 60 is not equal to 24. 24 is less than 60. So in that case, if value is less than mid, then change mid element to higher element, because our element is present in between this. Our element is present in between this 11 and 60. So I changed this mid element as higher element. We should not change this mid element into lower element, because if we change this mid element into lower element, then our element will be present in between this. So here I changed mid element as higher element. You need to remember these two things. If value which we need to find is less than mid, then change mid to high. And if value is greater than mid, then change mid to low. These two things you need to remember. Here value is less than mid, that is 24 is less than 60. So we need to change mid to higher. Again we need to find mid. Formula of mid is lower element plus higher element by 2, that is 1 plus 4 by 2, that is 5 by 2. 2 1 ja 2 2 ja 4, 0.5. Don't consider element which is after point, so your value is 2. This is mid. Value which we need to find is 24. Mid value is 24. Therefore we got our result. We can stop this. If value is equal to mid, then we successfully searched that element. For example, consider same example, but here I need to find 23. 23 is not present in this array. Here there is 11, 24, 55, but there is no 23 element. In that situation, it will become 23. This is another example. Then in that situation, you need to convert this mid element as higher element. If lower element and higher element comes side by side, then therefore element is not found. We cannot find that element. And in that situation, you can write therefore element is not present. This is another example. This is algorithm for binary search. Step 1. In step 1, we need to find lower element, that is first element in an array, and I am taking this lower element as L, low equal to L, and similarly highest element, that is last element in an array. I am denoting this high as H. After finding lower element and higher element, next we need to apply mid formula. Formula of mid is low plus high by 2. This is formula. After this, you need to go to step 2. Go to step 2. Step 2 is if value is equal to mid, then return mid. We need to return mid. Our result is found. Print element found. Element found at mid. This is value which we need to print. If value is equal to mid, then print element found. Then at last go to step 5. Step 5 is stop. Else, if value is not equal to mid, then there is two chances. That is step 3. That is if value is greater than mid, then change mid to low. As I already said in before example, if value is greater than mid, then change mid to low, and again go to, after changing mid to low, again you need to perform this, again you need to apply this formula. So go to step 1. Else if step 4, else in step 4, if value is less than mid, then change mid to high. After changing mid to high, again you need to calculate mid value. So again go to step 1, and at last step 5. Step 5 is stop. Here I said now step 5 stop. Else if we do not find that value, then here otherwise, when condition fails, that is we cannot find any element, if condition fails, print element not found, print element not found, and go to step 5, that is stop. This is algorithm for binary search which we need to remember in exams.
Next difference between linear search and binary search. In linear search, there is no need of arranging elements in sorted manner. This is an example. Here I written 5, 1, 2, 3, 4. This is not in sorted manner. In linear search, there is no need of arranging elements in sorted manner in order to find particular element. But in binary search, we need to arrange elements in sorted manner in order to search particular element. This is an example. If you want to find any particular element, then element should be in sorted manner. And next, linear search is based on sequential approach, but whereas binary search is based on divide and conquer strategy. Linear search is suitable for small size data sets, and whereas binary search is suitable for large size data sets. Linear search is suitable only for small size data sets, and it is not suitable for large size data sets, whereas binary search is suitable for large size data set. And next difference is worst case complexity of linear search is big O of n, and worst case complexity of binary search is O of log base 2n, and best case complexity of linear search is big O of 1, and best case complexity of binary search is big O of 1. Linear search can be implemented on both one dimensional array and as well as multi-dimensional array, but binary search can be implemented only on multi-dimensional array.
Next topic is algorithm to find roots of quadratic equation, and also I will explain algorithms to check number is even or odd and to check number is prime or not, and also I will explain algorithm to find maximum and minimum elements in given list and algorithm for factorial of given number. I will explain algorithm to check number is even or odd. This is an algorithm to check whether number is even or odd. For example, if we divide any number by 2 and if we get remainder as 0, then we consider it as even number, else it is odd number. For example, if you consider number 4, if you divide number 4 by 2, we will get remainder as 0 because 2 2s are 4, so remainder is 0, so 4 is considered as even number. And if you consider number 5, if you divide number 5 by 2, 2 2s are 4 and remainder is 1, so this 5 is not a even number, this 5 is odd number. For every algorithm, step 1 is start and step 2 is read n is nothing but we are reading any number like 5, 4, etc. So here I written read n. And step 3 is if number is divided by 2 and if we get remainder as 0, then print even, else we need to print odd. And step 4 is stop. I will explain algorithm to find factorial of a given number. Before that, you need to know how to find factorial of a number. For example, I want to find factorial of number 3. This is how we find factorial. Factorial of 3 is 3 into 2 into 1. 3 2 are 6. And 6 1 are 6. And similarly, factorial of 4 is 4 into 3 into 2 into 1, that is 24. And factorial of 5 is 5 into 4 into 3 into 2 into 1, that is 120. That means we need to start multiplying from that number to 1. This is how we find factorial of a number. Now I will explain algorithm. Algorithm to find factorial of a number. As we know, for each and every algorithm, step 1 is start. After that, take integer variable a. I am taking variable as a. And then step 2 is assign value to variable. For example, I want to find factorial of 5. So I am giving value of a as 5. And step 3 is for value a to up to 1. That means from starting value a to 1, multiply each digit and store. From this value 5 to till 1, we need to multiply each value and then we need to store this result. And at last, finally, stored value is factorial. This is how we find factorial, and last step is stop. This is algorithm to find factorial of a number. I will explain algorithm to find roots of quadratic equation. These are the formulas to find roots of quadratic equation. That is R1 equal to minus b plus under root of b square minus 4ac by 2a. And similarly, R2 is equal to minus b minus under root of b square minus 4ac by 2a. These are the two formulas that you need to remember in order to find roots of quadratic equation. Now Now I will write algorithm for this. As we know, step 1 is start. This formula contains A, B, C. So I am reading A, B, C values. After that, step 3 is compute D equal to B into B minus 4AC, because this is formula under root of B square minus 4AC. I am storing this B square minus 4AC in one variable, that is D. So here I written compute D equal to B into B minus 4AC. After that, step 4 is if D value is greater than 0, then we can apply these formulas. They are R1 is equal to minus B plus square root D by 2 into A. Square root D is nothing but D contains formula, that is B into B minus 4AC, and similarly R2 formula is minus B minus square root D by 2 into A. If D value is greater than 0, then we can apply these formulas, but if D value is equal to 0, then we need to compute R1 is equal to minus B by 2A and R2 is equal to minus B by 2A, because value of root 0 is 0. So we cannot apply this formula. Even if you apply this formula, result is same. If D value is less than 0, then you need to write roots are imaginary, and last step is stop. This is an algorithm for finding roots of quadratic equation. Next I will explain algorithm to check number is prime or not. But before that, you need to know what is prime number. Number which is divisible only by 1 and itself is known as prime number. For example, if you consider number 5 is divisible only by 1 and itself. You need to start from 1 and you need to check till 5. If you divide 5 by 1, remainder is 0. And if you divide 5 by 2, remainder is not 0. And if you divide 5 by 3, remainder is not 0. And if you divide 5 by 4, remainder is not 0. At last, if you divide 5 by 5, then remainder is 0. So this 5 is divisible only by 1 and itself. So this 5 is prime number. And similarly, if you consider number 4, you need to start from 1 and you need to keep on checking till 4. This 4 is divisible by 1 because 1 4 is 4. So remainder is 0. And this 4 is divisible by 2 because 2 2 is 4. So remainder is 0. This 4 is divisible by 2 and this 4 is not divisible by 3 and this 4 is divisible by 4. This 4 is divisible by 1, 2 and 4. So this 4 is not a prime number. Definition of prime number is number which is divisible only by 1 and itself. An algorithm to check whether number is prime or not. As we know, step 1 is start and step 2 is read number n. For example, I want to find factorial of 5. So I am giving n value as 5. And third step is initialize count to 0 and I to 1. That means we need to start dividing this element 5 from 1 to 5. 1, 2, 3, 4, 5. We need to start from 1 to 5. And initially count is 0. Count is nothing but how many times I got remainder as 0 is known as count. Initially I am giving count as 0. And step 4 is divide n by I. If remainder is 0, then increment count by 1. Here we given n value as 5. So we need to divide this 5 by 1. We need to start from 1 because here I given I value as 1. So we need to start from 1 and we need to repeat this division until this number 5. So at first I will start with 1. 1 5 is 5, remainder is 0. If remainder is 0, then increment count by 1. So now my count is 1. And similarly take another number 2. Divide this 5 by 2. 2 2 is 4 and remainder is 1. So remainder is not 0. So don't increment count. Keep count as 1 as it is. And similarly take 3. Divide this 5 by 3. 3 1 is 3 and remainder is 2. So remainder is not 0. And similarly take 4. 4 1 is 4. Remainder is 1. Still keep count as 1. And now divide 5 by 5. 5 divided by 5. 5 1 is 5. Remainder is 0. So now increment count as 2. Now my count is 2 because 5 is divisible by 1 and as well as 5. So now my count is 2. Repeat step until I less than n. We start dividing this number n with 1 until n because at first we need to take 1, 2, 3, 4, 5. So we are starting from 1 and we are dividing this number n until n. Repeat step 4. We need to repeat this step until I less than n. I value is 1. Here step 6 is if count is equal to 2, then print n is prime number. Otherwise n is not a prime number. Here count of I is 2. Now we need to print n is prime number. For example, if you give value as 4, then 4 is divisible by 1, 2 and 4. So now count will be 3. Whenever count is 3, then print n is not a prime number. And at last step is stop. This is an algorithm in order to check whether number is prime or not. This is C program to check whether number is prime or not. I want to find whether 7 number is prime or not. So here I written int n equal to 7. Number which is divisible by 1 and itself is known as prime number. How to check whether this 7 number is prime or not? So at first we need to divide this 7 with 1 and we need to divide this 7 with 2, 3 and so on until this number, that is 7. So here I took for loop. Here at first we are dividing this 7 with 1 until 7.
So here I written int I equal to 1, I less than or equal to n, where n value is 7, and we keep on incrementing values like 1, 2, 3, 4, 5, 6, 7. So here I written I plus plus. So it will take value 1. This 1 is less than or equal to 7. So condition is satisfied. So whenever condition is satisfied, then it will go to for loop. Inside for loop, I given condition, that is, if we divide 7 with 1 and if we get remainder as 0, we need to increment count. Initially count is 0, so here I written int count equal to 0, where count is variable. At first we need to divide this 7 with 1. 1 7 just 7, remainder is 0. If we divide 7 with 1 and if we get remainder as 0, then we need to increment count. So now count will be 1. And next I plus plus, that is, next we need to divide this 7 with 2, and next we need to divide this 7 with 3, so on until 7. 7 is divisible only by 1 and itself. So again 7 1 just 7, remainder is 0. So now count will be 2. Now close this for loop. If count is equal to 2, then printf prime number, else printf not prime. At last close this main function. Meaning of this is, if count is equal to 2, that means number which is divisible by 1 and itself. So this 7 is divisible by 1 and itself. So we will get output as prime number. This is C program to check whether number is prime or not.
Next I will explain algorithm to find minimum and maximum elements in given list. They given some array of elements. Now we need to find minimum and maximum element in this array. So initially we need to take this first element as minimum element and maximum element. So now minimum element is 5 and maximum element also 5. Now we need to keep on comparing this element with other elements. Move to next step. Here minimum element is 5 and maximum element is 5. But maximum in highest element. So when compared to 5, highest element is 40. So now replace this 5 with 40 and go to next step. Here minimum element is 5 and maximum element is 40. Okay, minimum is smallest element. When compared to 7, 5 is smaller. And similarly, maximum element means highest element. When compared to 7, 40 is highest. So don't change, keep it as it is. And go to next step. Here minimum element is 5 and maximum element is 40. So minimum is smallest element. When compared to 23, 5 is smaller. So keep 5 as it is, and maximum element means highest element. When compared to 23, this 40 is highest. So keep it as it is and go to next step. This is also same. Minimum element is 5 and maximum element is 40. And again go to next step. Minimum element is 5 and maximum element is 40, but here minimum element means smallest element. When compared to 90, 5 is smaller, so keep 5 as it is, and maximum element is 40. When compared to 40, highest element is 90, so replace this 40 with 90 and go to next step. Now minimum element is 5 and maximum element is 90. When compared to 51, 5 is smaller, so keep 5 as it is, and when compared to 51, 90 is highest element, so keep 90 as it is, and then go to next step. Here minimum element is 5 and maximum element is 90. When compared to 1, 5 is not smaller, because when compared to this 5 and 1, 1 is smallest element, so replace this 5 with 1. And when compared to 1, 90 is highest element, so keep 90 as it is. Therefore minimum element is 1 and maximum element is 90. This is how we find maximum and minimum element in an array. I will explain algorithm for this. Give index numbers for this. 0. Index number starts with 0. 0, 1, 2, 3, 4, 5, 6, 7. These are index numbers. This is an algorithm. Algorithm minimum maximum of a comma n, where a is nothing but array which contain n number of elements. There are n number of elements in an array. So here I written minimum maximum of a comma n. That means we are finding minimum and maximum element in this array. Inside this you need to write max is equal to minimum is equal to a of 0. That means we are considering this first element which is in index number 0 as minimum element and maximum element. So here I written min max is equal to a of 0. For I is equal to 1 to n, that means from starting 1 to till index number 7, you need to apply this. If a of I greater than max, then replace maximum with a of I, as I said before. For example, if you consider this element 40, initially maximum element is 5, but here in a of 1, maximum element is 40. If 40 is greater than 5, then maximum element is equal to a of I. So now we need to replace this 5 with 40. And similarly, if a of I less than minimum, then minimum element is equal to a of I. If you consider this at last, here minimum element is 5 and a of I is nothing but value which is present in index number 7, that is 1. This 1 is less than 5. So we need to replace minimum element as 1. This is an algorithm in order to find maximum and minimum element in given list. At last you need to close these brackets. Next topic is bubble sort, insertion sort and selection sort. I will explain both algorithm and example, and also I will explain difference between insertion sort and selection sort. At first I will explain what is bubble sort. Before that, you need to know what is meaning of sorting. Sorting is the process of arranging elements either in ascending order or descending order. Here they give an array of elements which are not arranged in particular order. So we call it as unsorted array. After arranging these elements in ascending order, that is from small to big, it forms sorted array. Now I will explain what is bubble sort algorithm. Bubble sort is the simplest sorting algorithm that works by repeatedly swapping the adjacent elements if they are in wrong order. I will give one example. Here this is unsorted array where elements are not arranged in proper order. Now we need to sort this array by using bubble sort. We must start from first position and we need to keep on checking whether elements are in proper order or not. First element is 3 and next element is 1. Both are not in proper order because 1 must be first and after 1 there should be 3. Definition of bubble sort is we need to swap adjacent elements if they are in wrong order. So adjacent element of 3 is 1. Now we need to swap this 3 and 1. After swapping, my array look like this. We need to swap 3 and 1. So after performing swapping, my array look like this 1 3 5 4. Still my array is not sorted because 4 must be here and 5 must be here. So again we need to swap these adjacent elements. After performing swapping, my array look like this 3 swap 4 and 5. Now my array is in sorted manner. This is how we sort elements by using bubble sort. This is an unsorted array. Now we need to sort this array by using bubble sort. We should start from first element and then we should keep on checking each and every element whether these elements are in correct position or not. So write same as it is 5, 1, 4, 2 and 8. Now place cursor to first position. First element is 5 and next move cursor to next position. Next element is 1. These both are not in proper order because 1 must be first and after 1 there should be 5. So these both are in wrong order. So swap these adjacent elements. Adjacent element of 5 is 1. So we will swap this both 1, 5, 4, 2 and 8. My cursor is here. Now move cursor 1 position forward. So I am placing cursor here. Here this 5 and 4 both are in wrong position because 4 should be first and after 4 there should be 5. So again swap this both adjacent elements. So after swapping, my array look like this 1, 4, 5, 2, 8. My cursor is here. Now move cursor 1 position forward and compare this both 5 and 2. 2 should be first and after 2 there should be 5. So again swap this 5 and 2. Swap this adjacent elements. So after swapping, my array look like this 1, 4, 2, 5, 8. Now my cursor is here and move cursor to next position. So my cursor reach to last position. 5 and 8 both are in correct order. So there is no need of swapping. Here cursor reached to last position but elements are not in proper order. That is still it is unsorted array. So consider it as first pass and we need to start second pass. And again we should keep on sorting the elements. This is second pass. Write these elements here 1, 4, 2, 5, 8. 1, 4, 2, 5, 8. Again we should start sorting from first. Move cursor to next position. 1 and 4 both are in correct order. So again move cursor to third position. Here 2 should be here and 4 should be here. So exchange this both adjacent elements. After sorting, my array look like this 1, 2, 4, 5 and 8. Now all these elements are in ascending order, that is from small to big. So we can stop sorting. Now this is considered as sorted array because all these elements are in proper order. Sorted array. This is how we perform sorting by using bubble sort. Guys, roughly I explained, but you need to write this in step by step manner like this. Actually after performing swapping, my cursor is here. So you need to perform checking until last element. So again move cursor here and again take another step 1, 2, 4, 5, 8. From 8 you need to move cursor here. Whenever this cursor is reached to last position, then you need to check these elements whether these elements are in correct position or not. This is how we perform bubble sort. I will explain algorithm of bubble sort. This is an algorithm for bubble sort. Step 1 is start bubble sort of array because we are performing bubble sort on array of elements. So here step 1 is start bubble sort array, and next step is if array I is greater than array I plus 1, swap array I comma array I plus 1. That means if first element is greater than next element, then we need to swap this both elements. This is meaning of this step. If you consider this example, here first element is 5 and next element is 1. this 5 is greater than 1 because actually 1 should be first and after 1 there should be 5. These both are in wrong position. So we need to interchange these both elements. We need to perform this step for all the elements present in an array. We need to close this if condition. So step 4 is end if, and after that we need to close this for loop. So step 5 is end for. After that we need to return array, and at last we need to end bubble sort. This is the algorithm for bubble sort. So you need to remember definition of bubble sort, that is we swap adjacent elements if they are in wrong position. Next I will explain what is selection sort. This selection sort algorithm sorts an array by repeatedly finding the minimum element from unsorted part and then putting it at the beginning. This selection sort maintains two arrays. One is sorted array and one is unsorted array. I will give one example so that you can clearly understand how selection sort will work. This is unsorted array. Now we need to sort this array by using selection sort. Selection sort maintains two arrays. One is sorted array and one is unsorted array. So let us consider this as unsorted array because this is not in proper order. So consider it as unsorted array. Selection sort will find minimum element in an array and then it will place this minimum element at the beginning. So minimum element is 2. So 7, 5, 4, 2. Minimum element is 2. So it will keep this 2 at the beginning and move this 7 in place of 2. So 2, 5, 4, 7. Selection sort will find minimum element in an array and it will place this minimum element at the beginning. So after placing minimum element at the beginning, it will consider it as sorted array. So consider this 2 as sorted array, sorted, and consider this remaining 3 as unsorted array. 5, 4, 7. Now again we need to find minimum element from this unsorted array. Minimum element from this unsorted array is 4. So we need to place this 4 at the beginning. So I'm placing this 4 at the beginning and place this 5 in place of 4. 2, 4, 5 and 7. After placing minimum element at the beginning, consider this 4 as sorted array. So we need to write 2, 4. This is sorted array and this is unsorted array. Now again we need to find minimum element from this unsorted array. Minimum element is 5. 5 is already at beginning, so consider it as sorted array. So 2, 4, 5 and it was 7. This is sorted array and this is unsorted array. This 7 is at the beginning, so again move this 7 into this sorted array. All these elements are from small to big, so this is sorted array. This is how we perform sorting by using selection sort. Next I will explain algorithm for selection sort. Here step 1 is start and step 2 is selection sort of array because we are sorting array of elements. So I written here selection sort of array, and step 3 is for all array elements search minimum element and swap element at the beginning and consider it as sorted element. As I already explained in this before example, here smallest element is 2. We will bring 2 at the beginning and then we will maintain this 2 as sorted array, and we need to maintain this process until complete list is sorted. So fifth step is increment minimum to next point and repeat until list is sorted. This is an algorithm for selection sort. This selection sort and bubble sort is not suitable for large size datasets. It is suitable only for small size datasets. Next I will explain what is insertion sort. Insertion sort is simple sorting algorithm that works similar to the way you sort playing cards in your hands. This insertion sort works same like how you sort playing cards in your hands. This is unsorted array. Now we need to sort this array by using insertion sort. At first you need to place cursor at first position. After that move cursor to next position. 7, 3, 5, 4, 2. Move cursor to next position. This insertion sort works same like playing cards. That means this 3 is compared with 7 and this 5 is compared with 3 and 7. 4 is compared with 5, 3, 7 and at last 2 is compared with all these remaining elements. Based on this you need to perform sorting. So whenever you move cursor to element 3, 3 must be here and 7 must be here. So you need to write like 3, 7, 5, 4, 2. Move this cursor next position, that is here. Now again compare this 5 with remaining these 2 elements and arrange these elements in sorted manner. 3, 5, 7, 4, 2. 7, 4, 2. Now again move cursor to one position forward, that is 4. Place cursor at element 4. Now compare this 4 with remaining elements, that is 3, 5, 7. Actually 4 should be placed in between 3 and 5. So arrange this in sorted manner like 3, 4, 5, 7 and 2. At last move cursor one position forward, that is in place of 2. Now 2 is compared with all these remaining elements, that is 3, 4, 5, 7. Actually 2 must be at starting position. So arrange this in sorted manner like 2, 3, 4, 5, 7. Now This is sorted array. Now all these elements are from small to big. Now I will explain algorithm for insertion sort. Here step 1 is start and step 2 is insertion sort of array comma n. That means we are performing insertion sort on n number of elements in an array. And step 3 is from I equal to 1 to n minus 1, that is from starting element to ending element. Pick element array of I, that means we need to pick particular element and then we need to insert that element in sorted sequence, that is like 1 0 1 2 3 so on I minus 1. And last step is stop. Next I will explain difference between insertion sort and selection sort. Definition of insertion sort. Insertion sort is a simple sorting algorithm that builds the final sorted list by transferring one element at a time. And this is definition of selection sort. Selection sort is a simple sorting algorithm that repeatedly searches remaining items to find smallest element and moves it to the correct location. It transfers an element at a time to the partially sorted array, and in selection sort it finds least element and move it accordingly. Insertion sort is more efficient when compared to selection sort, and selection sort is less efficient when compared to insertion sort. Insertion sort is complex than selection sort, and whereas selection sort is simple when compared to insertion sort. Insertion sort is more complex than selection sort, and whereas selection sort is very simple when compared to insertion sort. Best case time complexity of insertion sort is big O of n, and average and worst case time complexity of insertion sort is big O of n square. And whereas best case, average case and worst case time complexity of selection sort is big O of n square. Worst case space complexity of insertion sort is big O of 1, and whereas worst case space complexity of selection sort is big O of 1.
Next topic is various complexities of sorting algorithms, and also I will explain what is divide and conquer strategy and asymptotic notations. At first I will explain various complexities of sorting algorithms. Complexities are classified into two types. One is time complexity and another one is space complexity. Time complexity means amount of time that an algorithm required to complete its task is known as time complexity, and similarly amount of space that an algorithm required is known as space complexity. These are various algorithms and their time complexities and space complexities. We call it as big O, and we call it as theta, and we call it as omega. You need to remember this. Best case time complexity of bubble sort is omega of n, and whereas average case time complexity of bubble sort is theta of n to the power of 2, and similarly worst case time complexity of bubble sort is big O n to the power of 2, and similarly worst case space complexity of bubble sort is big O of 1. Similarly best case time complexity of selection sort is omega n to the power of 2, and similarly best case time complexity of insertion sort is omega of n. Guys, this table is very easy to remember. For all these three sorting algorithms, average case time complexity, worst case time complexity and worst case space complexity is same. Just you need to remember these three. Best case time complexity of linear search and binary search is big O of 1, and best case time complexity and worst case space complexity of linear search and binary search is big O of 1, and average case and worst case time complexity of linear search is big O of n, and average case worst case time complexity of binary search is big O of log n. This is important question. You need to remember this table. Next topic is divide and conquer strategy. What is meaning of strategy? Meaning of strategy is nothing but it is an approach or design to solve a particular problem is known as strategy. For example, if there is a problem in divide and conquer strategy, we will break down this problem into multiple sub problems. For example, this is large problem. I am breaking this large problem into multiple small problems P3, P4 and Pn, and we need to find solution to this each sub problem. This is solution 1, solution 2, solution 3, solution 4, so on, solution n, and at last we need to combine all these solutions of sub problems into single solution. This is known as divide and conquer strategy. In divide and conquer strategy, we divide single large problem. This is single large problem into multiple small sub problems. This large problem is divided into smaller sub problems, and then find solution to each sub problem, and then we are finding solution to each sub problem, and at last we need to combine all these solutions to get solution to main problem. This is known as divide and conquer strategy. Now I will write algorithm for this divide and conquer strategy. Divide and conquer strategy of problem. If problem is small,
then we can write solution directly. Meaning of this is, if problem is small, then we can write solution of this problem directly. Else, if problem is large, then divide problem into multiple subproblems, that is P1, P2, P3, so on, Pn. Apply divide and conquer strategy to P1, subproblem P1, divide and conquer strategy to subproblem P2, so on, divide and conquer strategy of Pn. And similarly after that, after finding solution to these subproblems, we need to combine all the solutions of these subproblems. Combine divide and conquer strategy of P1, that is subproblem P1, P2, so on of Pn. Here close this, and at last close this. This is algorithm for divide and conquer strategy. Next topic is asymptotic notations. By using asymptotic notations, we can calculate time complexity of an algorithm. Time complexity means amount of time taken in order to execute an algorithm is known as time complexity. By using asymptotic notation, we can calculate best case time complexity, average case time complexity, and worst case time complexity of an algorithm. I already explained what is best case, average case, and worst case in previous example, that is in linear search example. If we found an element in first position, then time taken is less, so it is known as best case time complexity. And if element is found in last position, then time taken is more, so it is known as worst case time complexity. And if element is found in between first and last element, then it is known as average case time complexity. Asymptotic notations are classified into 5 types. First one is big O notation. It is denoted by capital O symbol. Second one is big omega notation. Third one is theta notation. Fourth one is little o notation, and at last fifth one is omega notation. I will explain each and every notations in detail. First one is big O notation. It is denoted by capital O symbol. Big O notation is mainly used to represent upper bound of an algorithm's runtime. It is mainly used to represent upper bound of an algorithm. And by using big O notation, we can calculate worst case time complexity of an algorithm. Worst case time complexity means algorithm which takes maximum time for execution is known as worst case time complexity. So by using big O notations, we can calculate maximum amount of time taken by an algorithm for execution. This is known as big O notation. Main use is to calculate worst case time complexity. This is definition of big O notation. Let f of n comma g of n be two non-negative functions. Non-negative is nothing but positive functions. Let f of n, that is function f of n and function g of n, these both are two non-negative functions. Then f of n is equal to O into g of n. Here I took O because big O notation is denoted by capital O symbol. So I took here f of n equal to O into g of n. If there exist two positive constants, that is c and n naught, these both are two positive constants, such that f of n less than or equal to c into g of n for every n greater than n naught. Meaning of this is, condition f of n equal to O into g of n is satisfied if f of n less than or equal to c into g of n for every n greater than n naught. Again I will explain this definition. Let f of n comma g of n be two non-negative functions. Then f of n is equal to O into g of n if there exist two positive constants, that is c and n naught, such that f of n less than or equal to c into g of n for every n greater than n naught. This is graphical representation of big O notations. This is graph in which x-axis represents number of elements, that is denoted by small n symbol, and y-axis represents time. It is denoted by small t symbol. From center there are two lines passing. First line is c into g of n, and whereas second line is f of n. c into g of n should be in upper position because I already explained big O notation is mainly used to represent upper bound of an algorithm. So c into g of n should be in upper position, and whereas f of n should be below c into g of n, that is in lower position. And point at which these two lines meet is known as n naught, where n is greater than n naught. Next I will explain big omega notation.
If you understand this big O notation, remaining all these notations are very easy to understand because all are same as big O notation, only some small changes. Now let me explain big omega notation. Big omega notation is mainly used to represent lower bound of an algorithm runtime, whereas big O notation is used to represent upper bound of an algorithm. But big omega notation is used to represent lower bound of an algorithm. And by using big omega notation, we can calculate best case time complexity of an algorithm. Best case time complexity means minimum amount of time that an algorithm requires for execution is known as best case time complexity, and by using big omega notation we can calculate minimum amount of time that an algorithm requires for execution, whereas big O notation is used to calculate worst case time complexity, but big omega notation is used to calculate best case time complexity. This is definition of big omega notation. Let f of n and g of n be two non-negative functions, then f of n equal to omega of g of n. Here I took omega because this is big omega notation. If there exist two positive constants c and n naught such that f of n is greater than or equal to c into g of n for every n greater than n naught. This definition is same as big O notation, only difference is that here in place of O we used omega and in place of less than or equal to we used greater than or equal to. Only these two difference. Here f of n is greater than or equal to c into g of n because here we are calculating best case time complexity, because big omega notation is used to calculate best case time complexity. So f of n is greater than or equal to c into g of n for every n greater than n naught. This is graphical representation of big omega notation. Here I took graph in which x axis represents number of elements and y axis represent time, and there are two lines passing from center. First line is f of n and whereas second line is c into g of n. Here c into g of n represent lower direction because big omega notation is mainly used to represent lower bound of an algorithm. So c into g of n is lower to f of n, whereas in big O notation I took c into g of n upward because it is used to represent upper bound, whereas in big omega notation it represents lower bound. So I took c into g of n lower to f of n, and point at which these two lines meet is known as n naught, where n is greater than n naught. Third one is theta notation. Theta notation is mainly used to represent average bound of an algorithm, and by using theta notation we can calculate average case time complexity. Average case time complexity means average amount of time that an algorithm requires for execution is known as average case time complexity. By using theta notation we can calculate average case time complexity of an algorithm. This is definition of theta notation. Let f of n comma g of n be two non-negative functions, then f of n equal to theta of g of n. If there exist three positive constants, they are c1, c2 and n naught, such that c1 into g of n less than or equal to f of n less than or equal to c2 into g of n for every n greater than n naught. This is definition of theta notation. Whereas in big O and big omega notations there are only two constants, that is c and n naught, but whereas in theta notation there are three positive constants, they are c1, c2 and n naught. This is graphical representation of theta notation, where there are three lines passing from center, where c1 into g of n less than or equal to f of n, that is lower bound, and whereas if you close this, f of n less than or equal to c2 into g of n, which is an upper bound, and where f of n is placed in between this. Next, little o notation. There is no example and graphical representation of little o notation. There is only definition. Definition is let f of n comma g of n be two non-negative functions, then f of n equal to small o of g of n, because it is little o notation, such that limit n tends to infinity f of n by g of n equal to 0. This is little o notation. And next, fifth one is little omega notation. Definition is same as little o notation. Difference is that here limit n tends to infinity g of n by f of n equal to 0.